Welcome to part 2 of the CSS Full Course. Let's get straight back to it and continue learning more about Flexbox. It's now time to master one of the most common tasks in layout design, horizontally and vertically centering.
We'll be discussing centering with Flexbox, the different horizontal centering methods, the different vertical centering methods, and traditional centering methods versus Flexbox. Now this chapter is getting my more difficult stem. When I first started out, I found it a bit conceptually difficult to know when to apply different centering methods. So hopefully in this chapter, I've done a good job for you in setting out all the different ways we can center elements and the best use cases for each.
Now, as a heads up, this chapter is one of the longer ones, as I do go into a lot of detail, but it is my goal that you walk away confident with centering in CSS.
So let's first talk about centering in the context of Flexbox. Flexbox offers a modern and flexible approach to centering items vertically and horizontally. Looking at this page over here, we have a hero section which would all be inside a Flex container. Our Flex items would be the heading, the paragraph text, and the two buttons. Our main axis is in column running from top to bottom, which means our cross-axis is running from left to right. Using Flexbox allows us to easily center our items horizontally along the cross-axis. So I'm on this page we just looked at. I'm going to open up DevTools. I'm going to select the hero section. You can see that this is a Flex container. You can see the Flex direction is set to column, which means the main axis is running from top to bottom. So our cross-axis is running left to right. And the Align Items property center is being used to horizontally center these Flex items. If I turn this off, you'll see they move to the left. So here's an example of Flexbox allowing us to center items very simply. Looking at another example, we have these cards over here. At the top of the card is an image, and this image sits inside a Flex container, where the image is the Flex item in green. Our main axis runs from left to right, our cross-axis from top to bottom, and we're using Flexbox to both easily center this image vertically, as well as centering it horizontally. So I'm on the same page as before. I'm just going to scroll down to that section. So you can see over here, that image we just looked at. I'm going to select it. You can see it's inside a Flex container over here, and you can see both Justify Content and Align Item Center have been applied. I'll turn Justify Content Center off. Again, our main axis is running from left to right. So if I turn this off, you'll see it moves to the left, or Flex Start by default. And for Align Item Center, if I turn that off, you'll see by default, our image stretches because the default value of Align Items is stretch. Because the Flex container has a height set of 240 pixels, we can center the image. As you can see, there's space above and below for the image to move. So Flexbox offers a really neat way to center items horizontally or vertically, and horizontally and vertically. So I'm now going to be taking a detailed look at all the different methods available to us for centering elements. We're going to start by looking at horizontally centering a container. Now there are two methods available to us for centering elements. The first is using box model properties, where margin can be applied left and right to horizontally center child containers. To achieve this, we'd use the margin property, set the top and bottom value to 0, and the left and right value to auto. In diagram form, we'd have our browser, we'd have a parent container shown in purple, and our child container would nicely be centered inside the parent container, with equal margin applied left and right. It's important to note that the margin property is applied on the child container. So let's play around with this inside VS Code. So I've gone ahead and created an index.html file and linked a style sheet which is currently empty. What I'm going to do in the HTML is add a div. I'm going to give this a class of parent container, and I'll add another div and give this the class of child container. Inside this div, I'm also just going to go add some lorem text, just so we have some content. We'll head over to app.css. I'm first going to use the Universal Selector to just reset all the box model properties. I'll add a padding of 0 and a margin of 0. Next up, I'm going to select the parent container. And just so we can see it, I'm going to give it a background color of light blue. I'll select the child container. I'll give it a background color of blue. Let's give it a height of 300 pixels and a width of 300 pixels. So let's check this out so far in the browser. So you can see in blue here, our child container, which is inside our parent container in light blue. So using box model properties, let's go center this horizontally. As we saw earlier, we'll add a margin we'll set the top and bottom value to 0 and the left and right value to auto. Let's refresh. And you can see this nicely centers our child container inside our parent container with equal spacing applied left and right. So let's now see how we can achieve the same thing using Flexbox. Flexbox properties make it simple to horizontally center flex items. We can use the justify content center property when our main axis is in row. Remember, by default, our main axis is in row, which is horizontal, so we can apply justify content center. But if we've shifted our main axis, so that's in column, we'd have to use align item center to horizontally center our flex item. So align item center is when our main axis is in column. Looking at this in diagram form, we have our browser, our flex container, our flex item. For this demonstration, I am going to put our main axis into column so that our main axis is running from top to bottom and our cross axis is running from left to right. So to horizontally center our flex item, we would apply align item center as our main axis is in column. And align items is for centering along our cross axis, which is going horizontal. Now this works even when our flex container doesn't have a set width. And that's because the flex container is most likely a block element, which by default will extend the full width of the page. So even if there is no width set on the flex container, it will have width, which means that there's space horizontally for the flex item to move. It's also important to note that the Flexbox properties, justify content and align items, are applied on the flex container. This is different to the box model, where margin was applied on the child container. So let's play around with this inside VS Code. So I'm back inside app.css. I'm going to just comment margin 0 auto out. I'll refresh, and our child container moves back to the left. So let's go use Flexbox to center our child item. We do that by going onto the parent container. We give it the display property with the value flex. For this demonstration, I'm going to change our flex direction to column, which means our main axis is now running from top to bottom, and our cross axis is running from left to right. So to horizontally center our flex item, we're going to grab the align items property and set its value to center. I'll refresh, and you'll see our child item centers horizontally inside our flex container. And once again, this works because our parent container has width, which is currently the width of the browser. If I click on the parent container, you see it currently has a width of around 1100 pixels. So because the container has width, there is space for our flex item to move horizontally. So let's now continue our discussion of horizontal centering by looking at horizontal centering content inside a container. Looking at the box model first, using padding to create internal space left and right gives the illusion that content inside a container is centered. So we could use the property padding, set the top and bottom value to 0, and the left and right value to something like 200 pixels. Looking at this in diagram form, we have our browser, our parent container, our child container, and applying a padding value of 200 pixels left and right would add on extra space like this on the left and right of the child element. This would effectively give the illusion that the content inside the child container has been centered, especially if there's something like background color applied on the child container, as background color will both be applied on the content itself and any padding. The padding property is applied on the child container. So let's play around with this inside VS Code. So I'm back inside app.css. I'm going to just go comment out all the Flexbox stuff, and I want to uncomment out margin. So now we're back to horizontally centering our entire child container using box model properties. Let's now go add some padding. I'm going to give it a value of 0, top and bottom, and 200 pixels left and right. I'll refresh, and you can see by adding padding left and right, it gives the illusion that our content is centered inside the child container. If I open up DevTools and select the element and go down to the box model, you can see our child container is here with the content inside, and padding of 200 pixels has been applied left and right. I've just kept margin here to keep the whole thing centered, and let me just comment that out. And ignoring the parent container for a second, you can see on the child container, it still appears as if our content has been centered inside the blue box. So looking now at Flexbox, box model properties still apply on flex items, so padding still can be used to create internal horizontal space. So in terms of horizontally centering content inside a container, we can still use the padding property from the box model. Looking in diagram form, we have our browser, our flex container, our flex item, our main axis running top to bottom, our cross axis running left to right, and padding is simply just applied onto the flex item, creating internal horizontal space. And like with the box model, the padding is applied on the flex item, that is, the child container. So when adding padding, what effectively is happening is that the content inside the container is centered. So unlike before, where we were centering the actual container using margin or flexbox properties, we're just using padding to create extra space, which gives the illusion that our element is being centered. So let's go play around with this inside VS Code. So I'm just going to comment out the box model properties on the child container, and I'm going to uncomment out the flex properties. This gives us our flex item in blue, horizontally centered inside our parent container. I'm now going to come and uncomment the padding property. I'll refresh,
And you can see padding has been applied onto our flex item.
again giving the illusion like the content inside of it has been centered. So let's now continue our discussion by looking at vertically centering a container. For this to work, our parent container has to have a set height. Now, when we looked at horizontally centering a container, I stressed the idea that this works because the parent container does have a width, as block elements extend the full width of the page. Looking now vertically, if we don't set a height on our parent container, it means that the height of the parent container is being set by the height of the child container, which means that there's no space for our child container to move vertically. So looking first at how we can achieve this with box model, there actually is no easy way to vertically center a child container inside a parent container with a set height. So we have our browser, our parent container, our child container. Our parent container has a set height, and there is no easy way to vertically center the child container inside a parent container with a set height. So let's now look at Flexbox. Flexbox properties make it simple to vertically center flex items when the parent container has a set height. We would use align item center when the main axis is in row. If the main axis is in row, it means our cross axis is in column, and the cross axis is how we vertically center. And we know that align items is used on the cross axis. We would use justify content center if the main axis is in column. We know that justify content is used on the main axis, and if the main axis is in column, which is vertical, we would use justify content to center it. Looking at this in diagram form, we have our browser, our flex container, our flex item. Following on from the diagrams we've looked at before, we put our main axis in column, so it's going from top to bottom, which means our cross axis is going from left to right. As our flex container has a set height, we can easily use the justify content center property to center this along the main axis, which in this setup is responsible for vertical positioning, as our main axis is running from top to bottom. And just like we saw before, our flex properties are applied on the flex container. Now by doing this, the actual container is centered. It's not like we're using padding to create the illusion the child container is centered. It is actually centered inside the parent container. So let's go check this out in VS Code. Okay, so this is where we left off. I'm just going to go remove the padding for now. I'll refresh. And as I mentioned, for this to work, we need our parent container to have a set height, which needs to be more than the height of the child container, which is currently 300 pixels. So let's go give our parent container a height of 800 pixels. I'll refresh, and you can see now there is now vertical space for our flex item to move up and down. As we know, the flex direction is column, which means our main axis is running from top to bottom. So we're going to use the property justify content and set its value to center. And this centers our flex item vertically. It's also centered horizontally because before we had align items set to center. So this is a good example of centering a flex item both horizontally and vertically using align item center and justify content center. And very importantly, for this to work, our parent container has to have a height bigger than the height of the child container, so there is space for the flex item to move vertically. We don't need a set width on the parent container, because for a block element like a div, it will extend the full width of the page, so it has a width. So let's now look at the final case of vertical centering content inside a container. This is used when the parent container has no set height. So before, our parent container had set height. Now our parent container doesn't have set height. Looking at the box model, padding can be applied to the top and bottom of the child container. So it's the exact same as the horizontal centering content inside a container we looked at earlier. But now we're just applying padding to the top and bottom. We would apply a property like padding with a top and bottom value set to 200 pixels and the left and right values set to 0. Looking at this in diagram form, we have our browser, our parent container, our child container, and because our top and bottom value of padding is 200 pixels, there's 200 pixels being applied above our child container and below our child container. Now you will note the child container is also centered horizontal, so there's also padding applied left and right. On the slides, I just want to focus on the padding applied top and bottom. And just like with horizontal padding, the padding property is applied on the child container. So let's go play around with this inside VS Code. So I'm going to go comment out our Flexbox properties, and I'm also going to comment out the height, as we want to be looking at a parent container which has no height. I'm now going to add back in our margin and padding properties from earlier. So I'll refresh, and we're back to the situation where our content has padding, giving the illusion that it's horizontally centered, and our entire content container has been centered inside the parent container. So all I'm going to do is change the 0 value here, which is currently controlling padding applied top and bottom, to now have a value of 200 pixels. I'll refresh, and you'll see our element now appears to be centered left and right and top and bottom. I'll open up DevTools. I'll select the child container, and you can see the child container in here with padding of 200 pixels all the way around. So let's now look at Flexbox. Now, because the parent container has no height, we can't use Flexbox properties like justify content and align items. But box model properties still apply on flex items, so padding can be used to create internal vertical space. So again, we'd apply a property like padding with the value of 200 pixels top and bottom and 0 left and right. In diagram form, we have our browser, our flex container, our flex item, our main axis is running from top to bottom, our cross axis from left to right, and by applying padding, we've effectively created internal space between the child container and the parent container of 200 pixels, both top and bottom. And the padding value is applied on the flex item. Now, both these methods is when content inside the container is centered. This is different to what we looked at before with vertical centering using align items and justify content, because in those cases, the actual container is being centered inside the parent. Using padding just creates internal space, effectively centering the content, and ultimately giving the illusion that the container has been centered. So let's play around with this inside VS Code. So I'm just going to comment out the box model properties, and I'm going to go uncomment the Flexbox properties. I'll refresh, and we're back to having our flex item horizontally centered. Just to build this up slowly again, let's go add padding of 0, top and bottom, and 200 pixels left and right. I'll refresh. This creates internal horizontal space left and right of our child container. Let's now go update the top and bottom value from 0 to 200 pixels. I'll refresh, and you'll see now that our child container appears to be centered vertically. Opening up DevTools, selecting the child container, I'll zoom out a bit, and you can see our child container now appears to be centered both horizontally and vertically. All right, that was a lot to take in. I'm sure you're feeling pretty overwhelmed with the different methods of centering available to us. So let's now go through each of them one by one and start gaining some centering guidance so we can get a better idea which methods are used where. To do this, I'm going to slowly start building up this table where I've got the columns box model and flexbox next to each other. And for the rows, I'm going to be going through the 4 different cases we looked at. We'll first start with horizontally centering a container. This is when we're actually centering the child container horizontally within the parent container. With box model properties, we achieve that by applying a margin of 0 top and bottom and auto left and right, which centers the child container inside the parent container. This method is used to center main page containers and sometimes regular content containers. So let's now take a look at some examples of this by looking at horizontal centering guidance. Margin is often used to establish a web page's main container, as it is a simple method for horizontal centering. Looking at this page here, as we know, our entire page is wrapped by a body tag in HTML. All the content we see on the page would be wrapped within a main container, which would often just be a div tag. To center the main container, we would use the margin property. So this is a common example of where we would use margin to horizontally center a child container. That is, the main container of a web page. Let's check out this page in DevTools. All right, so I'm going to go open up DevTools. And you can see over here, we have a div with the class hero container. I'll click it, and you can see in orange, left and right, that margin has been applied. Let's scroll down to the box model, where we can see currently a margin of 253 pixels has been applied left and right, which horizontally centers all the content within the page. If I scroll up, we can see margin left of auto and margin right of auto has been applied. This is the same thing as doing margin 0 top and bottom and auto left and right. They've just done it as two separate declarations. And just to show you that this is in fact centering all the content, if I turn them both off, you'll see all the content moves to the left. So using margin is a very common approach to horizontally centering your entire page. Now, using margin to horizontally center is also sometimes used for regular content containers. For example, on this page, we have our body tag, we have our main container, which we've seen is centered by using margin, but we can also use margin a second time inside the main container to center elements like this card. This card, which is a content container, would be inside something like a div, and the margin property is being applied both to the main container and to the content container. So let's go check this out. So I'm on this page, I'll open up DevTools. I'm going to select the main container over here. Going down to the box model, you can see it currently has a margin of 160 pixels left and right. And this establishes the main page container. That is, the wrapper around all the content on the page. If I go select this card, you'll see it too has margin applied left and right, effectively centering the entire card. And you can see the margin property over here is actually one of the uncommon ones used, where 4 rems has been applied to the top, auto has been applied left and right, and 2 rems has been applied on the bottom. So this is an example of using margin twice, on the main page container and also on a regular content container like a card. So let's now take a look at guidance on horizontally centering a container using Flexbox. As we've seen from the demonstrations earlier, depending on the orientation of the main axis, we can use Justify Content Center or Align Item Center. Flexbox is used to horizontally center regular content containers. Now, I know we just looked at centering a regular content container using margin, but using Flexbox is a lot more common, because Flexbox is a much more powerful way of handling alignment and spacing of items, which you just can't achieve with margin. So continuing on with our horizontal centering guidance, Flexbox properties make it simple to horizontally center regular content containers. Looking at this example, this hero section would be inside a Flex container. We have our Flex items, which are the heading, this paragraph text, and the 2 buttons.
Our main axis would be in column, going from top to bottom.
And our cross-axis would be going left to right. Because our cross-axis is horizontal, we would use the Align Items property to center our Flex items horizontally. So using Flexbox on regular content containers, like inside this hero section, is very common. Let's go check out this page. I'll open up DevTools. I'll select the container, which you can see is a Flexbox. You can see the flex direction is set to column, so our main axis is going top to bottom, and Align Items is set to center. I'll turn this off, and you can see some of our elements go to the left. So by applying Align Item Center, we're centering all of our Flex items horizontally. I'm going to scroll down the page to show you another example of where Flexbox is used on a regular content container. We saw this example earlier with these images. I'll open up DevTools, select the container. So you can see we have our Flex container. In this case, our main axis is going from left to right. So Justify Content Center is being used to center the image inside the Flex container. So long story short, Flexbox is a very common method used for centering items inside a regular container, and is much more commonly used than what we saw just before, where margin was used to center this regular content container. So continuing to add to our table, let's now look at horizontally centering content inside a container. To do this, we use the padding property, where we can set 0 for top and bottom and something like 200 pixels for left and right. This is used for creating equal horizontal space around content inside a container. Once again, the content is not actually centered, but extra space is now around the content, giving the illusion that it looks centered. And because box model properties work on Flex containers, this is both a method we can use on regular div containers and Flex containers. So padding is used to create equal internal space left and right around containers like cards and elements like anchor tags. Let's see this in action on this page here. This content, the heading, paragraph, and anchor tags, are all contained inside a div. It's a regular content container. Now, to create horizontal space around this content, padding has been applied. So it gives the illusion that this content has been centered. The same thing is happening with the buttons. I'll zoom in. We have our anchor tags, which are in red. And again, some horizontal padding has been applied to give the illusion that the content, the anchor tag, is being centered. So let's check this out in the browser. So I'll open up DevTools. Let's first look at this content container. You can see over here, it's just a regular div. There's no flex, so this isn't a flex container. It's a regular div. But you can see straight away all the green around it. I'll scroll down to the box model. You can see the content and the 64 pixel padding that's been applied left and right to create horizontal spacing. You can see the padding property here of 4 rems is being applied to all 4 sides. Let's go check out the anchor tag. Scrolling down to the box model, you can see the anchor tag over here in blue and the padding of 15 pixels left and right. Once again, the content has been centered, and because of the padding, it appears as if the anchor text has been centered left and right. So let's now look at how we can use padding inside Flexbox. Padding can be used to create equal internal space left and right on Flex containers. Looking at an example, we have all this content inside a Flex container, and because box model properties still apply, we can add padding left and right to give the illusion that this content has been centered. Let's go check this page out. I'll open up DevTools. I'll select the container. You can see over here the word flex. So this is a flex container. And you can see looking at box model properties, 60 pixels of padding has been applied left and right. So padding can be applied to regular div containers or flex containers. Again, giving the illusion that the content has been centered. So once again, we're not actually centering the content. We're just applying some padding to make it look centered. This is very different to what we looked at before, where in this flex container, we actually are centering the flex items using the align items property. So let's now start looking at centering guidance for vertical containers. We'll first be looking at vertically centering a container. If you recall, this is the case when our container had a set height on it. We saw that trying to use box model properties, there is no easy way to achieve this. With Flexbox, we can use justify content center or align item center, depending on the orientation of the main axis. And this method is used to vertically center regular content containers. So let's take a look in detail at the vertical centering guidance. Flexbox properties are often used to vertically center UI elements inside a Flex container that has a set height. Looking at this page, I'm going to zoom into the icons towards the left of the page. Looking at the middle icon, all of this content would be inside a Flex container. Our Flex item is the icon itself. The main axis is in row going from left to right, the cross axis in column going from top to bottom, and the container has a set height. This easily allows us to vertically center this icon using Flexbox properties. So let's check this out in the browser. So I'm going to open up DevTools. I'm going to select this Flex container. You can see Flexbox has been activated. And if I open up the div, you can see there's one Flex item, which is just the SVG, the icon. Looking at the container properties, because there's no Flex direction property set, it means our main axis is horizontal and our cross axis is vertical. This means that align item center is controlling the vertical alignment of our SVG. If I turn that off, you'll see the SVG moves to the top. So align items is vertically centering the Flex item, which is the icon, inside the Flex container. And the Flex container has a set height of 48 pixels. And if I hover over the icon, you can see it has a height of 25 pixels. This means that there's space for the icon to move up and down. This Flex item is actually being both horizontally and vertically centered. Justify Content Center is centering the Flex item horizontally. If I turn that off, you'll see it moves to the left. And turning Align Items off moves the Flex item to the top. So you can see when our container has a set height, it's very easy to vertically and horizontally center the Flex item with Flexbox properties. So let's now look at the last case, which is vertically centering content inside a container. For both box model and Flexbox, we use the padding property, where we would set a value like 200 pixels, top and bottom, and 0 left and right. This is used for creating equal vertical space around content inside a container. Now, just like horizontally centering content inside a container, we are once again adding internal space to give the illusion that the content has been centered. We're not actually centering the content or container, like we just saw with Flexbox properties justify content and align items. So padding is used to create equal internal space, top and bottom, around containers like cards and elements like anchor tags. Looking at the same page we looked at earlier when we spoke about horizontally centering content inside a container, we have our container around all the content, and padding has been applied top and bottom. If I zoom in on the anchor tags, the content is the anchor tag itself, and padding again has been applied top and bottom. So let's check out this page again in the browser. So I'm going to open up DevTools. I'm going to select the container. Once again, you can see it's a div. There is no flex, so it's just a regular content container. If I scroll down, you can see padding of 64 pixels has been applied top and bottom, as well as left and right. So it appears that this content is vertically centered, but in actual fact, we've just created internal space using padding. If I click the anchor tag, you can also see once again, padding has been applied top and bottom and left and right. So this is fairly common, applying padding to elements or containers, both horizontally and vertically, to create internal space to improve the visual aesthetic of the element or container. Now padding can also be used to create equal internal space, top and bottom, on flex containers. Looking at this page once again, we have our flex container wrapping all the content, and padding has been applied top and bottom to create internal space to give the illusion that this regular content container has been centered. Looking at this inside the browser, let's open up DevTools. I'll select the container, which you can see is a flex container, and scrolling down on the box model, you can see padding of 40 pixels has been applied top and bottom. And as we saw earlier in this example, padding of 60 pixels has been applied left and right. Once again, creating internal space to give the illusion that this regular content container has been centered. So let's wrap up by finishing off the summary card, gap, nested flexbox, and centering. In this chapter, we looked at centering. I'm going to be summarizing this all inside this table, where we have our methods for centering, box model and flexbox in the columns, and our rows are the different cases. Looking at horizontally centering container using the box model, we achieve this with margin, setting 0 top and bottom, and auto left and right. We have our browser, our parent container, and our child container, which is horizontally centered because of the auto value left and right. For flexbox, we can use the flexbox property justify content center. This would be used where inside our browser, we have a flex container, our flex item, our main axis in row running from left to right, and our cross axis going from top to bottom. Justify content with the value center is used in this case because our main axis is horizontal. If our main axis had been shifted so that it was in column, you would use align item center. Moving on to horizontal centering content inside a container, we would use padding, would set 0 top and bottom, and a value like 200 pixels left and right. We have our browser, our parent container, and our child container. Adding padding left and right creates internal space, giving the illusion that the content inside the container has been centered. And we saw this was commonly used on elements like cards and anchor tags. Because box model properties can apply on flex containers and flex children, we can do the exact same thing. Apply a padding like this. We have our browser, our flex container, our flex child. Again, our main axis is in row, and our cross axis is going top to bottom. Applying the padding creates internal space left and right on the child container, giving the illusion that the content inside the flex item has been centered. Moving on to the next case, where we're vertically centering a container. And if you remember, this is when the parent had a set height. Using box model properties, there is no easy way to achieve this. With Flexbox, for our setup, where our main axis is in row and our cross axis is going from top to bottom, we would use the align item center property. We have our browser, our flex container, which has a set height, and our flex item will be centered. Our main axis running left to right, and our cross axis running top to bottom. And because align items is used for positioning flex items along the cross axis, it's horizontally centered as the cross axis is vertical. The last case is vertically centering content inside a container. And this is commonly used when the parent has no height. On a standard container or element, we would apply padding like this, where a value like 200 pixels has been applied top and bottom. We have our browser, our parent container, and our child container, which has padding applied above and below, giving the illusion that the content inside the child container has been centered. We can also apply padding on a flex container or flex item. So we'd apply padding the same way we just did. We have our browser, our flex container, our flex item, where the main axis is in row, the column axis is top to bottom, and applying the padding would create internal space above and below the flex item, giving the illusion that the content inside the container is centered. Now, I know this was a lot to take in, but I do hope I have provided a comprehensive overview of how elements and containers are centered in CSS. So let's now go look at applying different centering methods on our Quill homepage. Earlier on in the course, in the box model topic, we already set up the main container using margin. We have our body tag in red, and we have a main container shown in blue containing all the content, and we're using margin to horizontally center this container. Let's check this out inside VS Code. So you can see in our CSS file, we have this container where we're using margin, 0, and auto left and right to horizontally center all our content. Let's check this out in DevTools. I'll select this div where the class container is being applied, scroll down to the box model, and you can see margin has been applied left and right with those orange lines horizontally centering our entire container. And as we saw in the guidance, this is a very common practice, using margin to horizontally center your main container. Let's now go see how we can use Flexbox in two other places on our page for centering. We're going to be using Flexbox on our hero section. We're going to be converting the entire hero section into a flex container. This flex container actually has a height set. We did this earlier in the units topic, where the hero section is using view height units, so it always appears above the fold in your browser. The flex items inside this flex container will be the heading, the paragraph, and the anchor tags. To ensure these flex items stack vertically, we need our main axis to run from top to bottom, that is, in column. We'll then use the justify content property to vertically center our flex items inside the flex container. Our cross axis is running from left to right, which means that we can use the align items property to horizontally center our flex items. So let's go do this inside VS Code. I'm going to scroll down to the hero section in our CSS file, and just a quick recap on the current setup of this. I'm going to open up DevTools, and I'm going to select the hero section. As I mentioned earlier, the hero section has a set height, which is 100 view height units, minus the height of the navigation bar. If I scroll down in DevTools to the box model, you can see at the moment the height is 939 pixels. And if I reduce the height of my browser, the height of the hero section would reduce. Now, the main takeaway point here is that our hero section does have height, which means that we can easily vertically center our flex items, which is the heading, the paragraph, and the grouped anchor tags inside this unordered list. So let's go to our hero section. Let's convert the entire hero section into a flex container. So we'll add display flex. I'll refresh, and you can see our flex items are now next to each other because the main axis is running from left to right. Let's shift the main axis so it goes from top to bottom. We'll grab flex direction and set its value to column. I'll refresh. You can see we're back to where we started, but this is now a flex container with flex items. Let's first vertically center our flex items using the justify content property. We're using justify content because our main axis is running from top to bottom. So we'll set justify content to center. I'll refresh, and now finally, our flex items are beautifully centered inside our hero section. Let's open up DevTools to check this. So you can see when I hover over the hero section, it's now a flex container, and the flex items are nicely vertically centered. So let's now go handle horizontally centering. Now, if you look at the page, it does look like it is horizontally centered. And that's being handled because we have text align center applied on the hero section. Looking at our HTML markup here, because text align center is applied on this parent, the hero section, the H1 and paragraph are effectively inheriting that property, so they're centering. The unordered list inherits text align, the list inherits text align, and because the list is acting as a parent container for our anchor tag, text align is causing this anchor tag to center. We've seen this many times before in the course, where both block and inline elements will center when text align is applied to a parent container. In this case, text align is on the list item, which is the parent of the anchor tag. So because there's space to move, shown in blue above on the page, the anchor tag is able to center. So long story short, text align, because it's applied on the hero section, is centering the text of block elements and is also centering inline elements. Now, I spoke earlier in this topic that we don't really want to be using text-align center as a method for centering things inside Flexbox. So for now, I'm just going to go comment it out, and you'll see our flex items now move to the left of the page. So let's go center them properly using the align items property and setting its value to center. I'll refresh, and you'll see they once again are centered, but this is using the correct method of Flexbox properties. Now, one thing you'll notice is our heading looks a bit weird now. That's because in our markup, in the hero section, we're using this BR tag to force digital world onto its own line. So if I select the heading, you can see the blue box is the heading element. And by default, if we use a line break tag, any new words will always be left align. So we actually do want to use text align center on this property to center any text in this heading. So heading back to app.css, I'm just going to copy this text align center. I'm going to remove it from the hero section. So I'll paste in the text align center. I'll uncomment it and refresh. So now our text for the heading has been centered again. Now you might be thinking, why didn't I just use text align center on the hero section and kept it how it was? This seemed like a lot of extra work just to get back to the same thing. Now that is not good practice. When we're using a flex container, we want to be using the Flexbox properties to handle spacing and alignment. Now the last thing I want to do here before we finish up the hero section is get these buttons next to each other. Looking at our HTML markup, these buttons are inside this unordered list. So we're now going to be using nested Flexbox, where this flex item, the unordered list, will become its own flex container. Let's first go add a class to this. We'll give it the class name hero btn container. I'll copy this. And then under the hero paragraph, let's go add this. We'll change its display property to flex. I'll refresh. And because this is now a flex container, our flex items, which are the two anchor tags, appear next to each other in row. Let's just go add some gap between them of 2 rems. I'll refresh. And now our anchor tags are next to each other with some space. And just to remind you once again of nested Flexbox, our hero section is the parent flex container. The H1 paragraph and unordered list are the flex items. We've now converted this flex item into its own flex container. And these list items, which hold our anchor tags, are the flex items of this flex container. So here's our parent container, and here's our nested flex container. All right, so I'm going to put the browser full screen so we can see our beautiful work. The top of our page is now complete. It's looking really, really nice, where we've used Flexbox on both the navigation and the hero section for all spacing. Scrolling down, we're going to be handling the layout of this section using CSS Grid in the next topic. Now, in principle, you could use Flexbox, where you could set each feature section to be its own flex container. But CSS Grid is a bit more purpose-built for the layout we want to achieve. I'm going to scroll down. We've also previously in this topic used Flexbox on our navigation bar and nested Flexbox to achieve the layout. Now, I want to finish off with the CTA card at the bottom here. Just as a reminder of how we're doing this. As we know, we have our main container centering all the content on the page. And in the box model topic, we actually centered the CTA card using the same method, where we're applying margin of 0 and auto. We actually saw a case of this in some of the guidance earlier. We have margin 0 auto on the main container, and then on a regular content container, centering it. Now, you can do this. This does work, but I would recommend inside the page using Flexbox as much as possible, because it's just a bit more powerful and a bit more versatile, and is the modern approach for handling layout on pages. So let's now go use Flexbox to center this CTA card instead of margin like we've done here. So we're going to be converting the entire CTA section into a flex container. We will then have one flex item where we currently have a div called CTA card wrapping our heading and anchor tag. Our main axis will be kept in row from left to right, which means our cross axis is running from top to bottom, and we'll then be using the justify content property to horizontally center our flex item. Now, just to note, there's also a lot of padding on the CTA card, which we'll talk about soon. But let's go use Flexbox to center this now. So I'm back inside VS Code. I first want to go recap on the HTML markup. Inside our CTA section, we have the semantic section tag with the class CTA section, and we have this div called CTA card holding the heading and anchor tag. So we're now going to go convert the CTA section into a flex container, which means the CTA card will be the single flex item. Looking at this in DevTools, you can see when I hover over the CTA section, There's space in blue left and right for our flex item, this div, to be centered. So jumping into app.css, let's scroll down to the CTA section. I'm first going to go remove the margin over here, as we don't want to use that anymore. On our CTA section, I'm then going to convert this into a flex container. I'll add display flex and use the justify content value and set it to center. I'll refresh and watch what happens. So our CTA card has been centered using Flexbox now. If I open up DevTools and select the CTA section, you can see those purple dashes and the space left and right where justify content is centering the entire CTA card inside the CTA section. Now, one thing you may have noticed when I did this is that the card actually reduced in width. Just to show you that again, I'm going to comment this out and add back the margin property here. I'll refresh, and you can see the card expanded. Removing it and uncommenting this, I'll refresh, and the card is reducing in width. So what is going on there? Just to confirm, we have achieved what we wanted. The card is centering. But there is some weird stuff going on with the width of the card when we move from margin to center the card to Flexbox. So to explain what's happening, I want to go add margin back onto our CTA card. And I'm just going to comment out the Flexbox properties. I'll refresh. And what's happening is that when you set margin like this, and we have a max width property at play, like we see here, the browser is using this max width of the CTA card to work out the available space to put left and right. Opening up DevTools, if I select the CTA card, you can see it currently has a width of 600 pixels. And when I add on the padding left and right, we get to 600 plus 200 plus 200, which is 1000 pixels. You can see the content inside the CTA card, get started now, and the anchor tag get started doesn't take up the full width of the box. That's because max width is working. There is space inside the actual content container, the div, created by the max width property. So in a nutshell, when using margin like this, the way the browser is calculating the available space to apply left and right is it is looking at this max width property and seeing what remaining space there is left and right to then apply. This is not how Flexbox calculates available space. I'm going to remove this, and I'm going to add back on our Flexbox properties. I'll refresh, and you'll see now our flex item, the CTA card, has a width of only 361 pixels. You can also see now that there is no more available space inside the CTA card content container. The heading Get Started now butts up against the left and right of the box. It's a little bit hard to see because everything's in blue, but you can see when I hover over the content box, there is no more space left and right inside this blue box. So effectively, Flexbox is centering flex items based on the content width, not the maximum width. So that's why our card has reduced in width. In order to fix this, all we need to do is on our CTA card, add in the width property and give it a value of 100%, which effectively forces the CTA card to its maximum width. I'll refresh, and you'll see now the width of our CTA card is back to 600 pixels, and we have padding left and right of 200 pixels, so max width is being used as the width of the CTA card. So just be mindful of the differences of using margin and Flexbox and how the browser calculates available space when a max width property is involved. Now, the last thing I want to comment on is that we are using padding on our CTA card, both top and bottom and left and right, to center the content inside this container to give the illusion that the content is centered.
And we spoke about this method already at length throughout this chapter, where it is common to use padding to give the illusion that content is centered. Moving on, we'll learn how to control the behavior and sizing of individual flex items within a container by learning about the various properties for flex children.
We'll be discussing flex items properties, flex grow, flex shrink, align self, and order. So what are flex item properties about? Flexbox also has properties that control the behavior and positioning of flex items. Looking at our Flexbox diagram, we've seen many times by now, with the flex container, flex items, and main and cross axis. So far in this topic, we've looked at a whole range of properties that apply on the flex container. These include display with the value flex, flex direction, justify content, and line items and gap. And as you know by now, these are all applied on the flex container. But in Flexbox, there are also some properties that can be applied on individual flex items. These include flex basis, flex grow, flex shrink, align self, and order. And in this chapter, we're going to be going through each of these in detail. Now, just as an important note at this point, we will be looking at these properties in detail, and some of them may seem a little bit overwhelming. And I do just want to let you know that the flex container properties we've looked at so far are much more important and are way more commonly used in CSS. However, to complete this topic, you really do need to know about the flex items and how they work so that you can keep them in your back pocket if you need them. So let's start off by looking at flex grow. Flex grow determines how flex items expand to fill extra space in a container based on a set of proportions. The CSS property looks like this: flex-grow with a numerical value like 0. 0 is in fact the default value. That is, the value applied to all flex items if we didn't change the flex grow value. So let's look in diagram form how this works. We have our flex container, and let's say it has a width of 1000 pixels. We have our flex items, and let's say each of them have a width of 100 pixels. The default behavior is that flex items do not expand to fill any available space in the flex container. So in this instance, horizontally inside the container, there's 600 pixels of available space, which is 1000 pixels minus 4 lots of 100 pixels, giving us 600 pixels. So by default, the flex items stay as they are, and any available space will remain as available space. However, we can override this and use the flex grow property, and this calculates how flex items can fill the extra space. So let's see how this works, going through step by step. Items grow based on their flex grow value relative to the total. So let's start with box 1, which is the orange box on the far left. Let's give it a flex grow value of 1. For box 2, which is the second green box, let's give it a flex grow value of 2. For box 3, which is the third blue box, we'll give it a flex grow value of 0, which is just the default value. And for box 4, the fourth yellow box, let's also give it a flex grow value of 0, which again is the default value. So how this works is you would calculate the total flex grow, which is 1 plus 2 plus 0 plus 0, which is 3. So now any available space is distributed based on the flex grow value of a flex item relative to the total. So let's go see how this works. Box 1 effectively gets 1/3 of the remaining space. That is because the flex grow value of box 1 is 1 and the total is 3. So it gets 1 divided 3, or 1/3 of the remaining space. The remaining space is 600 pixels, so 1/3 of 600 pixels is 200 pixels. So our box 1, the orange box, will expand by 200 pixels, which means that the new width of box 1 is its original width, which was 100 pixels plus 200 pixels, giving us a new width of 300 pixels. Now the remaining space has obviously reduced, but we need to keep our eye on the original remaining space when doing these calculations, which is 600 pixels. So let's now take a look at box 2. Box 2 gets 2/3 of the remaining space. And that's because the flex grow value is 2, the total flex grow is 3, so it gets 2/3 of the remaining space, which is 2/3 times 600 pixels, which is 400 pixels, which means that box 2 will grow by 400 pixels to a total width of 500 pixels. Looking at box 3, it gets 0/3 of the remaining space, and that's because its flex grow value is 0. 0/3 times 600 pixels of remaining space is just 0. So box 3 remains its width of 100 pixels. And the same thing happens for box 4. It gets 0/3 of the remaining space because its flex grow value is 0. So it remains at 100 pixels. So you can see how the flex grow value of 0 is just the default value, where by default, our flex items don't grow. So let's go play around with this inside VS Code.
All right, so I've gone ahead and just created a similar setup to what we just saw in the diagram before.
I have a div with the class flex container, and I have 4 flex items, where I've given each flex item the respective class flex item 1, 2, 3, and 4. And I've also just put the numbers 1, 2, 3, and 4 inside the flex items. In app.css, I've just given the body a color of white so we can easily see our numbers on our flex items, and a font size of 30 pixels. And we know this will be inherited by our flex items. For the flex container, I've given it a background color of light gray, a height of 500 pixels, and a width of 1000 pixels. I've also applied the display flex property so that this is a flex container. For each flex item, they all have a width of 100 pixels and a height of 100 pixels, and different background colors, blue, purple, red, and green. So let's check this out in the browser. Okay, so nothing crazy going on. You can see our gray flex container and our 4 flex items. Because the flex container is 1000 pixels wide, and each flex item is 100 pixels wide, the remaining space is 600 pixels. Let's open up DevTools, and you can see this purple hatched box is going to have a width of 600 pixels. And as you'll note, each flex item, by default, doesn't expand to fill this extra space. In the background, they all have a flex grow value of 0. If I set that on item 1 and refresh, you'll see there'll be no change. So let's now go set the flex grow values we did before. We had a flex grow value of 1 on flex item 1, a flex grow value of 2 on item 2, a flex grow value of 0 on item 3, and a flex grow value of 0 on item 4. Now, if you remember, the way flex grow works is it distributes available space onto our flex items. It does this by working out the total of the flex grow, which is 1 plus 2 plus 0 plus 0, which is 3, and then takes the flex grow value, divides it by that total, and multiplies it by the available space. So I'll refresh my browser, and you'll see now flex item 1 has a width of 300 pixels because it's getting 1/3 of the available space, which is 1/3 times 600 pixels, plus the original width of 100 pixels to give us a width of 300 pixels. And you can actually see inside DevTools, the original width has this hatched line, and you have this arrow showing how the flex item has grown by 200 pixels. Flex item 2 now has a total width of 500 pixels, which is 2/3 times 600 pixels, which is 400 pixels, plus the original width of 100 pixels. And flex item 3 and 4 have not grown at all because their flex grow value is 0, and 0 times 600 is 0, so no additional space is added onto flex item 3 or 4. So let's now move on to flex shrink. Flex shrink determines how flex items shrink relative to others in a container where there isn't enough space. So it's kind of the exact opposite of flex grow. The CSS property looks like this, flex-shrink, with a numerical value like 1, where 1 is actually the default value. So let's first take a look at what happens by default when the flex shrink value is 1. We have our flex container with the width of 1000 pixels. We have our 4 flex items, which each have a width of 300 pixels. So 4 times 300 pixels is a total of 1200 pixels, which means that these flex items won't fit inside the flex container. However, what's happening behind the scenes is that these flex items are actually forced inside the container. So their actual width will be 250 pixels. So each flex item has effectively reduced in width by 50 pixels. That's because the amount these flex items would have overflown would have been 200 pixels, and the 200 pixels is divided by 4 to give us 50 pixels. So each of these flex items shrink at the same proportion. And that's because behind the scenes, each flex item has a default value of flex shrink 1. So let's check out this default behavior in VS Code. So I'm back inside the file we were working on earlier. For each flex item, I'm now going to update its width to 300 pixels and remove the flex grow value. I've done it on flex item 1. Let's do it on flex item 2, 3, and 4. I'll refresh. And what you'll see is that we set a width of 300 pixels on our flex items. We have 4 of them, which means the total width of this should be 1200 pixels. And because our flex container has a width of 1000 pixels, we would expect there to be some overflow. If I open up DevTools and check this flex item here, you can see its width is 250 pixels, not 300. And you can actually see on the right, there's an arrow pointing left, showing how much it's shrunk by. Now, because by default, each flex shrink value is 1, so I'm just explicitly setting on flex item 1, but behind the scenes, this is currently set on flex item 2, 3, and 4. It means that each flex item will shrink by the same proportion. As I mentioned, the overflow value would be 1200 pixels minus 1000 pixels, so 200 pixels. That 200 pixels is then just distributed equally to each flex item to absorb that space. So effectively, each flex item reduces in width by 50 pixels, so its new width is 300 pixels minus 50 pixels, which is 250 pixels. We can see here. All right, I'm just going to remove this flex shrink value over there. So now let's see what happens when we change our flex shrink value to 0. We have our flex container with the width of 1000 pixels, and by setting flex shrink to 0 on each flex item means that we've effectively removed this default behavior of flex items shrinking to fit inside the container. So now our flex items will overflow. They will be the width we actually set them, which is 300 pixels, and there's overflow now of 200 pixels. So setting a flex shrink value of 0 means that your flex items don't shrink. Let's check this out in VS Code. So on each flex item, I'm going to add a flex shrink value of 0. And I'll copy this for each flex item. Okay, I'll refresh. I'll zoom out a bit. And you can now see that our flex items are extending beyond the flex container. You can see this hashed purple is the amount we're overflowing by. So let's now go see what happens when we apply different values to flex shrink. We'll be using the same setup we've just looked at. So items shrink based on their flex shrink value relative to the total. So this is kind of similar to flex grow, but it now has to do with shrinking. Let's look at box 1 to start. Let's give it a flex shrink value of 2. Box 2, let's give it a flex shrink value of 6. For box 3, let's give it a flex shrink value of 1, which is the default value. For box 4, let's also give it a flex shrink value of 1. So we now work out the total flex shrink, which is 2 plus 6 plus 1 plus 1, which equals 10. So what this means is that box 1 absorbs 0.2 of the overflow space. That is its own shrink value of 2 divided by the total 10, which is 0.2. The overflow space is 200 pixels. 0.2 times 200 pixels is 40 pixels. So box 1 is going to reduce by 40 pixels. So we have our flex container with the width of 1000 pixels, and box 1 now has a width of 260 pixels, which is 300 pixels minus 40 pixels. For box 2, it's going to absorb 0.6 of the overflow space. 0.6 is from box 2's shrink value of 6 divided the total 10. The overflow space is 200 pixels. 0.6 times 200 pixels is 120 pixels. So box 2 is going to reduce by 120 pixels, which means the new width of box 2 is 180 pixels. That is 300 pixels minus 120 pixels, which is 180 pixels. For box 3, it's going to absorb 0.1 of the overflow space. That is 0.1 times 200 pixels, which is 20 pixels. So the new width of box 3 will be 280 pixels. That is 300 pixels minus 20 pixels. And for box 4, it's the same thing. It absorbs 0.1 of the overflow space, which we know is 20 pixels. So box 4 will now have a width of 280 pixels. So let's go play around with this inside VS Code. So this is where we left off. I'm now going to go give the same flex shrink values we just saw. On flex item 1, that was 2. On flex item 2, that was 6. Flex item 3, it was 1. And flex item 4, that was 1. I'll refresh, and you'll see our flex items have now shrunk in proportion of each flex item's shrink value divided by the total, which in this case was 10. Looking at flex item 1, its new width is 260 pixels. Flex item 2, 180 pixels. Flex item 3, 280 pixels. And flex item 4, 280 pixels. And we just saw earlier how all these widths are calculated. So let's now move on to the next flex item property, which is align self. Align self sets individual flex items alignment by overriding the flex container's default align items value. So let's have a look at this. We have our standard setup of our flex container, flex items, and main and cross axis. So what align self allows us to do is align an individual flex item, like the one in green, along the cross axis. The CSS property looks like this: align-self, and a value like flex end. Let's say that this property is applied on the green flex item.
What this will effectively do is override any aligned items value, which we know is applied on the flex container to all flex items and results in aligning just that flex item.
So we'd end up looking like this, where just the green flex item is positioned flex end. Now currently, our flex items would have a property like align items flex start. That is, they're positioned at the start of the cross axis, but applying align self onto a flex item overrides this for a flex item. So let's check out all the values we can have for align self. The first value is align self auto, and this is just the default value. All this is saying is that if align items has a value, then the flex items will have that same value. Long story short, if you have an align items value, each flex item is just given that value by default, which makes sense. if there is no align items value on the flex container, and our flex items have a fixed height, it just means, by default, our flex items will be at the start of the cross-axis, like we see here. The next value is align self stretch, which when applied to a flex item, will stretch that flex item along the cross-axis. The next value is flex start, which would position an individual flex item at the start of the cross-axis. Now, if no flex items value is on our flex container, then we're not going to see any effect here. But if we did say have flex items set to flex end, we would then see our flex items at the bottom of the cross-axis and a single flex item at the start of the cross-axis. The next value is align self flex end, where we would now see a flex item at the end of the cross-axis. The next value is align self center, which would position an individual flex item in the center of the cross-axis. And to see the last value, I'm going to add the align items value flex end and apply align self baseline. So what we'd end up with is this. We're applying align items flex end, so all our flex items would be at the end of the cross-axis, but then an individual flex item would be positioned baseline. That is, it's positioned on the baseline of its own text, like this. So let's go play around with these inside VS Code. Alright, so I'm back in the file we were working in earlier. For each flex item, I'm just going to go remove the flex shrink value and give it a width of 200 pixels. I'll do this for flex item 1, flex item 2, flex item 3, and flex item 4. So I'll refresh my browser, and our flex items are now back inside our flex container. Now let's quickly recap the setup we have. Our main axis is in row going from left to right, and our cross-axis is going from top to bottom. Because our flex items have a fixed height of 100 pixels, it means that by default, they're just going to be at the top of the flex container. So let's go and apply some align self properties. I'll be doing this all for flex item 2. Let's go apply align self and set its value to auto. I'll refresh, and you'll see nothing happens. This is just taking the align self value set on the flex container, which is not set, so it's just taking the default value of putting it at the start. If I change the flex container's align items value to something like flex end, all our flex items move to the end of the cross-axis. And again, align self auto is effectively just applying flex end onto flex item 2. It's just taking whatever value is being applied on the flex container. I'm actually just going to leave the align items value as flex end now, as it will help me better demonstrate the other properties. Let's change auto to the next value we looked at, which was stretch. I'll refresh, and align self is stretching. Well, it isn't really, but what's happening is that because this has a fixed height, the flex item is unable to stretch, and if that's the case, it'll just move to the top of the flex container. If I comment out the height for a second and refresh, you'll see that the flex item does in fact stretch. Alright, I'm going to uncomment this, and let's look at the next value, which is flex start. I'll refresh, and now flex 2 is actually at the start of the cross-axis. The next value is flex end. I'll refresh, and this is just moving it in the same position as all the other flex items set here. To see the impact of this, let's change this to flex start. I'll refresh, and you can see all our flex items are at the top, where flex item 2 is now at the bottom. Alright, I'm just going to put this back to flex end. The next value we looked at was center, and this will center this flex item along the cross-axis. And for the last value, baseline, to better demonstrate this, I'm going to remove the height on flex item 2, and I'm going to give it a font size of 50 pixels. Let's update the align self to baseline. I'll refresh, and what's happening is that this flex item is positioned according to the baseline of itself, which is just under the 2 here.
So as I mentioned at the start of the chapter,
this can all seem overwhelming, learning all of these new align self values. I really wouldn't worry too much about it. As I've mentioned, aligning flex items on the container with justify content and align items is way more common to do. So let's finally take a look at the last flex item property, which is order. Order changes the visual order of flex items independent of their order in the HTML markup. The CSS property looks like this, order with a numerical value, where 0 is the default value for all flex items. So let's take a look at how this works. We have our flex container and our flex items, where we can see 0 is the default values for all of them. So the way the orange, green, blue, and yellow box are appearing is just the order they appear in the HTML. What we can do is override the order of the flex items no matter what the HTML is. Looking at an example, so what we could do is on our third flex item, the blue box, we could set a value of -1. This would make it come first. Let's leave the green and yellow box, that is the second and fourth box, as 0. So they'll appear like this. The green box first, followed by the yellow box. That is because the green box appears first in the HTML markup before the yellow box. And then we can apply a value of 1 to the first box, which will now be the last flex item. So the order number is moving us from lower order numbers to higher order numbers. And once again, we're completely overriding the position of the flex item as it appears in the HTML. So let's go play around with this inside VS Code. So I've picked up where we left off. I'm just going to go remove this align self value, remove the font size, and uncomment the height. I'll refresh, and let's go play around with order. Let's have our third flex item now appear first. I'll put an order there of -1. For flex item 2 and 4, I'm just going to leave those alone, which means by default, the order value is 0 for 2 and 4. For flex item 1, let's make that come last. So I'm going to go give it an order of 1. I'll refresh, and you can see flex item 3 is now first, as it has the lowest order value. 2 and 4 have an order of 0, so they appear here. And flex item 1 has the highest order value of 1. Now I could change this to something massive, like 99. It doesn't matter. It's just looking at the numbers moving from left to right. And I don't have to use negative numbers. To maintain this order, I could change this to 1. Flex item 2 is in position 2, so let's give it an order of 2. Flex item 4 is in position 3, so let's give it an order of 3. And flex item 1 is in position 4, so let's give it an order of 4. I'll refresh, and you'll see there's no change, as we're moving from 1 to 2 to 3 to 4. The reason I used negative numbers earlier, it's because it allows me not to then put order values on some of the flex items. So sometimes it can be more efficient using negative values and relying on the default value for some of your flex items. So let's wrap up this chapter by building the next summary card, Flex Children. We looked at several Flex Children properties. The first was Flex Grow, which was about how flex items can grow to fill extra space. We looked at an example with a flex container and 4 flex items with equal width. We can also see there's extra space inside the flex container. And by default, the flex items won't expand to fill the extra space. But we can override this using the Flex Grow property. We set a Flex Grow value of 1 on box 1, a Flex Grow value of 2 on box 2, a Flex Grow value of 0 on box 3, and 0 is the default value, meaning it won't grow, and also a Flex Grow value of 0 on box 4. The way it works is the total Flex Grow value is calculated, which is 1 plus 2 plus 0 plus 0,
which equals 3.
The flex items will then fill the extra space like this, where the first flex item gets 1/3 of the extra space. That is its own Flex Grow value, 1 divided by the total, 3. The second flex item gets 2/3 of the extra space, which is its own Flex Grow value of 2 divided by the total of 3. And because box 3 and box 4 both have a Flex Grow value of 0, they won't absorb any extra space, so they remain the same size as they originally were. We then looked at Flex Shrink. This is about how flex items shrink where there isn't space. We looked at an example with the flex container. We saw that by default, the flex shrink value was 1, which means that flex items will by default shrink within the container in the same proportion of any overflow. We saw that we could set the flex shrink value to 0, which would then result in our flex items overflowing, like this. Flex shrink was then the proportion of how each flex item absorbs this overflow space in order to fit inside the container. On the first box, we set a flex shrink value of 2. On the second box, we set a flex shrink value of 6. On the third box, a flex shrink value of 1, which is just the default value. And on box 4, we also set a flex shrink value of 1, which again is the default value. The way flex shrink works is the total flex shrink is calculated, which is 2 plus 6 plus 1 plus 1, which equals 10. And this results in our flex items all fitting within the container like this, where the first box absorbs 0.2 of the overflow space, that is its own flex shrink value of 2 divided by the total of 10. The second box absorbs 0.6 of the overflow space, that is its own flex shrink value of 6 divided by the total of 10. Box 3 then absorbs 0.1 of the overflow space by the same logic, and box 4 also absorbs 0.1 of the overflow space, the exact same as box 3. We then looked at the align self property, which sets individual flex item alignment along the cross-axis, and will override any align items value set on the flex container.
The first value we looked at was align self auto,
which is just the default value, and just takes whatever the value is set for align items. The next value was align self stretch, where you can see the green box has stretched, and this would only work if the green box does not have a set height, but is just content, like some text. We saw align self flex start. To better show this, I've set the align items value to flex end, which means all our flex items will be at the end of the cross-axis, and you can see the green box is at the start of the cross-axis. The next value was align self flex end, and you can see the green box is at the end of the cross-axis. The next value was align self center, where you can see the green box is centered along the cross-axis. And the final value was align self baseline, where when your flex item has some text, it will align according to the baseline of its own text. The last property we looked at was order. This was where we could override the order of our flex items as they appear in the HTML. The property looked like this: order with a numerical value, where 0 is the default. We could then do something like this, where we have a flex item with the order value of -1, the next flex item, the order value 0, the next flex item, the order value 1, and the last flex item with an order value of 2. So the flex items are being ordered from lower value to higher value. And again, this completely overrides the order they appear in the HTML.
In the final chapter, we'll explore how to handle items that don't fit in a row and control their alignment using flex wrap and align content.
We'll be discussing flex items shrinking behavior, flex wrap property, align content property, and align content values. So let's first quickly recap the shrinking behavior of flex items. If flex items are larger than their container, by default, they will shrink to fit inside. We saw this in the previous chapter, where we have a flex shrink value of 1, which is the default value. What this results in is inside our flex container, which let's say is 1000 pixels, our flex items will shrink to fit inside this container. So let's say these flex items are 300 pixels wide. That would mean that the total width of these flex items is 1200 pixels, so we should expect to see overflow. But what's happening is that behind the scenes, our flex items have a flex shrink value of 1, which means that each flex item is absorbing the overflow space. So that 200 pixels is effectively divided by 4, so each flex item will absorb 50 pixels. So the width of the flex items will be 250 pixels. We saw that we could set a flex shrink value of 0, which effectively removes the shrinking behavior. So we end up with our container of 1000 pixels, but now our flex items will be their actual width of 300 pixels, and you can see we now overflow the container. So let's again check this out in VS Code. So I've got a very similar setup to what we saw in the previous chapter. I have a flex container with 4 flex items. Inside app.css, we have our body, where we're applying the color white to our text and a font size of 30 pixels. Our flex container has a background color of light gray, a height of 500 pixels, a width of 1000 pixels, and the display property is set to flex, so that each of our flex items are now in a row. Each flex item is 300 pixels by 100 pixels, and each have a different background color. So the first thing I want to do is just open up DevTools. I'll select our flex item, and you can see in the box model, its actual width is 250 pixels. If I go hover over it, if you remember, we also have that arrow on the right, visually showing how the flex item is shrunk. I'm going to go change the flex shrink value on each flex item to 0 to effectively remove the shrinking behavior. And I'm going to apply this on each of our flex items. I'll refresh, and you can see our flex items now do overflow the container. So when we have this situation of flex items overflowing the flex container, there is something else we can do here, and that's using flex wrap. Flex wrap pushes flex items onto multiple lines instead of being forced to fit on a single line when they exceed the container. The CSS property looks like this, where flex-wrap is the property, and in this case, wrap is the value. It's important to note that flex wrap is set on the flex container. The values we can use include no wrap, wrap, and wrap reverse, where no wrap is the default value. So flex wrap can be used in the specific case when your flex items exceed the container. Like in the demonstration I just showed you in VS Code. That would be an opportunity to use Flex Wrap. Now Flex Wrap works a bit differently if there is height or no height set on the parent container. Let's look at a general block container first. That is, when our Flex container has no set height. The way Flex Wrap works here is that our Flex items will appear next to each other, and to fit the Flex item that is going to wrap onto the next line, the Flex container expands. Looking now at a Flex container with a set height, like this one here, when the Flex items wrap, there's actually a line dividing the Flex container in two, so the rows divide equally. Our Flex items will appear as usual, and then the Flex item which we're wrapping onto the next row will appear at the start of the divided row. Let's go play around with this inside VS Code. So I'm back inside the file we were working on earlier. Let's go first look at the case when there is no set height on the Flex container. I'm just going to go comment this out and refresh. So what this means now is that our Flex items are setting the height of the container. And the container in light gray is now hidden because our Flex items go beyond the width of the Flex container. Now I'm just going to go remove the Flex shrink values as we no longer need those anymore. I just did that before to demonstrate that our Flex items can overflow, but by default, the Flex shrink value of 1 applied behind the scenes to each Flex item ensures that they fit within the container. I'll refresh. So now our Flex items are back to 250 pixels wide, all within the Flex container. Now this is a setup where we can use Flex Wrap. And once again, that's because our Flex items, when added up, will overflow. If our Flex items fitted within the container, Flex Wrap simply wouldn't work. It only works when your Flex items can extend beyond the Flex container. So let's go add our Flex Wrap property. I'm first going to set the default value of no wrap. I'll refresh and you'll see there's no change. And that's because by default, our Flex items won't wrap. Let's change the value now to wrap. I'll refresh and you'll see the Flex item, which would have been overflowing, now wraps onto its own line. And the container has expanded in height to allow this Flex item onto its own row. Let's go apply the other value of wrap reverse. I'll refresh, and as you can see, this effectively flips our different rows. All right, I'm just going to comment this out for now. Let's now go look at the other case by adding our height back in. I'll refresh, and again, we can see that our Flex items are shrinking inside the Flex container. Let's go wrap these. I'll uncomment this, and let's just use the value wrap. I'll refresh, and now you can see that when we have a set height, the height is divided by 2, and the Flex item that was overflowing now appears at the start of this row. So just be mindful of how wrap works when there's height or no height set on the Flex container. And really just to drive this point home, this property only works in a situation where your Flex items do exceed the width of the container. So just to show you this, if I go and update all the Flex item widths to 200 pixels, if I sum these up now, 4 times 200 is 800 pixels, which is less than the total width of the container of 1000 pixels. We still have our Flex Wrap property applied, so if I refresh, you'll see they don't wrap onto another line. And that's because this only works when the sum of the width of your Flex items exceeds the width of the container. Now, when we do have our Flex items wrapping onto a new line, there is an additional property that allows us to control the alignment of the wrapped Flex items. We do this with the align content property. Do not get this confused with align items, where align items is used to space and align properties along the cross-axis. Align content controls the alignment of Flex items along the cross-axis when there are multiple rows of Flex items. I really want to highlight, it's when there are multiple rows of Flex items. So you can only use align content when you apply Flex Wrap and your Flex items are on multiple rows. In CSS, it looks like this, where align-content is the property, and Flex Start is an example of a value. Also really importantly, align content is set on the Flex container. So let's have a look at the setup of this. We have our Flex container. In this example, I'm looking at one with a fixed height. We have our Flex items, which are wrapping onto different rows. We have our main axis and our cross axis. So align content is the alignment of Flex items on the cross axis when there are multiple rows of Flex items. That is, when we are applying Flex Wrap. Let's look now at all the different align content values. The first value is align content stretch, which is just the default value. In our setup, our Flex items will essentially stretch their entire height. The next value is Flex Start, where our Flex items are all at the start of the cross-axis and butt up against each other vertically like this. The next value is flex end, where our flex items are now at the end of the cross-axis. The next value is center, where our flex items wrap in the center along the cross-axis. The next value is space between, where our flex items have maximum space between them. And the last value is space around, where our flex items have equal space around them. So let's go play around with these inside VS Code. Alright, so I'm back inside the file we were working on earlier. I also just went and changed the width back to 300 pixels so that our flex items wrap. Let's go add the align content property, and I'm going to set the value to its default value of stretch. I'll refresh and you'll see nothing happens. Now what's actually happening is that because our flex items have a fixed height, they actually can't stretch. So they just end up looking like this, where the rows divide by 2 and they are just their height. What I'm going to do to better demonstrate the align content property is just turn off the height of each flex item and let the height be determined by the height of each number in each flex item. So I'll refresh and you can now see that our flex items do stretch the height of their rows. Let's go play with all the different values. We'll do flex start. I'll refresh and you can see our flex items all start at the start of the cross-axis. Let's do flex end. I'll refresh and you can see our flex items move to the end of the cross-axis. The next value we looked at was center. I'll refresh and our flex items now appear in the center. The next value was space between. I'll refresh and you'll see this creates the maximum space between our rows of flex items. The last value we saw was space around. So let's update this. Opening up DevTools, there's now equal space top and bottom of the rows of flex items. So the space above here and below here, and the space above here and below here are all equal. Now I just want to quickly highlight that the align content property can only be used when we have flex wrap enabled. I'm going to comment out flex wrap. I'll refresh and you can see the align content property is doing absolutely nothing. I'm going to add this back on and refresh. Now I also just want to show you that align items still does work. If I go align items and set the value to say flex start, I'll refresh and you can see our flex items are now at the start of the cross axis. However, as soon as I add back in an align content value like space around, I'll refresh, you'll see that the align content value completely overrides the align items value. As a general rule of thumb, you should be using align content when flex wrap is enabled, and align items for most cases when your flex items are inside the flex container. Now I know this can be really intimidating and confusing with align content, align items. My general word of advice is don't really worry too much about flex wrap and align content. The majority of layouts you're going to be working with are just a regular flex container where you're going to be using the align items value that we've been using throughout this topic. So let's now take a look at some flex wrap guidance. As I've kind of mentioned, I wouldn't worry too much about flex wrap as it's not often required. But let's look at some cases where you could use it. Wrapping is useful for simple linear layouts when elements need to wrap onto multiple lines. Taking a look at an example of this, we have this page over here with these logos showcasing where this application has been seen in the media. When you reduce the width of the browser, these logos wrap onto two different rows. So let's go check out an example of this in the browser. On this page here, when I scroll down, you can see company logos that are using this application. Let's go open up DevTools. I'll select the flex container over here. You can see it's going across two rows, which is being controlled by this flex wrap property here. If I turn the flex wrap property off, you can see they all go inside the flex container. Now the reason I wouldn't worry too much about flex wrap is that the truth is, when we start thinking about layouts like this, which are two-dimensional, that is, they contain rows and columns, this is actually a grid layout. And we're going to be spending a lot of time in the next topic talking about this. Just to give you a taster, you can see a very similar layout here to what we saw before of rows and columns. That is a two-dimensional grid layout. If I go inspect this layout, you can see over here the word grid. So that's why I wouldn't really worry too much about flex wrap. When layouts need both rows and columns, grid is the way to go, and we're going to be spending a lot of time in the next topic going through this.
So let's finish up by building our next summary card, flex wrap and align content. We first looked at flex wrap, which is when flex items wrap onto multiple lines if they exceed the container. In CSS, it looked like this, where the values include no wrap, wrap, and wrap reverse, where no wrap is the default value. We then looked at two different cases, The first is the flex container with no height. We saw that the flex items set the height of the container, and as the flex item wraps onto another line, the container expands. We then looked at a container with a set height, and in this case, the container is split into two, where rows divide equally, and our flex items are placed at the top of each row. We then looked at align content. Align content dealt with flex alignment along the cross-axis when there are multiple rows. We looked at all the values, including align content stretch, which is just a default value, and in diagram form, our flex items just stretch the full width of their row. Align content flex start is when our flex items go to the start of the flex container along the cross-axis. Align content flex end is when our flex items go to the end of the flex container along the cross-axis. Align content center is when our flex items center along the cross-axis. Align content space between is when space is created between our flex items, such that the top row of flex items touches the top of the flex container, and the bottom flex items touch the bottom of the container. And the final value was space around, which creates space between the rows of flex items and between the rows and the edge of the flex container. That's Flexbox ticked off the list. Well done. Learning layout techniques can be challenging, but you've made fantastic progress. Let's now take our layouts to the next level by mastering CSS Grid. CSS Grid is a powerful two-dimensional layout system that allows us to build complex designs with ease. In this topic, we'll explore how to structure web pages using rows, columns, and different grid alignment techniques to take full control of our layouts. Let's begin by exploring a powerful two-dimensional layout system with an introduction to CSS Grid. We'll be discussing what is CSS Grid, CSS Grid terminology, CSS Grid design guidance, and CSS Grid vs Flexbox. So what is CSS Grid? CSS Grid is a two-dimensional layout model, making it simple to arrange items in rows and columns. Now, the key difference between Flexbox and CSS Grid is that CSS Grid is two-dimensional, and it has rows and columns. Looking at an example of CSS Grid, on this page, you can see we have a 2x2 grid, and there are a total of 4 grid cells. We can see the first one here, the second one here, the third one here, and the fourth one here. This is an example of a two-dimensional layout which has rows and columns, where CSS Grid is used to achieve this. So let's start looking at some CSS Grid terminology. CSS Grid has two main components. We first have the grid container, which is the parent, and this is similar to the flex container in Flexbox. And then we have grid items, which are the children, and this is similar to flex items in Flexbox. So just like Flexbox has two main components of flex container and flex items, in CSS Grid, we have grid container and grid items. CSS Grid has two axes, and very different to Flexbox, we can't change the direction of the axes. The vertical axis is known as the column axis, and the horizontal axis is known as the row axis. The grid is divided into grid cells by grid lines. You can see vertically and horizontally, we have grid lines. And these grid lines divide our grid into grid cells. Now we actually number these grid lines like this. I'm going to start with our vertical grid lines at the top left. We would label the first one 1, then 2, then 3, then 4, and then 5. These numbers are very important for some properties we're going to be looking at later. Now we just numbered our vertical grid lines going from left to right, but you can also number them from right to left using negative numbers. Pay attention to the bottom right now. That is, on grid line 5, this is also -1. Moving to the left, we have -2, -3, -4, and -5. Let's now go number our horizontal grid lines. Paying attention to the top left, we're going to label the first horizontal grid line 1, then 2, and then 3. And now moving your attention to the bottom right, we're going to do the same thing with negative numbers, starting at -1, moving up to -2, and then -3. Now, as I mentioned, these grid lines define grid cells, which are shown in blue over here. So we can see our grid cell. Now, what's really important to note from the outset is that a grid item, which I've shown in green, isn't always the same size as a grid cell. You can see in my diagram, there's actually space inside the grid cell. And in fact, we're going to see later on, using some CSS Grid properties, we can move our grid item, that is the green box, inside the grid cell. And in fact, grid cells can have no grid items. So for example, the bottom left cell might not even have a grid item inside of it. So it's really important from the outset to distinguish between a grid cell, which is defined by grid lines, and a grid item, which is an actual piece of content. And some grid cells can be empty. That is, there is no content inside the grid cell. Now, grid lines define grid tracks. Grid tracks is just a fancy word for rows and columns. We can see our grid rows over here, where we effectively have 2 rows, a row over here, and a row over here. Looking now at our grid columns, we have 4 of these over here. 1, 2, 3, and 4. Grid rows and columns can have spacing between them. So you just saw our grid container expand vertically and horizontally. We still have our horizontal grid lines and our same grid rows in yellow, but now we have some space between our grid rows. Labeling our grid lines, we have horizontal grid line 1, grid line 2, where there is now space between the grid lines, which we call horizontal gap. And then we have grid line number 3 on the edge of the grid container. Looking now at our vertical grid lines, we again have our grid columns shown in purple, and let's go label our vertical grid lines. We have grid line 1 on the edge of the grid container. Grid line 2 now has some vertical gap. Grid line 3 also has some vertical gap. Grid line 4 also has vertical gap. And grid line 5 is on the edge of the grid container. So let's have a look at CSS Grid on a web page. I'm on this page where you can see these cards are arranged in a grid, which has 2 rows and 3 columns. Let's open up DevTools, and if I select the main container, you can see CSS Grid is being applied. You can see our vertical and horizontal grid lines, which are defining our grid cells, which have inside of them content, which are the grid items. You can also see there's horizontal and vertical gap between the grid cells. So this is just one example of how you could use CSS Grid, and we're going to see many implementations of CSS Grid throughout this topic. So let's now take a look at how we can activate CSS Grid by using Display Grid. The display property on a container element will activate grid layout features on children elements. It's the exact same with Flexbox. We use the display property with the value grid. And just like Flexbox, the display property is declared on the grid container, the parent. Looking at values for display, we have block, inline, inline block, flex, and grid. So by the end of this topic, you'll know how to use each of these values, as we've already covered block, inline, inline block, and flex at great length in this course. So let's go play around with this inside VS Code. Alright, so I've gone ahead and created a new index.html file, which just has the boilerplate, and I've linked up an app.css style sheet, which is currently empty. Inside index.html, I'm going to go create a div. I'm going to give it the class grid container, which, as the name suggests, means this div will be our grid container. I'm then going to go add 8 grid children by adding 8 divs. I'm just going to pop the number 1 in the first div and give it a class of grid item 1. For the second div, I'll copy this class, pop it here, and change it to grid item 2 and give it the number 2. Now, to avoid boring you, I'm just going to repeat this pattern for all 8 divs. Alright, so we now have our 8 grid items inside our grid container. Let's now move over to app.css. I'm first going to grab the Universal Selector and just remove all default margin and padding. I'm going to grab our grid container and I'm just going to give it a font size of 40 pixels. This means our grid items will inherit this font size as it's being defined on the parent. We'll make the grid container into a grid by adding the display property with the value grid. We'll grab grid item 1, and I'm just going to give it a background color of red. I'll copy this style, change it to grid item 2, and give it a background color of green. Now again, to avoid boring you, I'm going to go add colors to the other grid items. So we have our 8 grid items, all with different background colors. So let's go check this out in the browser. Alright, so you can see our grid over here. By default, you'll see straight away that a grid just has one column, where our grid items are being stacked vertically on top of each other. We can confirm grid has been activated by opening up DevTools, selecting the grid container. You can see the word grid here, and you can also see the horizontal grid lines, which are those dashed purple lines. Now, if I go comment out display grid and refresh,
you'll see there's actually no visual change. But this layout is not a grid. You can see inside DevTools, there's no grid appearing here, and there are no grid lines. We don't have those purple dashed lines. I'll just uncomment this again. I'll refresh, and you can see now our grid is back on with the grid lines reappearing. Now, throughout this topic, we're going to be using this setup to look at all the different properties for CSS Grid. But I do just want to highlight that by default, our grid items just appear in a single column. And we'll be seeing in the next chapter how we can use grid properties to get the two-dimensional layout of rows and columns. So let's now take a look at some CSS Grid guidance. CSS Grid can be used for complex two-dimensional layouts. Looking at this page over here, if we were to see the grid, it would actually look like this. This is a very complex two-dimensional layout, where we have elements like text spanning grid cells. That is, our text is actually going across different grid cells. And you can see over here, we have images also spanning cells. So for this design, to achieve this interesting effect of images and text in a complex 2D layout, CSS Grid has to be used. Grid is also commonly used for major sections. This page has a very popular kind of layout, which would often be used for a feature section, with columns of alternating images and grouped text. You can see our 4 grid items over here. Grid is also commonly used for UI elements with consistent spacing in a one-dimensional row or column. Now, you could also use Flexbox for this, and we are going to be seeing soon when to use Flexbox and when to use Grid. So here's what I mean. You can see these 3 cards are in a one-dimensional layout, but using Grid is actually fairly common. And we're going to see soon it's because we can easily divide a grid container into columns like this, where in this example, 3 columns are being used. So even though this is a one-dimensional layout, CSS Grid is being used with a single row and 3 columns. And this is actually a fairly common implementation. But of course, you can still use Flexbox. And if you were to look at DevTools at a layout like this, you'll see some pages use Flexbox and some pages use Grid. So it's kind of down to what you prefer. So when you're starting out, it can be quite confusing when to know to use Grid or Flexbox. So let's take a look at CSS Grid versus Flexbox and get a general idea of when you'd use each. Looking at Flexbox first, Flexbox is generally used for smaller UI. In CSS, we know it's defined like this, and it's a one-dimensional layout model in rows or columns. Examples of where we'd use Flexbox include navigation bars, footers, components, which would include things like buttons, text callouts, and inside cards. Flexbox is also used on hero sections and forms. These are good examples of one-dimensional layouts which tend to be smaller pieces of UI. Looking now at Grid, as a rule of thumb, this is used on larger UI. We know it's defined like this, and CSS Grid is a two-dimensional layout model with rows and columns. Common places we'd see CSS Grid is in complex 2D layouts, like we saw earlier, with the images and text spanning different grid cells. It's also commonly used in large feature sections, where we saw an example of alternating images and group text in rows going down the page, and also used in cards, which could be in 2 dimensions or even in 1 dimension, like we just saw earlier. So as a general rule of thumb, Flexbox is used on smaller UI, and Grid is used on larger UI. And there are some cases where there is a bit of overlap where you could use Grid or Flexbox, just like those one-dimensional cards we looked at before. So let's wrap up this chapter by starting to build out the next summary card, CSS Grid Fundamentals. In this chapter, we looked at grid terminology. We saw that a grid has a grid container. Inside the grid container are our grid items. From top to bottom, we have our column axis, and from left to right, we have our row axis. And we discussed how these do not shift like in Flexbox. We then have our vertical grid lines, which are numbered from left to right 1, 2, 3, 4, and 5. And going the other way, we can also number them with negative numbers. Starting at the bottom right, we have -1, -2, -3, -4, and -5. We then have our horizontal grid lines. Looking in the top left, we number them 1, 2, and 3. And now looking in the bottom right, with the negative numbers, we go -1, -2, and -3. These are our grid lines. Our grid lines define our grid cells. And we also spoke about how a grid cell doesn't always have to have a grid item inside of it. And a grid item can also be smaller than a grid cell.
And we're going to see later on some properties which allow us to align grid items inside of grid cells. Focusing on our grid container and our grid cells, we then spoke about grid tracks, which were defined by our grid lines, where we can have a grid row shown here and another grid row here. We then have a grid column defined by our vertical grid lines, which we can see here. And in this setup, we have this grid column here, here, and here. Between our grid rows and grid columns, we can have space. First looking horizontally, we call this horizontal gap, which is space between our grid rows. We can also have space between our grid columns, which we called vertical gap, and looks like this. Next, we'll learn how to structure layouts by defining tracks with grid columns and rows. We'll be talking about grid template columns and rows, the fractional unit, the repeat function, and grid column and row design guidance. So let's start off talking about grid columns and rows. Grid items will appear in a single column by default. We saw this in the previous chapter when we were playing around with CSS Grid. We added the display grid property. This defined a grid container, and we saw that all our grid items appeared by default in a single column, stacked one above another. The height of the grid container is the sum of the grid items. And because our grid items, we know the block element will extend the full width of the page or the container there inside. So this is our default setup. By adding display grid to a container, all children are converted to grid items, which by default will appear in a single column. So let's now look at how we can define columns in CSS with grid template columns. This is a CSS property that sets the number of columns and width of each. The property looks like this: grid-template-columns. And the values we use define the width of each column. So 100 pixels is the width of column 1, and 200 pixels is the width of column 2. So these two values are defining the width of the columns. Let's go play around with this inside VS Code. Alright, so I'm back inside the file we were playing around with in the previous chapter. We have our 8 grid items defined inside this grid container, which we previously put the display grid property on, converting this into a grid. And as I mentioned earlier, our grid items will just stack vertically by default in a single column. So let's go add the grid template columns onto our grid container. Let's make 2 columns, the first 100 pixels and the second column 200 pixels. I'll refresh and you'll see now that our grid has 2 columns. Let's open up DevTools. I'll select the grid container. Let's check out grid item 1, which is in the first column. So you can see from the box model, it has a width of 100 pixels. If I click on grid item 2, you can see it has a width of 200 pixels. The other thing I want you to note is that when I click on the grid container, you can see the purple dashed lines are defining the grid. So let's now take a look at grid template rows. This sets the number of rows and height of each. The CSS property looks like this: grid-template-rows. And similar to grid template columns, the values are now setting the height of each row. So row 1 will be 50 pixels, row 2 will be 100 pixels, row 3 is 200 pixels, and row 4 is 300 pixels. So each of these values are setting the height of each row. Let's go play around with this inside VS Code. Alright, so I'm back inside our file, and at the moment, the height of each row is just being defined by the height of the content itself. You'll also note that there are 4 rows, and this is happening because we earlier defined 2 columns. And because there are 8 grid items, it means that 2 grid items will appear per row. So that's why we end up with 4 rows. It's a result of having 8 grid items in 2 columns. But let's now go explicitly define our rows. We'll grab the grid template rows property. Let's still define 4 rows. The first row will set as 50 pixels, second row 100 pixels, third row 200 pixels, and fourth row 300 pixels. I'll refresh, and you can now see that the height of our rows is being explicitly defined by grid template rows. Now, as I mentioned earlier, when we didn't have the grid template rows property, we had 4 rows, and that was a result of having 8 grid items in 2 rows. But what I can do with the grid template rows property is also explicitly define the number of rows I want. So for example, let's go remove 300 pixels and just define 3 rows. I'll refresh. So now what's happening is that I'm explicitly defining only the first 3 rows, and grid items 7 and 8 are still in our grid container, but will just be their default height. Now in the earlier chapter, I mentioned that you can have grid cells which don't necessarily have to have grid items inside of them. So let me show you how we can end up in that situation. I'm going to come to our grid template columns and add an additional column of 300 pixels. So what this means is we now have 3 columns and 3 rows, and we only have 8 grid items. So let's see what happens when I refresh. You can see in our last row and last column, we have a grid cell with no grid item in them. And that's because we've defined 3 columns and 3 rows, which means that there's 9 cells. But we only have 8 grid items, so the last cell is empty. Let's check this out in DevTools. I'll select the grid container. And you can see in the bottom right, we have a grid cell with no grid item inside of it. You can also now see our grid lines appearing with the numbers we saw in the previous chapter. Alright, so we now have a good idea of how to define columns and rows in our grid. It's now time to talk about a special unit called the fractional unit, which we haven't seen before and is very commonly used in CSS Grid. The fractional unit defines the fraction of available space in the grid container. And we use it like this, where we have our property, like grid template columns, and we define our columns using this fractional unit. Or in this case, I've defined 3 columns. The first is 1FR, the second is 3FR, and the third column is 4FR. So this is how it works. We have our grid container, which let's say has a width of 1000 pixels. We then add up our total fractions, which would be 1 plus 3 plus 4, which equals 8. We then take our width of 1000 pixels and divide it by our total fractions of 8, which gives us a value of 125 pixels. So we end up slicing our grid container into 8 fractions, each with 125 pixels. So essentially, one fraction is equal to 125 pixels. We then look back at the grid template columns values we decided. Our first column is 1 fractional unit, which we know is 125 pixels. Our second column is 3 fractional units, which would be 3 lots of 125 pixels. So that's 375 pixels. And our third column is 4 fractional units, which is 4 lots of 125 pixels, which is 500 pixels. So fractional units is an easy way to define our grid columns proportionally. Let's go play around with this inside VS Code. So I'm back inside the file we were working on earlier. I'm just going to go remove our grid template rows property and just go back to 2 columns we had before. So let's go use the fractional unit to define our columns. I'll remove the pixel values. Let's define our first column as 1 fractional unit and our second column as 3 fractional units. So let's open up DevTools so we can talk a bit more about what's happened. So if I select our grid container, now because our grid container is just a div, it will just extend the full width of the browser. Now by using fractional units, we're effectively dividing this space into 4, that is 1FR plus 3FR, and then our first column is 1/4, that is 1 fractional unit on the total of 4 in width, and our second column is 3 divided by 4, which is 3/4. So we've effectively divided our grid container into 2 columns, where the first column is 1/4 the width of the entire page, and the second column is 3/4 the width of the entire page. Now, one thing I want to show you, that this is technically the same thing as using percentages. I could change this to 25% and change this to 75%. I'll refresh, and you'll see there is no change. However, it's much more common to use fractional units when defining grid columns and rows. So I'm just going to change those back. Now, the last thing I want to show you is that at the moment, our grid container has no width. It's just extending the full width of the page. Let's now go set a width of our grid container of 400 pixels. I'll refresh, and now the fractional units are dividing the width of 400 pixels to define our columns. So the first column is 1/4 of 400 pixels, which is 100 pixels, and our second column is 3/4 of 400 pixels, which is 300 pixels. So I just wanted to show you that fractional units will define your columns proportionally based on the width, and that width could be the full width of the page if it's just a general block container, or it could be the width explicitly defined on the grid container. So let's now take a look at fractional units and rows. Now, fractional units and rows are just a little bit more tricky, and the behavior hugely depends on whether the grid container has a set height or not. So let's look at the first case. If height is set on a grid container, FR units proportionally distribute space to the grid items. This behavior is very expected. It's the exact same as what we saw with columns, just being applied to rows. So we have our CSS property, grid template rows, and we're defining 3 rows. The first one has 1 fractional unit, the second row 2 fractional units, and the third row also has 2 fractional units. Looking at this in diagram form, we have our grid container. Let's say its height is 1000 pixels. The total fractions is 1 plus 2 plus 2, which equals 5. So our grid container has 5 fractions, each with a height of 200 pixels. That is 1000 pixels, the height of the container, divided by 5, the total number of fractions, to give us 200 pixels.
So these define our fractions of rows. Looking at grid template rows now, our first row we defined to have 1 fractional unit, so will look like this, with a height of 1 fractional unit. Our second row is 2 fractional units, which would be 400 pixels. And our third row is also 2 fractional units, and also will have a height of 400 pixels. So let's go check this out in VS Code. So the first thing I want to do, just so we can look at the case I just went through, is I'm going to go add an explicit height on our grid container of 1000 pixels. Let's then go grab our grid template rows property, and let's define 4 rows. The first will be 1 fractional unit, the second 2 fractional units, the third 3 fractional units, and the fourth 4 fractional units. Let's refresh, and I'm going to zoom out quite a bit to see what's going on. So if we add up all our fractional units, 1 plus 2 plus 3 plus 4 gives us 10 fractions. Because the height of our grid container is 1000 pixels, it means that each fraction will be 1000 pixels divided by the total fractions of 10, giving us 1 fraction equal to 100 pixels. So our first grid row, which is 1 fractional unit, will be 100 pixels. Our second grid row, which is 2 fractional units, will be 200 pixels. Our third row, 300 pixels, and our fourth row, 400 pixels. So let's continue our discussion with fractional units and rows, and look at the other case, which is if no height is set on the grid container, FR units use the height of the grid items to set height and space on the grid container. This is very unexpected, where the fractional units are being calculated by the height of the grid items. They're no longer dividing the height or width of the grid container. So let's see what this looks like. Let's say we define our rows like this, grid template rows, which will define 3 rows, row 1 of 1 fractional unit, row 2 of 3 fractional units, and row 3 of 4 fractional units. Looking in diagram form, we have our grid container, and let's say each grid item is 10 pixels. Now, as there's no height set on the grid container, the height of the grid container is the sum of the content, that is 30 pixels. Let's now move back to our fractional units. We'd calculate the total fractions, which would be 1 plus 3 plus 4, which equals 8. And what this now does is define 8 fractional units like this. We're no longer dividing the grid container in 8, but we're basing the fractional units on the height of the grid items. So we could then calculate what the new total height of our grid container will look like, which equals 10 pixels times 1 fractional unit, plus 10 pixels times 3 fractional units, plus 10 pixels times 4 fractional units, which equals 80 pixels. So this means the height of our grid container will be 80 pixels, where the grid container has now scaled based on the grid items. And our grid rows will now look like this. The first row is 1 fractional unit, which is 1 divided by 8, the total fractions, multiplied by 80 pixels, which would be 10 pixels. The second row, which is 3 fractional units, is 3 divided 8 times by 80 pixels, that is 3 fractions of 10 pixels. And our third row is 4 fractional units, which is 4 divided 8 times 80 pixels, which is 40 pixels. So this is just really strange behavior, where our grid container is actually expanding based on the height of our grid items and the different fractional units we're using. Now, this may seem incredibly overwhelming, and honestly, I wouldn't worry about it too much. We're going to see soon in the guidance that in most cases, we don't even use grid template rows, let alone grid template rows when there is no height on a grid container. Most of the time, we're just using grid template columns to define our columns, and the rows are just a result of the number of columns and grid items, where we don't actually go and explicitly define our grid rows. And I'll cover that in more detail soon, but I wanted to bring it up now because I imagine you're feeling very overwhelmed. And I seriously wouldn't worry too much about this. As always, I do just want to show you so you know everything that's going on, but honestly, don't stress too much about it. Alright, so let's check this out in VS Code. What I'm going to go do is now remove the height on our grid container. I'm just going to temporarily comment out our grid template rows. I'll refresh, and we're now back to a grid container of 400 pixels with our columns defined with 1 fractional unit and 3 fractional units. Okay, so our grid container has no set height, which means the height is being set by the height of our grid items. So the sum of these 4 grid items are setting the height. I'm going to uncomment this and refresh, and you'll see how our grid container has now expanded. So let's open up DevTools. You can see the height of this grid item is 46 pixels. Now, because our first row is 1FR, that means that 1FR is equal to 46 pixels. Now, if I add up our fractional units of 1 plus 2 plus 3 plus 4, that gives us 10 fractions. As 1 fractional unit is 46 pixels,
it means our height of our grid container is now being set at 46 pixels times 10 fractional units, which gives us a height of 460 pixels, which you can see here when I click on grid container. And then each grid row is now defined by a multiple of our fractional unit, which is 46 pixels. If I click on grid item 3 in row 2, you can see it has a height of 92 pixels, 2 times 46 pixels. If I click on grid item 5 in row 3, its height of 138 pixels is 3 times 46 pixels. And grid item 7 in row number 4 has a height of 184 pixels, which is 4 times 46 pixels. So once again, just to summarize this, when you don't explicitly have a height on your grid container and you're using fractional units, the fractional units are calculated based off the height of the grid items. And as I mentioned earlier, I really wouldn't worry too much about this, but I do just want you to see how it works. So let's now take a look at the repeat function. The repeat function is a helpful tool which can be used to repeat rows or column dimensions when they are recurring. It looks like this, where we have our grid template columns or rows property, and we use this function called repeat. Inside the repeat function, we have 2 values. The first value is the number of rows or columns we wish to define, in this case 4 columns, and the second value is the size value, that is, the size we want our columns to be, in this case 1 fractional unit. So what this will give us is a grid with 4 columns, each 1 fractional unit in width. So it's just a cleaner way of defining 4 grid columns, each with the same width. You can of course define this as grid template columns, 1FR, 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 that is 1FR 4 times, but this function is just a nicer and cleaner way of defining it. So let's check this out in VS Code. So I'm back inside the file we've been working on. I'm going to go just remove grid template rows. At the moment, we have 2 columns. Let's go define 4 columns, each with 1 fractional unit. So the long way of doing it is like this, using 1FR 4 times. I'll refresh, and this defines us a grid with 4 columns, each 1 fractional unit. The width of our grid container is 400 pixels, so that means that each column will be 100 pixels. That is 1 divided by 4, where 4 is the total number of fractions, multiplied by the width. So instead of doing this, we can define it like this. Repeat. The first value is the number of columns we want, which is 4, and the second value is the width of our columns, which we're going to define as 1 fractional unit. I'll refresh, and you can see we end up with the same thing. Now you don't have to use fractions here, you can use other units. So let's say I define this as 200 pixels. I'll refresh, and you can now see that we have 4 columns, each 200 pixels wide. Alright, let's finally take a look at some column and row guidance. So the good news is the actual use of rows and columns is fairly simple in practice. Columns are often set with FR units, and the width of the grid container is usually not set, but extends the width of the page. Looking at this page as an example, we have 6 grid items here, which would all be defined in this grid container, where the grid container extends the full width of the page. We have the 6 grid items shown in green, and we have 3 columns, all with equal width, and would each have 1 fractional unit, which very simply defines 3 columns with equal width, each taking up 1/3 of the grid container. Now the number of rows are not usually set, but are automatically defined by the number of grid items. I touched on this earlier when you were likely freaking out about using grid template rows. As you can see here, the good news is we often don't even use it. We just define grid template columns and let the number of rows automatically fall into place by knowing our number of grid items and the number of columns we're defining. In this case, we have 3 columns with 6 grid items, which automatically creates our 2x3 grid. And finally, the height of the grid container is not usually set, but defined by the sum of the height of the grid items. As we've seen throughout this course, when defining page sections or components, it's very common not to actually set height, but let the height be automatically determined by the height of the content. So the height of the grid container is the sum of the height of the content in the grid items. So our grid items contain things like images and text and anchor tags. So the height of each grid item would be the sum of those, and the height of the grid container would be the sum of the grid items. So let's wrap up this chapter by adding to our summary card CSS Grid Fundamentals. In this chapter, we looked at rows and columns. We saw how we could define columns with the CSS property grid template columns, and we also looked at fractional units, which are very commonly used in CSS Grid. For grid template rows, the CSS property looked like this, where we also saw we could use a repeat function, where the first value is the number of rows,
And the second value, in this case, would be the height of each row of 200 pixels. These properties would then define our grid, which would look something like this, where we have two columns, where the width of the first column would be 1/3 the width of the grid container, the second column would be 2/3 the width of the grid container, and for the rows, we would have two rows, each with 200 pixels in height. And just as a final reminder, don't freak out too much about the use of grid template rows. We're mainly going to be using grid template columns and fractional units to define our grid and let our rows be automatically calculated. So let's now go ahead and start adding a grid to our Quill homepage. This section of the page, which has our features, will be defined inside a grid. We'll define a grid container, where the grid container width extends the full width of the page. We then have our grid items, which are either grouped text or an image. In our layout, we want two columns of equal width. So we will be using fractional units to define our columns, where each column will be one fractional unit. This will effectively divide our grid container to have two columns of equal width. Now, because we have two columns with 6 grid items, this automatically creates a 3x2 grid. That is, a grid with 3 rows and 2 columns. Let's add on our vertical grid lines and our horizontal grid lines. Now, one thing I want you to notice is that our text grid items have a different height to our images. So the height of the grid container is set by the height of the images. That's because in each row, the image has a larger height compared to the grouped text. So the image grid item is setting the height of each row, which means that the height of the entire grid container will be the sum of the heights of the images. Now, later on in this topic, we're going to be talking about alignment of grid items when there's extra space in the grid cell. So you can see, for example, our group text has been vertically centered inside each grid cell, and we're going to be looking later at how we can do that. Now, before we jump into VS Code, I do just want to point something out. This layout of alternating text and image as you move down the page is very common, and there are actually 2 ways of achieving this. The method we're doing is defining a grid for the entire section. Let me show you this on another page. Okay, I'm going to scroll down to the features section of this page, and you can see we have these alternating images and group text as we scroll down. I'm just going to zoom out quite a bit. I'm going to open up DevTools, and you can see we have a single grid defining this entire section. Now I want to contrast this to the implementation on this page. I'm going to scroll down, and you can see we have the same layout, where we have alternating text and image. I'm also going to zoom out quite a lot. I'm going to open up DevTools, and let's go select the grid. And what you'll notice is that each row is actually its own grid. We have a grid here, we have a separate grid here, if I scroll down, and we have a separate grid here. So I just wanted to show you this is another common way of implementing this. Now I've decided to go with this method, but do be aware this is another common implementation of defining separate grids for each row. So I'm back inside our index.html file for our Quill project. I'm going to scroll down to the features section. And before we start using the CSS grid properties, we need to make some adjustments to our HTML. So at the moment, inside our section, we have our 3 features, each defined inside a div. Here's feature 1 with the heading, paragraph, and image, feature 2, heading, paragraph, image, and feature 3 with the heading, paragraph, and image. So the first thing I want to do is just go define our grid container. I'm going to grab a new set of divs, and I'm going to give this the class of features grid container. Now, if I were to just copy and paste these divs for each feature back inside of here, this isn't going to work with the layout we want. And that's because inside our grid container, we would just have 3 grid items. This one here, and this one here. And what we need is 6 grid items, where we need to group our text for some of the grid items and just use the image as the other grid items. So what I'm going to do is I'm going to get another div, and this will be used to group our text. I'll copy this and place it inside the div. So now we have our grid container with our first grid item, the grouped heading and paragraph inside this grid item, this div here. And the next grid item is just the image. I'll copy that and paste it over here. And I just need to repeat this same structure for the other feature sections. So I'll define another div for our group text for feature 2. I'll copy this and paste it here. I'll then grab the image for feature 2 and paste it here. Finally, I'll get the last group text from feature 3 over here. I'll copy that and paste it here. And then finally, I'll grab the image from feature 3. So this now gives us our grid container with 6 grid items. Grid item 1, which is the group text for feature 1. grid item 2, which is the image for feature 1, grid item 3, which is the grouped text for feature 2, grid item 4, which is the image for feature 2, grid item 5, which is the grouped text for feature 3, and grid item 6, which is the image for feature 3. So let's now go remove the original markup. Now I really don't want these divs over here to throw you off. The div here is just a child of our grid container, no different to the image. So that's why the entire div is the grid item, where inside the div we have some text. So once again, we have 6 grid items. This one here, 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 and this one here. Heading over to app.css, let's go down to our features section over here, and under the features main heading, I'm going to go grab our features grid container. We'll change the display property to grid, and let's go define our grid template columns. And as we said, we're going to define 2 columns, each with a width of 1 fractional unit. Now I've defined it like this. You could also use the repeat function, but because this is 2 columns, I'm just going to use this implementation. So let's check this out in the browser. Now before I refresh, this is what the page originally looked like, where we have our feature section with text and image repeated. Now in our markup, we've now grouped this text, so that's 1 grid item, and our image is another grid item. So I'll refresh, and you'll now see we have 2 columns where our grid items is group text and an image, and each column is 1 fractional unit. Let's open up DevTools. I'll select this div with the class features grid container. I'll zoom out a bit, and you can see our grid in all its glory, where inside each grid cell, we either have group text or the image. And as I mentioned earlier, the height of this grid container is being defined by the height of each image. You'll also notice that inside each grid cell, there's actually some space for our content to move. In the grid cells with our text, you can see there's some vertical space here. And in the grid cells with our image, you can see there's horizontal space. And we're going to soon be learning about grid alignment properties that allow us to move grid items inside grid cells when there is space. The other thing I want to mention is that in our final design, the text and images alternate as you move down. You can see that's not happening here, where in the second row, we want the image on the left and the text on the right. Now, one way of fixing this is going to the underlying HTML and changing the order of the second feature. I could take this image and put it above the group text for feature 2. I'll refresh and you'll see this corrects this. However, this is not a good implementation. Let me just change it back. There's actually 2 reasons why it's not a good implementation. The first is we want to keep our HTML markup consistent, where we first have our group text and then image for each feature. This is much cleaner and much more consistent. The second reason, which is more important, is that when we come to the next topic and learn about media queries and responsive design, it's going to make it a lot easier having our flex items defined like this. So we'll see why this is a lot better. So to correct this, we are going to learn about a property later on, which allows us to manually define the position of a grid item.
Now it's time to learn about how to create spacing between grid items using grid gap.
We'll be discussing default spacing between grid items, the gap property, and gap design guidance. So let's first talk about the default spacing between grid items. By default, grid items are placed next to each other with no spacing between them. Looking at an example grid, we have our grid container, and we have our different grid items. In this case, a grid which is 2 rows by 3 columns. And you'll notice by default, there is no spacing between any of the grid items. They butt up right next to each other. Let's take a look at this inside VS Code. So this is the file we were working on in the previous chapter. I want to go update it to just have 2 columns. So I'm going to do 1FR and 1FR. I'll refresh, and we're now back to having 4 rows and 2 columns. I'm going to zoom in a bit, and as you can see, our grid items all butt up right next to each other. There is no spacing between them. If I open up DevTools and select the grid container, you can see those dashed grid lines, which act as a border between the grid items. So by default, there is no spacing between our grid items. Now this is a fairly simple example, and I actually want us to get more familiar with thinking about grid cells as opposed to grid items when it comes to spacing. So to better understand what I mean, I've gone ahead and prepared this file ahead of time. I've got a simple div, which I've given the class grid container, and I have 8 images inside. In app.css, I've gone ahead and removed margin and padding, and on the grid container, I've converted this into a grid. I've given it 2 equal columns of 1FR and 1FR, and I've given the entire grid a width of 1000 pixels. So let's check this out in the browser. So you can see I have 8 different images of my favorite satirical character Borat, each with different sizes. You can see they're in a grid with 2 columns and 4 rows. Let's open up DevTools, and you can see the grid here with the grid lines. Now, the reason I want to get more comfortable with thinking about grid cells as opposed to grid items is that when we're talking about gap, we're talking about space between rows and columns, which is space between our grid cells. So you can see, for example, inside this grid, this image, which is a grid item, is inside this top left grid cell. And you can see that there's space inside that grid cell for this grid item to move. We'll be looking at how we do that in the next chapter. But what I really want you to get comfortable with is that the spacing we're going to be looking at now is between grid cells, not grid items. It can be that your grid item is the same size as your grid cell, like in the simple example we looked at earlier, but that's not always the case. So I just wanted to make a note about that from the outset, that the spacing in this chapter we're talking about is spacing between our grid cells. So for the rest of this chapter, I'm no longer going to be talking about grid items, but rather grid cells. So let's now take a look at the gap property. The gap property creates space between grid rows and columns. Here's our flex container. In blue, we now have our grid cells, and we can use the property row-gap, which will create space between our rows. And in this case, the space will be 20 pixels. And we can also use the CSS property column-gap to create space between our grid columns. In this case, a space value of 40 pixels. So let's play around with this inside VS Code. All right, so I'm back in the file we were working on earlier. Now, the first thing I want to do before we go add some gap is look at the size of our grid cells. If I click on this grid cell, you can see it's currently 200 pixels wide by 46 pixels high. Let's now go add some row gap of 20 pixels. I'll refresh. You can see now that between our rows, there's 20 pixels of gap. Now, because there was no height set on this grid container, to account for the additional 20 pixels between each row, the entire grid container has effectively expanded. And you can see the height of our grid items are unchanged. They're still 46 pixels high. I also want you to notice that in the CSS grid model in DevTools, our grid line, like this one here, number 3, now actually appears as 20 pixels wide, whereas grid line 1 is just in one dimension. It has no width. I'm going to exit DevTools just so you can clearly see the row gap of 20 pixels between each row. I'm going to open up DevTools again and select the grid container. Now let's go add column gap. And this time, I want you to keep an eye on the width of our grid cells, which are currently 200 pixels wide. This is being set by the width of the grid of 400 pixels. And because there's 2 columns, each with 1 fractional unit, it results in the columns being 200 pixels wide. So let's go add some column gap of 40 pixels. I'll refresh, and you can now see we have 40 pixels of column gap. But the big thing you'll notice here is that the width of the cell has actually reduced. It was 200 pixels and has now gone to 180 pixels. So what this means is that if you have a set dimension on either width or height, if you add column or row gap, it will reduce the width or height of the content. Now, in most cases, you won't have a height set, so your grid container will just expand in height, whereas with width, you'll either have a width set, like 400 pixels, or it will just expand the full width of the page. So to show you this, let me turn this off. I'm going to comment out column gap. I'll refresh. Our grid items are currently 310 pixels wide. Let's go add our column gap back in. I'll refresh, and you'll now see, to account for the additional column gap of 40 pixels, our grid items have reduced to 290 pixels. So long story short, in most cases, when it comes to the width of a grid container, it will either be explicitly set, or it will just extend the full width of the page. And in both those cases, adding column gap will reduce the width of your grid item. Now with height, in most cases, you will not set an explicit height on the grid container, which means that when you add row gap, the height of your grid container will just expand to account for the additional space between your rows. Now once again, I really want to stress that the row and column gap we've just looked at is spacing between grid cells. So I'm back in our Borat collage. Just going to open up DevTools. Let's go add row gap of 50 pixels and column gap of 100 pixels. I'll refresh. I'll select the grid container, and I want you to once again see that the spacing is between our grid cells, and it's our grid cells that make up columns and rows. So for example, the spacing is not the spacing between this flex item and this flex item. It's the spacing between this entire grid cell and this grid cell. And as I mentioned earlier, we're going to be looking at the next chapter at how we can move our grid items inside grid cells when there is space like this inside the grid cell. Now, the other thing I just want to note before we move on is that row gap and column gap is not created on the perimeter. So for example, in this grid, you can see there's no column gap on the far left and on the far right. It's only down here. And the same for row gap. There's no row gap right at the top and right at the bottom. It's only between our actual rows. Now, another version of the gap property you can use is the simple property gap with a value like 40 pixels. And this value is the value for the row and column gap set in one go. So for example, in our grid container, we have our grid cells, our row gap is 40 pixels, and our column gap is also 40 pixels. So if you're using an equal value for both row and column, you can simply use the gap property. So let's now take a look at some gap guidance. Gap is commonly used to space grid items in major sections. We can see over here a typical feature section with alternating images and group text. I'm going to lay over the grid cells. We can see over here some large row gap, and over here some smaller column gap. Gap is also commonly used for spacing in card layouts such as testimonials and features. Looking at this example here, we have our grid cells, we have row gap and column gap. So there are many instances where you do want to be using gap inside your grid layout. So let's now finish off the summary card, CSS Grid Fundamentals. In this chapter, we looked at gap. We saw the CSS property row-gap and the CSS property column-gap. We saw that these properties create gap between our grid cells. For row gap, the value is 40 pixels. That is 40 pixels between our rows inside our grid. And for column gap, the value is 20 pixels. That is 20 pixels between our columns inside our grid container. We also looked at the gap property, which sets a gap value for both rows and columns at the same time. So in this example, a gap of 20 pixels will set 20 pixels of space between our rows and 20 pixels of space between our columns. So let's now go and apply column and row gap to our Quill homepage. So far, we've established a grid container with our grid cells in a 3x2 layout. We're going to go ahead and add some row gap between our rows and some column gap between our column. So let's jump into VS Code and add this to our project. So I'm back inside our app.css file for the Quill homepage. Now before we go add some values, I want you to see that our rows are really quite on top of each other. We really do want to create quite a bit of space between each of these rows to improve the visual aesthetic. We're also going to add a small value of column gap to just spread these out a bit more. Now ordinarily, you'd go play around with values until you feel like the page looks right. I played around before, and for me, a row gap of 15 rem, which in our project is 150 pixels, and a column gap of 5 rem, which is 50 pixels, look good for me. I'm going to refresh, and you can see this creates more vertical spacing between our different features, which just seems a bit more consistent with the layout we have. And as I mentioned, I just think this spacing looks good. But you, of course, can go add whatever spacing you like. Now, just to see the row and column gap in action, let's open up DevTools. I'll select the grid container, and you can see the column and row gap with the purple dashes. Now, the other thing I just want to mention before we finish up is that the values I picked here, 15 rem and 5 rem, are still part of our spacing system we defined much earlier. 5 rem is equivalent to 50 pixels, and 15 rem is equivalent to 150 pixels. So whatever values we pick for our spacing should still fall in line with the spacing system we established earlier on in the course.
Moving on, we'll explore how to position content within individual grid cells using grid alignment.
We'll be discussing the Justify Items property, the Align Items property, and grid cell alignment design guidance. So what is grid cell alignment? This is where grid items can be aligned inside grid cells if there is space available. So let's take a look at this on this page here. We have our grid container and our 2 grid items. I'm going to add in our horizontal grid lines and our vertical grid lines. You can see that the height of the grid is set by the height of the image. This means that on the left, there's space inside the grid cell, as the grouped text, which would be inside a div, is not the same height as the image on the right. So there's space above and below for this grid item to move inside the grid cell. So let's check out the first property, Justify Items. Just a note, this is not Justify Content, which we saw in Flexbox. Justify Items aligns grid items inside a grid cell along the row axis. The CSS property looks like this, where at the moment the value start is being used. Looking at this in diagram form,
We have our grid container, our vertical grid lines, and horizontal grid lines. The grid lines define our grid cells, and inside the grid cells, we have our grid items. So you can see in this setup, there's space for our grid items to move inside the grid cell along the row axis. So this is where we could use justify items to align the grid items. Now there are 4 possible values we can use. The first value is justify item start, which we just looked at earlier, and it will align our grid items at the start of each cell along the row axis. The next value is justify items end. We have our grid container, and along the row axis, our grid items are at the end of each grid cell. The next value, justify item center. We have our grid container, and along the row axis, our grid items are in the center of their grid cell. And the final value is justify item stretch. And this is in fact the default value. We have our grid container, and along the row axis, our grid items are stretching the full width. So let's play around with this inside VS Code. So I'm back inside the app.css file we were playing around with in the previous chapter. So let's go add our justify items property to see it in action. Like all the other properties we've seen so far, justify items is set on the grid container. And the first value I want to use is the default value stretch. I'll refresh and you see nothing changes. And that's because the grid item is being stretched inside the grid cell. You can see the number 1 only takes up this width of content. And because I've added a background color, you can see the background color has been fully stretched inside the grid cell. Let's go look at the other values. We saw start. I'll refresh. And you can see the grid item is now only occupying its actual width and is at the start of the grid cell. Let's check this out in DevTools. You can see our grid container with the grid lines now appearing. And you can see inside each grid cell, the content, which is just the number 1 inside a div with some background color, is at the start of the grid cell. The next value we looked at was end. I'll refresh. And you can see the grid item now moves to the end of the grid cell along the row axis. And the final value we looked at was center. I'll refresh. And this now centers our grid item inside the grid cell along the row axis. So now let's take a look at the align items property. This property is the same as what we're using in Flexbox. Now by now, I'm sure you're getting a bit overwhelmed with the different alignment properties flying around, where some are used on Flexbox, some are used on Grid, some are not. In the next chapter, I'm going to be doing a side-by-side comparison of the different alignment properties to help summarize what we're using where. But just stick with me for now. The align items property aligns grid items inside a grid cell along the column axis. The CSS property looks like this, where at the moment, the value start is being used. Looking at this in diagram form, we have our grid container, our vertical grid lines, our horizontal grid lines, and these define our grid cells. We then have our grid items inside the grid cells, and along the column axis, these grid items are at the start of their grid cell. So let's now take a look at the different align items values. We have align item start, where our grid items appear at the start of the grid cell along the column axis. We have align items end, where our grid items appear at the end of the grid cells along the column axis. We have align item center, where our grid items appear in the center of the grid cell along the column axis. And we have align item stretch, which again is the default value, and where our grid items will stretch the full height of their grid cell along the column axis. So let's go play around with this inside VS Code. Okay, I'm back inside the app.css file. I'm just going to go remove justify item center, so we can focus on the align items property. I'll refresh, and we know by default, our grid items will stretch the full width of the grid cell along the row axis. Now, at the moment, applying align items with a value like start won't do anything. And that's because our grid item currently is the same height as the grid cell. Just checking this out in DevTools. Our grid item is setting the height of the grid cell, so there is no space along the column axis to align the grid item. Now for this to work, I need to go add some height onto our grid container. Let's go add 500 pixels. It's also going to be easier to see the effect of align items if I just comment out the gap. So I'm going to do that and refresh. Let me just comment out align items. And you can see by default, our grid item is now stretching the height of the grid container. If I add align items back in and set its value to stretch, which is the default value, you'll see there's no change. Let's go play around with the different values now. I'm going to change this to start. You'll see that the grid item now appears at the start of each cell along the column axis. Let's change it to end. To better see this, let's open up DevTools. You can see that each grid item is now aligned at the end of each grid cell along the column axis. And the final value is center, where you can see the grid item is centered inside the grid cell along the column axis. And just like Flexbox, you can of course use these properties together. So let's go set justify items to a value like end. I'll refresh, and you can now see our grid item is at the end of the grid cell along the row axis and is in the center of the grid cell along the column axis. So let's now take a look at some grid alignment guidance. It is common to use grid alignment properties when one grid item is larger than another. Looking at this web page here, this content is inside a grid container. We have our two grid items. I'm going to add in the horizontal grid lines and vertical grid lines, and you can see the image sets the height of the container. So align items is used to center this grid item along the column axis. Let's go check out an example of this. So on this page, I'm going to scroll down to this section here, where we have a grid layout. I'm going to open up DevTools, and I'll select the grid. You can see this image on the left is setting the height of this row. And the group text on the right, which is the other grid item, has a height smaller than the image on the left, which means that there's space for this grid item to move along the column axis. Looking at the CSS properties, you can see a line item center is being used. If I turn this off, you'll see the content moves to the top. Now we know the default value is stretch, so if there was background color on this grid item, you would see that background color be the same height as the image. But this is a great example of where we're using the align items property to center a grid item when the other grid item sets the height. Moving on to the next piece of guidance, it is common to use grid and flexbox in parallel to achieve more precise control of layout. Looking at this page as an example, all of this content would be inside a grid container with our grid items. I'm going to add in our grid lines, and for this layout, grid controls the overall structure. But now instead of using grid alignment properties, we can use flexbox inside the grid items, where flexbox controls the alignment inside the grid item. Our grid item would essentially be turned into a flex container, where we would have these two flex items. And then we can use the flex properties for spacing and alignment, as well as properties like gap. So let's see an example of this in the browser. So on this page, I'm going to scroll to the bottom, and we have this review section over here. I'm just going to zoom out a bit. I'm going to open up DevTools. I'll select this section. You can see it's a grid, which is controlling the overall structure of this section. If I expand this, you'll see each grid item is a flex container, where Flexbox is being used for precise controlling of the flex items. And the same thing for the grid item on the right. This is also a flex container, where once again, Flexbox properties can be used for precise alignment. So let's build the next summary card, grid cell alignment. In this chapter, we looked at the two grid cell alignment properties. The first was justify items, which aligns content inside a grid cell along the row axis. We saw there were four possible values. The first was start, where our grid items are at the start of the grid cell along the row axis. There was end, where our grid items are at the end of our grid cell along the row axis. There was center, where our grid items were centered inside the grid cell along the row axis. And then there was stretch, which was the default value, and our grid items stretched the full width of the grid cell along the row axis. The second value we looked at was align items. This aligns content inside a cell along the column axis. The first value we looked at was start, where our grid items were at the start of each grid cell along the column axis. The next value was end, where our grid items were at the end of each grid cell along the column axis. The next value was center, where our grid items were centered inside the grid cells along the column axis. And the final value was stretch, which is the default value, and is where our grid items stretch the full height of the grid cell along the column axis. So let's go use the grid alignment properties on our Quill homepage. We have our grid container and our grid items. We've already established some vertical gap and some horizontal gap. So to achieve the layout we want here, we need to go position our grid items inside the grid cell. Now, just like the other examples we've seen throughout this chapter, the image is setting the height of each row. This then creates space along the column axis, that is vertically, for our grouped text. So align items is used to center the grouped text inside the grid cell vertically. Now, the width of our image is also less than the width of each grid cell. In our project, we're using the fractional unit to define our columns based on the full width of the page. Now, for our desired design, we want to center our image horizontally inside each grid cell. And because there's space to move horizontally, that is along the row axis, justify items is used to center the image horizontally. So let's go add this to our project. Alright, so I'm back inside our app.css file for the Quill homepage. We have our grid properties here inside the CSS file, and you can see the grid on the features section over here. I'm going to open up DevTools so we can see what's happening with our grid cells. Now for the height of each row, the image is setting the height, which means that for the group text on the left, there's vertical space for the group text to move vertically along the column axis. Inside the grid cell on the right, because our grid container is expanding the full width of the page, and the columns are using fractional units, means that there's space inside the grid cell horizontally, so our image can move along the row axis. Let's first go center our image horizontally along the row axis using the Justify Items property. I'll grab Justify Items and set its value to center. I'll refresh, and you'll see the image has now centered horizontally inside the grid cell along the row axis. Now, of course, Justify Item Center is being applied to every single grid cell because it's set on the grid container. We just don't see the effect of this on the text because the text is currently expanding the full width of the grid cell, so there is no space for the text to move. Let's now vertically center our text using Align Items. We'll set its value to center, and I'll refresh. And you'll see now our text is nicely vertically centered inside the grid cell. And once again, Align Item Center is also applying onto our image, but because the image is setting the height of the container, there is no additional height for our image to move up and down along the column axis. So Align Item Center has no impact. Alright, let's go check out our page in full screen. So this is starting to look great. Each text is now vertically centered, giving nice visual balance between the image and text, and each image is also centered horizontally inside its grid cell. Let's now continue by learning about how to align the entire grid structure within its container using grid alignment. We'll be discussing the Justify Content property, the Align Content property, and items versus content. So what is grid alignment about? Entire grid tracks can be aligned and distributed when there is extra space in the grid container. Looking at this in diagram form, we have our grid container, our grid items. I'm going to add in our grid lines. We have our grid rows, and we have our grid columns. Now, grid alignment is about how we can move the grid tracks, that is, the rows and columns, when there's extra space inside the grid container. This is different to grid cell alignment we looked at in the previous chapter, which was about aligning grid items inside grid cells. For grid alignment, we're moving the entire grid, that is, the different grid tracks, inside the grid container when the grid container has extra space. Now, as a general rule of thumb, I will say that grid cell alignment, what we looked at in the previous chapter, is a bit more commonly used than grid alignment, as it isn't too often your grid container is larger than your actual grid. But for completeness, we do need to cover this. So let's take a look at the first alignment property, which is Justify Content. And this is the same property as we've seen in Flexbox. It's just now being used in the context of grid. Justify Content in CSS Grid aligns entire grid columns along the row axis. So in CSS, it looks like this. The property Justify Content, which is the same as we've seen in Flexbox with a value like space evenly. Looking at this in diagram form, we have our grid container, our grid items. I'm going to add in the horizontal grid lines, and I'm just going to overlay the grid columns over our grid items. So the Justify Content space evenly property is aligning our grid columns, shown in red, along the row axis. So let's now take a look at all the different Justify Content values. They're actually the exact same as what we've seen earlier in Flexbox. We have Justify Content Start, which is the default value. We have our grid container, and our grid columns would be at the start of the row axis. The next value, Justify Content End, where our grid columns are at the end of the row axis. Justify Content Center, where we have our grid columns centered along the row axis. The next value, Justify Content Space Between, places the far left and far right grid items right up against the edge of the grid container, and any remaining grid items are inserted with equal space between them. For Justify Content Space Around, the grid container is essentially divided into 4 equal horizontal sections, and the grid columns are then inserted inside. So we end up with equal spacing between our grid columns and half the spacing between the far left and far right grid columns and the edge of the grid container. The last value, Justify Content Space Evenly, is when there's just equal spacing between each grid column and the edges of the grid container. So let's go play around with these inside VS Code. Alright, so I'm back inside the app.css file we were playing around with in the previous chapter. The first thing I'm going to do is just go remove the Align Items and Justify Items property, which we know has to do with alignment of grid items inside grid cells. So we don't need those properties for this chapter, so I'll remove those and refresh. I'm also just going to clean this up a bit. I want to get rid of these gap properties. Now, in order to demonstrate grid alignment, we need to set up our grid so our grid rows and columns have space to move inside the grid container. So in order to do that, we need to make a few modifications. I'm just going to update this height to 800 pixels, and I'm also just going to uncomment the width and change its value to 800 pixels. So now we're working with a grid container with a width and height of 800 pixels. I'm going to also give the entire grid container a background color of black so we can see it. I'll refresh, and let's talk about what's happened. Because our columns are being defined with fractional units, it just means that the width of each column is going to automatically calculate as 50% the width of the grid container. So each of these grid columns are each 400 pixels wide. Because we're not using grid template rows to explicitly define the number and height of rows, the number of rows is automatically calculated based on the number of grid items, which is 8, and number of columns, which is 2. So the result is 4 rows. Because we're not explicitly defining any height, it appears as if each grid item is the full height of the row. Now we know from the previous chapter what's actually happening is that the Align Items property has the default value of stretch. So if I refresh, you'll see no change. But if I change this to a value like start, you can see the black grid container appearing in the background, where the grid item is just the height of the content. But you can see the actual grid row is being automatically calculated as the height of 800 pixels divided by the number of rows, which is 4. So the height of each row is 200 pixels. I'm just going to go remove the Align Item start. And what I now want to do is actually go and explicitly define grid template columns and grid template rows in pixels, so that I can ensure our rows and columns have a width and height smaller than the grid container. So let's go update this to 100 pixels and 100 pixels. And you'll now see our columns are only 200 pixels wide, leaving 600 pixels of space along the row axis. Let's also go define grid template rows. We'll keep it as 4 rows, each with a height of 100 pixels. I'll refresh. So we now end up having our grid rows with a height of 100 pixels, meaning the total height of the grid container is now 400 pixels, which means that there's 400 pixels of space along the column axis. So in summary, I've just gone and defined specific heights and widths of our columns and rows, which is less than the width and height of the entire grid container. And this puts us in a position where we now have space along the column axis and the row axis for our grid columns and rows to move. So let's go play around with the Justify Content property. We'll set the first value to start, which is just the default value, so there's no change. Our grid columns are at the start of the row axis running from left to right. Let's update this to end, and you'll see our grid columns shift to the right. That is the end of the row axis. The next value is center. I'll refresh, and you can see our grid columns are centered inside the grid container along the row axis. The next value was space between. I'll refresh, and you can see our grid columns move to the far left and far right, and if there was a third column, it would appear in the middle. The next value is space around. Because we have 2 columns, this effectively splits our grid container into 2, down the middle vertically, and then inserts our grid columns in the middle of each column. The final value was space evenly. I'll refresh, and this now creates even space between our grid columns and the edges of the grid container. Let's now take a look at Align Content. And again, this is the same property used in Flexbox, but now applied in CSS Grid. Align Content aligns entire grid rows along the column axis. In CSS, it looks like this, align-content with a value like center. In diagram form, we have our grid container, we have our grid rows. I'm going to add in the vertical grid lines, and Align Content distributes our grid rows along the column axis. So let's take a look at the Align Content values. We have Align Content start, which is the default. And in diagram form, it looks like this, where our grid rows are positioned at the start of the column axis. We have Align Content end, where our grid rows are at the end of the column axis. We have Align Content center, where our grid rows are centered along the column axis. We have Align Content space between, which pushes our top and bottom grid rows to the top and bottom edge of the grid container, with any additional grid rows spaced evenly between these. We have Align Content space around. This will divide our grid container into 2 horizontally, and then we'll insert our grid rows in the middle of those two sections. The final value is space evenly, which creates even space between our grid rows and the top and bottom edges of the grid container. So let's go play around with these inside VS Code. Alright, so I'm back in the file we were just working on earlier. I'm going to go just comment out the justify content property and refresh. Let's go grab our line content property, and let's first look at the value start. This is the default value, so we're not going to see any changes. And by default, we know that our rows will appear at the start of the column axis running from top to bottom. Let's change this value to end. I'll refresh, and you can see our rows now move to the end of the column axis, which is at the bottom. The next value is center. I'll refresh. This centers our grid rows along the column axis. The next value is space between. I'll refresh. This pushes our top and bottom rows right to the top and bottom edge of the grid container, and then equally spaces any grid rows between these. The next value was space around. I'll refresh. This essentially divides our grid container into 4 equal rows, and then inserts the grid row inside each of those sections. This means we end up with 2 times the amount of spacing between our different grid rows compared to the edge of the grid row and the edge of the grid container. The last value was space evenly. I'll refresh, and this creates equal space between our grid rows and the edge of the grid container. Now, I know throughout this topic, we've seen a lot of alignment properties when it comes to grid. So I do want to quickly summarize the differences of the properties, items, and content. Looking at the items properties first, we have justify items and align items. And these are more commonly used in CSS Grid. These properties align grid items when grid cells have extra space inside of them. Along the row axis, we use justify items, and along the column axis, we use align items. The values that each of these can take include start, end, center, and stretch. In diagram form, it looks like this. We have our grid container, our grid lines, and let's say we apply the properties justify items center and align items end. We end up with our grid items inside our grid cells looking like this, where along the row axis, that is horizontally, justify items is centering our grid items inside the grid cell, and along the column axis, that is vertically, align items end is placing the grid item at the end of the grid cell. So justify items and align items are about aligning grid items inside grid cells when the grid cells have extra space. For the content properties, we have justify content and align content. This aligns grid tracks when the grid itself has extra space. Along the row axis, we have justify content, and along the column axis, we have align content. For the values that justify content and align content can take, include start, end, center, space around, space evenly, and space between. Looking at an example of this, we have our grid container, and let's say we applied justify content center and align content end. This would mean that our columns are centered along the row axis, which is being defined by justify content center, and our rows are at the end of the column axis, being defined by align content end. Now, justify content and align content only work when the grid container itself has space, so that the rows and columns can move around. This is very different to the properties justify items and align items, which is about the movement of grid items inside grid cells. Now, as I'm sure you're aware, we also use some of these properties in Flexbox. So when it comes to Flexbox, align items, justify content, and align content can be used, where justify items is specific to grid. Just as a quick reminder, align items aligns flex items along the cross axis, justify content aligns flex items along the main axis, and align content is only used when our flex items wrap onto separate lines. So let's now wrap up this chapter with a new summary card, grid container alignment. We first looked at the justify content property, which aligns grid columns along the row axis when there is extra space inside the grid container. The different values we looked at include justify content start, which is the default value, and looks like this, where our grid columns, shown in red, are at the start of the row axis. The next value was justify content end, where our grid columns are at the end of the row axis. We then had justify content center, where our grid columns are centered along the row axis. The next value was space between, where our far left and far right grid columns are pushed right up against the grid container, and any grid columns between these will have equal spacing. The next value was space around. This essentially divided our grid container into 3 separate columns, and then inserts our grid columns in the center of these. So we end up with double the spacing between our grid columns compared to the grid columns on the far left and far right and edge of the grid container. For space evenly, this simply creates even space between our grid columns and the left and right edge of the grid container along the row axis. The next value we looked at was align content. This aligns grid rows along the column axis when there is extra space inside the grid container. It's the same values as justify content. We have align content start, which is the default value. This positions our grid rows at the start of the column axis. Align content end, which positions our grid rows at the end of the column axis. Align content center, which positions our grid rows in the center of the column axis. Align content space between, which pushes our top and bottom grid rows to the top and bottom of the grid container along the column axis, and any additional rows would have equal space between these. Align content space around divides the grid container into 2 equal rows, and then inserts the grid rows in the middle of these rows. This results in double the space between the grid rows and the top and bottom edge of the grid container and the top and bottom grid row. The final value space evenly creates equal space between the grid rows and the top and bottom edges of the grid container along the column axis. Now in our Quill project, we won't be applying these properties because our grid doesn't have any extra space. And it actually is fairly common in most web design for there not to be additional space to move the grid around. And that's why I mentioned the justify items and align items properties, which move grid items inside grid cells when there's extra space inside the grid cells, is a lot more commonly used. In the final chapter, we'll look at how to control the placement and behavior of elements inside a grid with grid items. We'll be discussing placing grid items, spanning grid cells, and aligning grid items. So let's first talk about placing grid items. Grid items are automatically placed in a grid based on the order they appear in the HTML. Let's look at some example HTML, where we have 6 grid items inside a grid container. In the CSS file, in the grid container class, we've activated grid with display grid and given this grid 3 columns, each 1 fractional unit. In diagram form, we have our grid container, and our grid items are going to be positioned based on their order in the HTML, where the HTML order is going from top to bottom. So by default, our grid items are positioned like this. In the first row, we have grid item 1, grid item 2, and grid item 3, going from left to right. And in the second row, we have grid item 4, grid item 5, and grid item 6, going from left to right. So by default, grid items fill up from left to right, row by row. Now, grid items can be moved to different cells. Let's go add on our grid lines and see how this works. I'm going to be moving grid item 6. That is the grid item in the bottom right corner. We can use the grid row property, which is grid-row, and the value is 1/2. So what is this value? The 1 corresponds to the start line, and the number 2 corresponds to the end line. This is the start and end line of where grid item 6 will be positioned in relation to the row, because this is the grid row property. Importantly, grid row is set on the grid item, that is specifically on grid item 6. So by setting this, grid item 6 moves to this row. That's because this row starts at 1 and ends at 2. You can see those numbers on the left edge of the grid container. So what happens is that grid item 6 will now move here. And by default, it's always going to go to the first column. But it's now positioned in the grid row defined by the start line of 1 and the end line of 2. Now, because grid item 6 moves to the slot where number 1 was, it means our other grid items need to move. So grid item 1 now moves to where grid item 2 is, grid item 2 to where grid item 3 is, grid item 3 to where grid item 4 is, grid item 4 to grid item 5, and grid item 5 to where grid item 6 was. So other grid items move automatically when placing a grid item. So we've looked at the grid row property. Let's now look at the grid column property. It follows the same format, where 2/3 now represents the start line and end line of a column. So setting this property will result in grid item 6 moving to this column. That is where the vertical grid line is starting at 2 and ending at 3. So grid item 6 will move here, and this will result in grid item 1 moving back to position 1. So using grid row and grid column allows you to have precise control of where you want grid items to be placed if you want to override the placement of how they appear in the HTML. So let's go play around with this inside VS Code. All right, so this is where we left off in the previous chapter. I'm going to go just simplify our grid container. There's a lot going on here we don't need. I'm just going to go remove all these properties and change our grid template columns to 200 pixels, just so that they're a bit bigger. I'll refresh, and we're now back to a simple grid, with our 8 grid items in 2 columns. The first thing I want to do is open up DevTools, so we can see our grid lines. So let's move grid item 6 to where grid item 2 is. To do that, I'm going to scroll down to grid item 6. Let's handle grid row first. The start line is 1, and the end line is 2. As we know, our horizontal grid lines are 1, 2, 3, 4, and 5, and you can see them down the left here. So we want grid item 6 for the row position, starting on grid line 1 and ending on grid line 2. So this will be 1/2. I'll refresh, and grid item 6 has now moved here. As I mentioned before, by default, if no grid column is defined, it will automatically go into the first column of that row. So let's now move it into this column here. We'll grab the grid column property, and we want it starting on grid line 2 and ending on grid line 3. You can see the numbers for our vertical grid lines, 1, 2, and 3. So to do this, we do 2/3. I'll refresh, and you'll now see that grid item 6 has moved from the position here to up here, and the other grid items have moved automatically. So let's now take a look at some placing grid items guidance. Placing grid items is used to achieve specific layouts. Looking at this example here, this kind of layout is common in a feature section, where we have alternating text and image in each row. Grid item 1 is the group text, grid item 2 is the image. This is in the first row. In the second row, the order swaps. So now the image is grid item 4, and the group text is grid item 3 in the second row. The reason this is the case is because in our HTML, it's best practice from a semantic perspective to have text followed by image. So in CSS Grid, we can use the technique of placing grid items to swap the order. For the third row, we would have grid item 5 for the text and grid item 6 for the image. Looking at this web page in mobile now, grid item 1 would be the text, grid item 2 is the image, grid item 3 is the text, and grid item 4 is the image. Now in the next topic, we're going to be learning about media queries and how we can achieve this. But what you'll see is that grid items need to change position on mobile. Now in actual fact, this positioning is just going to be achieved by just following the order of the HTML. But the grid items are changing position compared to what you see on desktop. And as I mentioned, we'll be discussing how to achieve this in great detail in the next topic. So let's now talk about spanning grid cells. Grid row and grid column can be used to have grid items span multiple rows or columns. Let's take a look at what I mean. Let's focus on grid item 1. We'll use the grid column property, where we're going to set the start line to 1 and the end line to 4. So you'll notice this time, the end line is not one increment above the start line, but several increments above. So what this results in is our grid item spanning multiple columns, like this. So grid item 1 is now spanning from the vertical grid line 1 all the way up until the end of the grid container, defined by grid line 4. Now because grid item 1 is now occupying the grid cell where grid item 2 and 3 are, our grid items need to move. So this is what happens. Grid item 2 is pushed down to where grid item 4 is. Grid item 3 is pushed down to where grid item 5 is. As a result of this, grid item 4 is pushed to where grid item 6 is. Grid item 5 goes on to another row, and grid item 6 also goes onto another row. So because of grid item 1 now spanning the entire row and entering into 2 grid cells, our grid items are moved to another row. Let's take a look at the same setup, but now focusing on the grid row property. Our start line is number 1, and you'll see now instead of an end line, I'm using the special notation of span with a number, where the number is the cells to span. So this is saying start at grid line 1 and span 2 grid cells. So the result will look like this. Our grid item 1 will span 2 grid cells. And just like before, because grid item 1 is now occupying another cell, our grid items need to shift around. Grid item 2 and 3 are fine where they are, but grid item 4 now needs to move to position 5, grid item 5 to position 6, and grid item 6 is going to be moved to another row. Now in reality, for most designs, you just simply wouldn't do this. you would ensure that the number of grid items is correct to achieve the layout you want. So you wouldn't be using 6 grid items here, you'd only be using 5. Let's go play around with this inside VS Code. Alright, so I'm back inside the file we were playing in earlier. I first just want to go remove the placement of grid item 6, just so we can restore everything back in order. So for this demonstration, I want grid item 5 to span 2 rows. So we'll go into grid item 5, we'll grab the grid row property, as we want to span 2 grid rows. I'm going to open up DevTools just so we can see our grid lines. So grid item 5, we want starting at grid line 3 over here and ending at grid line 5. So this will be 3/5. I'll refresh and you can see grid item 5 is now spanning these 2 rows. Grid item 6 is where it originally was. Grid item 7 has been pushed from over here to over here. And grid item 8 has been pushed onto a new row. Now this could also be achieved by typing span and the number 2. I'll refresh and you'll see there's no change. Now, as I touched on earlier, in your design, you wouldn't really have this happening with grid item 8 going onto its own row. In actual fact, you just wouldn't have a grid item 8. So I'm going to remove that. I'll refresh and you can see this is the layout we would achieve. So beforehand, you would know your desired outcome in terms of the design you're trying to achieve. And then when you're spanning your grid items, everything will fall into place nicely without grid items being pushed into new rows. So let's take a look at some spanning grid cells guidance. Grid cells can be spanned to create visually interesting designs. Looking at this example over here, we have our grid container. We have a grid item here, over here, and over here. I'm going to add in the grid lines. You can see the 2 grid items stacked on top of each other are spanning 2 columns, whereas the grid item on the right is spanning 2 rows. This kind of grid layout is actually fairly common on the homepage of a lot of tech companies. So let's now talk about aligning grid items. Grid cell alignment can be overridden for individual items. Now, this is not too common, so I wouldn't worry too much about it, but it is important you understand what it is. Let's say we have a grid container, and we apply justify item center and align item center. Inside our grid container, this would result in our grid items being centered inside the grid cells. So what I want to do now is focus on grid item 2, and we're now going to be applying properties to this specific grid item. The first property is justify self with the value of end. And what this does is aligns just grid item 2 along the row axis, overriding the justify item center applied onto the entire grid container. So focus your attention on grid item 2, and you'll see it moves to the end of the grid cell along the row axis. We can also apply the property align self, in this case with the value of start, and this aligns grid item 2 along the column axis, overriding the align item center value applied on the entire grid container. If you focus your attention on grid item 2, it will now move like this. It moves to the start inside the grid cell along the column axis. Now the values you can have for the justify self and align self properties include start, end, center, and stretch, where stretch is the default value. So let's go play around with this inside VS Code. Alright, so I'm back in the file we were working on earlier. For this demonstration, I'm just going to go add back in our grid item 8, and I'm going to go remove the grid row property on grid item 5. I'll refresh and we're back to where we started. Now for this demonstration, we need our grid cells to be larger than our grid items. Because our grid cells have a width of 200 pixels and the content number 1 is much smaller than the width of the grid cell, this will work fine horizontally. But for vertically, we need our grid cell to be higher, because the grid cell is just currently the height of the grid item. So to do this, I'm just going to go add some height onto the grid container, and let's make it 400 pixels. So you can see now, if I highlight number 1, there is height inside this grid cell. The background color red is just being stretched by default. So let's go position our grid items in the center of the grid cells. I'll grab the justify items property and set its value to center. I'll refresh, and you can see our grid items are now centered inside the grid cell along the row axis. Let's go center them as well vertically. We'll grab align items, set its value to center. I'll refresh, and you can see our grid items are now also centered vertically inside the grid cell along the column axis. So let's now go use the properties we learned earlier to only move grid item 3 into the top right corner of its grid cell. So for grid item 3, let's first position it along the row axis. We'll grab justify self and set its value to end. I'll refresh, and you can see grid item 3 has now moved to the end of the grid cell along the row axis. To move it to the top right, we'll grab the Align Self property and set its value to start. I'll refresh, and you can see grid item 3 has now moved to the start of the grid cell along the column axis. So the Justify Self and the Align Self properties are overriding the Justify Items and Align Items property set on the grid container. As I mentioned, I wouldn't worry too much about this as it's not too common to do, but you do need to know about it. So let's wrap up this chapter by building a new summary card, Grid Items. We first looked at placing grid items. Looking at grid item 3, we saw the grid row property places grid items along horizontal grid lines, where the number 1 is the start line, followed by a /, and the number 2 is the end line. The grid column property places grid items along vertical grid lines. So in this case, grid item 3 will stay in the first row, as that's defined by the horizontal grid lines 1 and 2, but it's going to shift its column defined by the vertical grid lines 2 and 3. So grid item 3 is going to move where grid item 2 is. As a result of this, grid item 2 will now move into position 3. We then looked at spanning grid cells. Focusing on grid item 2, we could use the grid column property to span grid item 2 across multiple columns. The number 2 is the start line, and the number 4 is the end line. It's the same notation as placing grid items, but for spanning grid cells, the end line will always be more than one increment above the start line. For this setup, grid item 2 will look like this, starting at the vertical grid line 2 and ending at the vertical grid line 4. Looking now at grid item 3, we can use the grid row property to span multiple rows. In this case, grid item 3 is going to start at the horizontal grid line 1, and we're using the notation here, span with a number, which defines the number of cells to span, in this case 2. So this will result in grid item 3 now spanning 2 columns where it starts at the horizontal grid line 1. The last concept we looked at was aligning grid items, where we saw we could override the alignment of specific grid items. In this case, our grid container has Justify Items and Align Items set to center. On grid item 5, we can set the Justify Self property to end, which will position grid item 5 along the row axis. And in this case, the value is end, so it's going to move grid item 5 to the end of the grid cell along the row axis. We can use the Align Self property to position the grid item along the column axis. In this case, grid item 5 will be positioned at the start of the grid cell along the column axis. Okay, so let's go use placing grid items to finish off the feature section on our Quill homepage. We have our grid container, our grid items, and in the middle row, we want to place our image where the grouped text is. So I'm back inside the app.css file for our Quill homepage. I'll scroll down to the grid, and we need to move this image over here and this text over here. Now to do this, I'm going to head to the HTML file, and for the middle row, on this image, I'm going to go add a class, so that we can select it and move it. That's this image over here. It currently has a class already, feature-image. We're going to go define a new class, which is feature img swap order. I'll just copy this. I'll head back to app.css. I'll select this class. I'm going to zoom out a bit and open up DevTools so we can see our grid lines. So we want our image over here, which we've just given a new class, to remain in the current grid row, which has a start line of 2 and an end line of 3. And move to this column over here, which has a start line of 1 and an end line of 2. So let's go do the row first. We'll grab the grid row property. It has a start line of 2 and an end line of 3. For the grid column, it has a start line of 1 and an end line of 2. I'll refresh, and you'll see now we've moved this image over here, and as a result, the text is pushed onto the right, with the other grid items unaffected. Now, just to highlight, even though the image remained in the same row, that is defined by the start line 2 and the end line 3, if I didn't define that, it by default will move up to the top row. Alright, so let's take a look at our page in all its glory. Our hero section is looking great. Our feature section is now looking beautiful with the use of CSS Grid. And our call to action section is also looking superb. Now in the next chapter, we're going to be learning about media queries, which is all about responsive design for different screen sizes. Now, there are just 1 or 2 things that are annoying me about this page that I want to fine tune. For some reason, this is still black. So we're going to go make that white. And the other thing annoying me is that these anchor tags down here are not styled for different states. In the pseudo-class section of the course, we focused on states for buttons. And I kind of said these weren't that important to do, but they are annoying me now, so let's go fix those up. All right, so in our app.css file, our heading over here is defined by the CTA heading. In the HTML file, you can see in the CTA section, we have CTA heading. So let's simply go add the color property. We have the white color stored in a variable with the name white. I'll refresh, and the get started now text is now white. For these anchor tags down here, we're going to scroll up to our global styles. And at the moment, this is how we're defining our anchor tags. But let's now go add pseudo-classes onto these anchor tags for different states. As a reminder, for our buttons, we group together the link and visited states and hover and active states. So let's go first do the anchor tag link pseudo-class and anchor tag visited pseudo-class. For these, I just simply want to apply our base text color. Scrolling up, this is simply our gray base. I'll copy this and I'll paste it over here. I'll refresh, and you can see our anchor tags now look a lot more in line with our design. Now, in actual fact, I don't really care about different colors for the hover and active state. So in fact, I'm just going to group these all together, hover and active, and I'll refresh, and this will just ensure that for any state, our anchor tags remain this color. All right, the final thing I've noticed is that this heart over here should be purple. So let's quickly go do that. In index.html, I'm going to scroll down to our footer. As this is a text element we want to style, we're going to go add some span tags. I'll copy the heart, place it in the spans. I'm going to give our spans a class of heart icon. I'll copy this text. In app.css, I'm going to scroll down to our footer. Below the social icons, I'll select this class, and I want to give it our secondary color. We store this in a variable, which is secondary base. I'll refresh, and we now have our beautiful purple heart. All right, so our homepage is basically done. In the next chapter, as I mentioned, we're going to learn about responsive design so that our page can adapt to different screen sizes, because at the moment, it's only designed for desktop. Great work! CSS Grid is now complete. With both Flexbox and CSS Grid in your toolkit, you've taken a major step toward mastering modern web layouts in CSS. It's now time to learn about responsive design. Responsive design ensures that websites look great on all screen sizes, from mobile devices and tablets to large desktops. In this topic, we'll explore how to use media queries along with relative units and fluid layouts to create flexible, adaptive designs that adjust seamlessly across different screen sizes. Let's begin by learning how to make websites responsive across different screen sizes with an introduction to responsive design. We'll be discussing responsive design, media queries, relative units, and fluid layouts. So what is responsive design all about? Web pages were originally designed only for desktop computers, as they were the only device available to access the internet. As I'm sure you know, a desktop computer is a fairly hefty machine that sits on your desk. Now today, there are a variety of devices with different screen sizes, so web pages need to adapt for a more functional user experience. Looking at the range of different devices we have our desktops, we have laptops, which are smaller and more portable computers, we have tablets, and we also have smart mobile devices. Now for a good user experience, a web page appears different between different devices. Let's take a look at an example of this. Okay, so I've opened up DevTools, and I've clicked the toggle device icon here. This allows me to change the width of the browser so we can see what happens. At the moment, I'm at 2000 pixels wide. This would be a very large desktop computer. Let's come and reduce the width a bit and see how the elements and layout changes. You can see at this point, the layout completely changes. The image, which was on the right, has now moved below. Let's continue to reduce the width. You can now see the layout again changes, with the buttons going the full width of the screen and the font size reducing. Some spacing properties like margin and padding would also have reduced. Let's continue. So as you can see from this, as we reduce the width of the browser to simulate the web page at different screen sizes, the web page totally changes, both in layout, that is, where elements are placed on the page, as well as the size of properties, like font size, and different spacing properties like padding and margin. Now, responsive design is powered by three main pillars. The first pillar is relative units, like percentages and rems, which we've covered at length in the course already, and we'll be discussing more soon. The next pillar is fluid layouts. This is Flexbox and CSS Grid, which we've also already covered at length. And the third pillar we need to learn about now is media queries. So what are media queries? Media queries apply styles to a web page based on specific conditions. In CSS, it looks like this. We declare an @media, which is a special rule called the @rule. We then have some regular brackets, where inside we set a condition. In this case, a max width of 500 pixels. And then just like regular CSS rules, we have our curly brackets, and inside these, we apply specific styles, like an H2 with a font size of 14 pixels. So what this is essentially saying is that when the page is less than 500 pixels, apply these rules. So let's go look at this a bit more in diagram format. I'm going to set up an axis here with different browser width values. We're going to start with 0 pixels. The next value will be 500 pixels. The next value 1000 pixels. And the last value 1500 pixels. So let's go and apply different media queries for an H2 heading. We'll start when the browser is less than 1500 pixels. That is this range over here. We would define our media query like this: @media with a max width of 1500 pixels. And inside that media query, we're setting the H2 to have a font size of 24 pixels, which would look something like this. Let's now go add a media query for pages less than 1000 pixels. That is this range over here. That would look like this: @media with a max width of 1000 pixels, where our H2 is now a different font size of 18 pixels, which would look something like this. And finally, let's go change our H2 for browser widths or screen sizes less than 500 pixels. That is this range over here. And that would look like this: @media with a max width of 500 pixels. And inside there, we have our H2 with a font size of 14 pixels, which would look something like this. So you can see at different screen sizes, our H2 font size will be different. Now, some global styles like colors and fonts are applied no matter what the screen size is. So these are actually defined outside media queries, and we'll be looking at this inside VS Code soon. For example, let's say the H2 has a font family of Poppins. It's very rare we actually want to change that for different screen sizes. So that kind of property is a global style which isn't set inside a media query. Now, the important thing we need to get our head around is that the order that these media queries appear in our CSS is really important. For example, let's look at a browser width or screen size which has a width of 300 pixels. Now, if you think about it, in fact, all of these media queries are applying. For the max width of 1500 pixels, this applies when the screen size is less than 1500 pixels, and 300 pixels is less than this. So this is applying a font size of 24 pixels. For the media query max width 1000 pixels, this applies when our browser width or screen size is less than 1000 pixels, and 300 pixels is less than this. So the font size of 18 pixels is also applying. The last media query, with a max width of 500 pixels, will apply the H2 style when the browser or screen size is less than 500 pixels, and 300 pixels is less than 500 pixels. So the font size of 14 pixels is also being applied here. So how does this actually work? So if all the media queries are applying, how do we ensure that for a screen size of 300 pixels, only the top one, which sets a font size of 14 pixels, is applying? To solve this, we use the CSS Cascade. We would have the largest max width value first, like this, and then we would go down in descending order. So after this would be the max width of 1000 pixels, and after this, a max width of 500 pixels. So effectively, our media queries are going in descending order of their max width value, which means that the smallest screen is always last. And as we know from the CSS Cascade, when we have conflicting styles, later rules will always win. So in our example, with a browser width or screen size of 300 pixels, all the different H2 font size values are trying to be applied because the condition is met, but it's only the last one that is actually applied because that appears last in the CSS. So I just wanted to get across the order that we put our media queries in our CSS file is incredibly important. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up an index.html file, and I've linked a style sheet which is currently empty. I'm going to come inside the body and just add an H1 with the text media queries. Inside app.css, I'm going to select this H1. I'm going to give it a color of red, a font size of 80 pixels, and let's go change the font family to Georgia here. So let's check this out in the browser. All right, so I'm going to open up DevTools. I'm going to come to the toggle icon here, and this will allow us to change the width of the browser. Now, as you'll expect, as I change the width, nothing is happening. But let's go add some media queries now so that the styles will change as we change the width of the browser. We'll get our @rule of @media. We then grab regular brackets, and I'm going to go use the values we used before. I'm going to get a max width and set its value to 1500 pixels. Then grab our curly brackets like usual, and inside here, we now add different CSS rules. I'm going to select the H1, I'm going to give it a color of blue, and I'm going to change the font size to 60 pixels. So what this is saying is that between 0 and 1500 pixels, apply these styles. At the moment, I'll save and refresh. I'm just going to extend the browser a bit further. You can see I'm currently at 1559 pixels, which means this max width is not yet taking effect. So these global styles are being applied. When I come and reduce the width of the browser to less than 1500 pixels, you'll see the H1 changes to a color of blue and a font size of 60 pixels. So these styles have now been overridden. And because I'm not changing the font family value, because we would consider this a global style, which lives outside the media query, that doesn't change. Let's now go add another media query. I'll grab @media, we'll get max width, and set its value to 1000 pixels. We'll grab our curly brackets, and again, we'll select the H1, and let's now change it to have a color of green and a font size of 40 pixels. Okay, I'll refresh. So because our width is 1041 pixels, this rule is being applied. But now watch what happens as I reduce the browser to less than 1000 pixels. I'm now at 900 pixels, and you can see the H2 is now green with a font size of 40 pixels. And as I mentioned earlier, the order you put the media queries in is really important, because both of these are trying to be applied. Because 900 pixels is less than 1500 pixels and less than 1000 pixels, both these CSS rules are attempting to be applied, but only this one applies, which is what we want, because it appears last in the CSS file. When I select the H1 in DevTools, you can see the media queries coming into play. The max width of 1000 pixels is being applied, and you can see over here, this media query is also attempting to be applied, but it's being crossed out because it appears before this media query here in our CSS. I also want you to note that the original styles of color and font size are also being striked out because they appear before our media query rule here, but the font family is still being applied, which is a global style we don't want to change as the width of the browser reduces. Okay, let's go add our last media query. We'll grab @media, we'll set a max width of 500 pixels, we'll grab the H1, we'll set the color now to orange, and we'll change the font size to 20 pixels. I'll refresh, and let's now go reduce the width of the browser. You'll see as I hit 500 pixels and below, the H1 now changes to orange with a font size of 20 pixels. So let's go and play with all the different values we have now. I'm going to extend the browser to a value bigger than 1500 pixels. You'll see it starts red. As I reduce, it changes to blue with a smaller font size. It then changes to green with a smaller font size, and then finally changes to orange with an even smaller font size. All right, so what I want to do now is set up a small project we're going to be working on in this chapter. It's going to allow me to demonstrate the 3 different pillars of responsive design I touched on earlier. That is relative units, fluid layouts, and media queries. So I prepared the HTML ahead of time. I have a main div with the class reviews grid, and this contains 4 grid items. Over here, over here, over here, and over here. The grid items are the same structure, just with different content. Each review card contains an H3 with the class review heading and some review text, like review 1, a paragraph with the class review text with some review content, and then finally another paragraph with the class review person with the name of the person who gave the review. As I mentioned, this structure is repeated for all 4 grid items, and only the content changes between them. So let's open app.css and push it on the right here. So what we're going to go do is make a 2x2 grid, which would form the review section of a web page. Let's first grab our Universal Selector to do a CSS reset. I'm going to strip the padding away by giving it a value of 0, and strip the margin away by giving it a value of 0. Let's also go change our box sizing value to border box. Okay, next up, let's go grab the body tag. Let's go give it a font family of Arial, and I'm going to give the entire body a background color of light gray. So let's now go make our grid. The grid container is being defined by this class here. So let's go select reviews grid. To activate CSS grid, we change the display property to grid. Because we want our grid to be 2x2, we're going to go grab grid template columns and give it the value 1FR, 1FR, which defines our 2 columns, which will take up equal width of the available space. Let's give the entire grid review a max width of 1200 pixels. All right, let's check this out in the browser so far. All right, so nothing special, but we have nicely set up our grid structure. I'm going to go add some column and row gap to better separate these out. So I'll add a gap property with a value of 20 pixels. Now at the moment, our grid is stretching the full width of the screen and sits right at the top over here. So let's just go give it some margin. I'm going to give it 100 pixels top and bottom and give it the value auto for left and right. So this has now moved our grid 100 pixels down, and there's also some margin 100 pixels below. And if I open up DevTools and go to a width beyond 1200 pixels, like this value here, you can see our grid has nicely been centered. Where we know from previous chapters, the auto value applied left and right will calculate available space and divide it equally left and right. All right, so let's now go add some styles to our review card. In our HTML, that's this div over here. So I'll select review card. We'll give it a background color of white. I'm going to add padding all around the card of 20 pixels. Let's give it a border of 1 pixel solid and dark gray, and a border radius of 8 pixels. All right, I'll refresh, and you can see now our cards look a lot more like cards. Let's now go and apply some styles to the different text elements inside our card. We have review heading, review text, and review person. Let's start with review heading. I'll select that. We'll give it a font size of 40 pixels and a font weight of 700. I'll refresh, and you can see the review text goes a lot larger. Let's now go handle the review text here. That was the class review-text. We'll just give it a font size of 20 pixels. I'll refresh. And the final style is review person. Let's give it a font size of 18 pixels, and we'll change the font weight to 700. Okay, let's refresh. All right, the last thing I want to do is just create a bit more space inside these cards. So review heading, I'm just going to go grab the margin bottom property and set its value to 20 pixels. And on the review text, let's go grab margin bottom and set the value to 10 pixels. All right, so we've set up our review grid. Now, as I reduce the width of the browser, you'll see this viewing experience doesn't look great as the browser reduces. First of all, the content is butting up all the way left and right. The font size and all the elements is just too large for smaller screen sizes. And some of the spacing values, like the padding and margin, also makes it look a bit awkward. And finally, this grid layout is just not working anymore. It would be much better to now break the grid layout so that each review just stacked on top of each other. So let's now go use media queries to improve this for different screen sizes. The first media query, we'll grab our @media, open up our brackets. I'm first going to do different styles for a max width of 1000 pixels. So the rules I define here are going to apply when the browser is less than 1000 pixels. Let's first select our review card. The current padding there is 20 pixels. Let's go reduce that to 15 pixels. And then I'm going to grab the review heading. Currently, the font size there is 40 pixels and the margin bottom is 20 pixels. Let's change the font size to be 30 pixels and the margin bottom to be 15 pixels. For the review text, the font size is 20 pixels and the margin bottom is 10 pixels. So let's go reduce those values. We'll change the font size to 16 pixels and the margin bottom to 8 pixels. Finally, for the review person, its font size is 18 pixels. So let's go reduce that. We'll change its font size to 14 pixels. Okay, so let's check this out in the browser. I'll refresh. I'm now going to reduce the browser to a width less than 1000 pixels. And you can see how everything updated. This now looks a lot more appropriate for this screen size. So just to show you again, this is how we started. As the screen size reduces, the review card padding reduced, and the font size and margin bottom values also reduced. However, as I keep going smaller, you can see this also doesn't look great. We want to continue to reduce some of these values. So let's go add another media query. Just to make this simple, I'm going to copy this one and paste it below. I'm just going to change the max width value to now 500 pixels. So these rules will apply when the browser is less than 500 pixels. Let's go change our review card padding to 10 pixels, our review heading font size to 20 pixels, the margin bottom to 10 pixels, the review text to a font size of 14 pixels, and a margin bottom of 5 pixels, and the review person to have a font size of 12 pixels. All right, I'll refresh and watch what happens as the browser reduces below 500 pixels. All the font size and spacing values like padding and margin adjust. So let's go through the whole spectrum. We start here, hit a value less than 1000 pixels, continue down, and then again hit a value less than 500 pixels. And you can see that for each of these screen widths, the reviews grid is now better designed. So you can see how we've effectively used media queries for different screen sizes. Now, the only problem with this approach is that for every single property, we had to manually go change its size. And this is just a bit of a painful exercise. And that's why relative units is one of the other pillars of responsive design, where relative units avoid us having to define these for every single property. So let's now look at relative units in more detail. Relative units ensure elements scale proportionally based on parent container size or scalable reference points. Parent container size is all about percentages, and scalable reference points is all about rems. Let's look at an example of using these. The web page on the left is in desktop view, and on the right in mobile view. Percentages is used on a main page container to ensure that when the container scales down on a mobile device, there is still space left and right, so the content isn't butting up right against the screen. Percentages are also used on elements like images, so that on smaller screens they scale down. Rems are very commonly used for spacing, like margin and padding. On the web page on the left, there's margin between the navigation bar and the main heading, and this margin value would be reduced on a mobile device. Rems is also very commonly used on text. So this heading over here would use a larger rem value compared to the rem value on a mobile device. Alright, so I'm back inside the project we were working on earlier. Inside our HTML, I want to go define a main container to contain all the content. I'll grab a new set of divs, I'll cut all this content, and paste it inside the div. I'm going to give the div a class of main container. Inside the CSS, below the body tag, I'm going to add our main container class. I'm first going to center the main container by setting the margin value to 0 top and bottom and auto left and right. It's then common to define a max width so that our content doesn't stretch too wide on live screens. I'm going to give it a max width of 1200 pixels. And then I'm also going to go add a width and give it a value of 90%. And this will ensure that on browser windows less than 1200 pixels, the width of the content is only 90%, which will ensure that there's space left and right so the content doesn't butt up right against the edge. I don't want to refresh just yet, so I can show you how when I reduce the width of the browser, the content is going right up to the edges. I'll refresh now, and you can see now our content doesn't go all the way to the edges and is an improved viewing experience. Okay, so you can see our percentages is very helpful for responsive design on an element like a main page container. Alright, we're now going to be shifting it up a gear and talking about rems in the context of media queries, as there's a few funny things we need to get our head around. The first thing I want to discuss is rems inside media query conditions. The rem value inside a media query condition is always based on the default browser font size. Now, I want to be very clear here. I'm specifically talking about the media query condition. That is, the max width value we're setting inside the brackets. And we know that from previous chapters, the default browser font size is 16 pixels. Alright, so this seems very confusing. So let's go through it step by step. Let's say we had a CSS file with the rules defined here. We know that it's very common to set the root HTML font size to 62.5%. That's because 62.5% times 16 pixels, which is the default browser font size, is 10 pixels. And we do this because 10 pixels is a much easier unit to work with compared to 16 pixels. Because the default browser font size is 16 pixels, that means that by default, one rem is 16 pixels. But by adding this line of code, we've now changed it so that one rem is 10 pixels. And this makes using rems inside our CSS a lot simpler, where 4 rems would be 40 pixels and 2 rems is 20 pixels. Now let's move over to our media query condition. You can see inside the brackets, I currently have set a max width of 31.25 rem. Now, the important thing that we need to understand is that the rem value inside this condition, that is over here, is still based on the default browser font size. That is, 1 rem equals 16 pixels. So even though we've adjusted the rem value in our CSS on the left by changing its font size to 62.5%, that is 10 pixels, this doesn't carry through into the rem value used in the media query condition. That's still based on the default browser font size. So effectively, this media query has a max width of 31.25 rems, which would be 31.25 times 16 pixels, which is 500 pixels. So it's really, really important to realize that the rem values inside the conditions is based on 16 pixels, and not what you define when setting up the font size on your root HTML. Alright, so I'm back inside our project. Load the Universal Selector. Let's select the root HTML element, and let's change its font size to 62.5%. This effectively adjusts the default font size in the browser of 16 pixels to 10 pixels. That is 16 pixels times 62.5% equals 10 pixels. And we know that this is much better practice compared to just changing it to 10 pixels like this, because this overrides the different font sizes in the browser. And let's go change the condition to use rems instead of pixels. Now, even though we've adjusted our rem value to be based on 10 pixels, as we've just discussed at length, this value is still based on the default 16 pixel font size value. So to change this to 1000 pixels, we need to calculate 1000 pixels divided by 16 pixels, which gives us 62.5. So we need to now adjust this max width value to 62.5 rem. Just to check this works, I'll refresh, and let's go scale our browser down to 1000 pixels, and you'll see that the styles inside this media query are being applied. Now, just to highlight why this could be confusing, is that because in our HTML root element, we've set our font size to 62.5%, which is effectively 10 pixels. So you may have thought that the 1000 pixels we had here before, if we wanted to change this to rem values, it would be 1000 pixels divided by 10 pixels, which is the value currently sitting on our root HTML element. So this would then be 100, which means that you would come and change this to 100 rem. But the rem value inside this condition is 16 pixels, even after adjusting the font size of the root HTML element here. So this is not actually 1000 pixels, it's 100 times 16, which would be 1600 pixels. So long story short, it's just really important to realize that the rem value specifically inside the media query condition is still based on the default font size value of 16 pixels. So we'll leave that as 62.5 rem. Let's go adjust the other max width value here to rems. So to work out the rem value, we do 500 pixels divided by the default browser font size of 16 pixels, which gives us a value of 31.25. Let's go change this to 31.25 rem. And just to check it works, let's go down to 500 pixels, and you'll see that when we hit that value, all these styles now apply. Now, there's a few reasons why we want to use rem values inside our max width condition, as opposed to pixels. One of the reasons is that we're going to be using rem values throughout the project for our other units, so this keeps things more consistent. And it also ensures if someone ever did go adjust the font size in their browser, everything would still be consistent. So it's just better practice to use rem values inside your media query conditions as opposed to pixels. So now that we've spoken about rem values inside the media query condition, let's now go talk more about how we use rem values inside the media query itself. So we'll now be looking at detail in how we use rems inside media queries. Rem values scale proportionally, adjusting both existing and new values based on the updated root font size. So let's take a look at what I mean here. Let's say we have this CSS file. We've changed the root HTML font size to be 62.5%. That is 62.5% multiplied by 16 pixels, the default browser font size, gives us a font size of 10 pixels. This now means 1 rem is equal to 10 pixels, which is a much easier unit to work with when sizing CSS properties compared to 16 pixels. Let's now look inside our media query. We've defined a max width of 62.5 rem, and as we've just discussed, the rem value inside the condition is based on the default browser font size, which is 16 pixels. So this max width would kick in at 62.5 multiplied by 16 pixels, which would be 1000 pixels. Inside the media query, you can see we've changed the HTML font size to 50 pixels. What this now means is that for screens less than 1000 pixels, the root HTML font size is 50% times by the default browser font size of 16 pixels, which is 8 pixels, which means that 1 rem is now 8 pixels. So our rem value has now been reduced from 10 pixels to 8 pixels. That is, it has been reduced by 8 pixels divided by 10 pixels, which is 80% of the original size. So let's first look at how this affects existing properties using rems. When I say existing properties, I mean properties already defined in our CSS. In this case, the H1, which has a font size of 10 rem and a padding of 5 rem. All properties using rems will automatically shrink to 80% of their original size. So the font size was originally 10 rems and had a padding of 5 rems, which means the font size is 100 pixels, 10 times 10 pixels, and the padding is 50 pixels, 5 times 50 pixels. But now inside our media query, when the screen is less than 1000 pixels, our H1, which is defined outside the media query, now shrinks by 80%. That is, the font size will now shrink from 100 pixels to 80 pixels, and the padding will shrink from 50 pixels to 40 pixels. And this is all being controlled by changing the root HTML font size inside the media query. Let's go play around with this inside VS Code. All right, so I'm back inside our project, and we're now going to go use rems to write more efficient CSS. So initially what we're going to be doing is just updating a lot of our pixel values to rem values. And then we'll see inside media queries how we can adjust the font size of the root HTML element to write more efficient CSS. Now, usually with max width values, we do leave those in pixels. So I'm not going to touch those. For the gap property, I am going to come and change this to rems. Now, once again, the font size on our HTML root element is 62.5%, which means that 1 rem equals 10 pixels. So let's change 20 pixels to 2 rem. For the margin, we'll change 100 pixels to 10 rem. On the review card, we'll change 20 pixels here to 2 rem. For border, we do usually use pixels. And for border radius, we also use pixels. So I won't change those. On the review heading, the font size will change to 4 rem. And margin bottom will change to 2 rem. For the review text, we'll change this to 2 rem. And the margin bottom to 1 rem. And finally, for the review person, we'll change this to 1.8 rem. Okay, I'll refresh and you'll see there's no change. And that's just because I've just updated our values to use rems instead of pixels. But now let's see the magic of rem units. As I mentioned earlier, inside this media query, I'm having to explicitly change every single property that uses pixels. I'm having to reduce the pixel value of every single property. Now, this is a small project, but you could imagine for a homepage with many more sections and components, this would be very painful to do because there could be hundreds of these. So instead of doing that, we just come and change the font size of the root HTML element. Currently, it's sitting at 62.5%, which is 10 pixels. So let's now reduce this. I'll grab the HTML element. We'll change its font size to 50 pixels. That is the default font size of 16 pixels times by 50%, which equals 8 pixels. So by writing just this one line of code, anything that uses a rem value, like the font size here, the margin bottom here, is now being reduced. So it's no longer based on 10 pixels, but based on 8 pixels. So for example, the review heading, which has a font size of 4 rems, outside the media query would be 4 times 10 pixels, so 40 pixels. But now, inside the media query, the rem unit is 8 pixels. So this would be 4 times 8, which is 32 pixels. So every single one of these units has now scaled down. Let's refresh and check this out. I'll reduce the width of the browser to a value less than 1000 pixels. And you can see how everything nicely scales. And this has been achieved by one single line of code. Let's go do the same thing in this media query. I'm going to remove all these styles. We'll grab the HTML root element, and let's set its font size to 37.5%. That is 16 pixels times by 37.5%, which is 6 pixels. So now all the properties using rems are now based on 6 pixels. So this font size was initially 40 pixels. When it's less than 1000 pixels, from the media query here, when it's less than 1000 pixels, it reduced to 32 pixels, which is 4 times 8. And now when our browser is less than 500 pixels, our rem value is 6 pixels, which means that the review heading font size will now be 4 times 6, which is 24 pixels. So let's refresh, and I'm going to reduce the browser below 500 pixels. And you'll see once again how all our elements scale based on a single line of code here. Now let's go see these properties changing inside DevTools. We'll look at the feature heading to start. You can see on the Computed tab, you can see its font size is 40 pixels, where 1 rem is 10 pixels, so 4 times 10 is 40 pixels. When I reduce the browser below 1000 pixels, you'll see its font size is now 32 pixels. And that's because at this width, 1 rem is equal to 8 pixels, where 4 times 8 is 32. Let's scroll now below 500 pixels, and you'll see now the font size is 24 pixels. That's this media query coming into action, where 1 rem is 6 pixels. So 4 times 6 is 24. And this exact same thing is happening for anywhere we're using rems. As another example, let's look at the padding on our card. You can see the padding is currently 20 pixels. Let's go below 1000 pixels. You'll see the padding is now 16 pixels. And if I reduce it below 500 pixels, the padding is 12 pixels. So that's how rems works So by reducing the font size on the HTML root element, all properties using rems will effectively shrink as we reduce the width of the browser. So that's all about existing properties. So let's now talk about using new properties inside a media query. So we'll now be taking a look at new properties inside media queries. New properties added with rem will be based on the new pixel value, not 10 pixels. So let's see what I mean by this. I'm going to update our media query to now style an anchor tag. You can see it has a padding of 2 rems, top and bottom, and 4 rems left and right. This styling of our anchor tag was not present in our CSS file. It's being added for the first time inside the media query. So now stop and think about this. The value 2 rem is not 2 times 10 pixels, because in our media query, 1 rem is 8 pixels, which means that the top and bottom padding is 16 pixels. That is 2 times 8 pixels. And the padding left and right is 4 times 8 pixels. That is 32 pixels. So this is just a bit painful. It means that for every media query, when you want to come and add a new property, technically the rem value will be different depending on what media query you're in. And you can imagine that having to do the mental math where your rem value is changing inside each media query is just a bit painful. Because A, you need to remember which media query you're in and what the rem value is there. And B, you're no longer working with a nice rem value of 10 pixels. Now the good news is you don't actually need to worry about this. And that's because when adding new rem values inside a media query, select values you would use for the base case and it will scale automatically. Looking at our CSS and media query so far, for the 2 rem and 4 rem value that we're adding on the anchor tag, you just need to think as if 1 rem is 10 pixels. And that's because inside the media query, the padding on the anchor tag will automatically scale down. So when adding new properties in your media query, don't worry about exact pixel values for each media query. Focus on what you would do on the base case. And when I say base case, I mean the 10 pixels base case. Because whatever you would do for the base case, when 1 rem is 10 pixels, this will automatically adjust and scale down inside the media query. So definitely don't sit there and whip out a calculator and think about the new rem value for each media query. Just continue to use 1 rem as 10 pixels in your head and pretend like you're designing it for the base case. And then inside your media query, it will automatically scale down. Let's go play around with this inside VS Code. Okay, so I'm back inside our project. Now adjusting the root HTML element font size like this is a fantastic way to instantly scale all properties using rems. The only problem with it is that sometimes you want to do a bit more fine tuning. So for example, at this screen width of less than 1000 pixels, I think that this card could do with some more padding. At the moment, the padding is 2 rems. So inside this media query, the padding would be 2 rems times by 8 pixels, which is 1 rem inside this media query, which is 16 pixels. So what I'd like to do is actually increase this for this media query. So I'm going to grab the review card class, and I'm going to set the padding to 3 rem. Now I know I spoke earlier about this process for adding new properties that didn't exist in the CSS beforehand, and padding is an existing property, but the process of fine-tuning existing elements is the same thing, because we are effectively targeting an element and overriding what the HTML root element font size is applying to the padding. So just keep in mind this process is done for both applying new properties in the media query, but also for pinpointing existing properties and fine-tuning them. Now, with this padding value of 3 rem, I'm not thinking about this as 3 times 8 pixels, which would be 24 pixels. All I'm doing is keeping my mental model of 10 pixels, so this would be 30 pixels, and I know that because I'm inside this media query, where I've reduced the font size of the HTML element, it will scale down. So I'll refresh this, and for me, this padding just looks a bit better. And in all honesty, this is just a bit of an iterative process, and I really wouldn't overthink it. You just need to come and play with different rem values here until you're happy. I could have changed this to 4 rem, which would give it even more padding. But I do just want to stress that this rem value is now actually being calculated where 1 rem is now 8 pixels. And you can see that in the box model. If I select the card and scroll down to the box model, you can see its padding is 32 pixels, which is 4 times 8 pixels. Now, long story short, I really wouldn't overstress this, and I wouldn't be adding or refining elements and having to think about the new rem value inside each media query. Just continue to work on your 10 pixel base case, see how that looks, and then just come and change it up or down as you please. But this process is fairly common, where initially we change the font size of the root HTML element to dynamically adjust all our properties. We then look at our design and see anything that needs fine-tuning. And for me, it was the padding. And once again, just understand in the back of your mind that this rem value is now based on 8 pixels, but in reality, just continue to think of it as 10 pixels, and it will automatically adjust and just go through a bit of an iterative process inside the browser to land on a value that you're happy with. Alright, so we've looked at media queries, we've looked at relative units, percentages and rems, and now it's time to discuss the third pillar of responsive design, which are fluid layouts. Using Flexbox and CSS Grid allow layouts to dynamically adjust in size and position easily. Looking at the desktop view of this web page on the left, and the mobile view on the right, you can see the layout is initially a 2x4 grid, but then on mobile, it changes to a 4x2 grid. Now the good news is this is really easy to do inside our media queries. So I'm back inside our project, and what I'd like to do is that when we get to a browser width less than 500 pixels, I want our reviews to no longer be in a grid, but just stack one on top of each other. At the moment, our grid is being defined here, where we're currently defining 2 columns, each 1 fractional unit. So now all I need to do is select this class inside our smallest media query, and just update the grid template columns to 1FR. This is now defining a grid with 1 column. And watch what happens as I go below 500 pixels. Our grid items automatically shift into a 4x1 grid. And there you can see the power of fluid layouts like CSS Grid inside media queries. Alright, let's finish up this chapter by starting the next summary card, responsive design. In this chapter, we focused on media queries, which apply styles based on different screen sizes. The media query looks like this, where it starts with @media, and inside the brackets, we define a condition. I highlighted that the rem value used inside the media query condition is always based on the default browser font size of 16 pixels. So even if you adjust the HTML root font size in your CSS to say 62.5% or 10 pixels, this isn't the rem value used inside the condition. It's always based on the default browser font size of 16 pixels. We discussed how existing properties using rem values will adjust when changing the root HTML font size inside the media query. Over here, the properties adjust because by changing the root HTML font size to 50%, it now becomes 16 pixels, the default browser font size, times by 50%, which equals 8 pixels, which means that inside our media query, 1 rem is now 8 pixels. So any properties using rem values now reduce to 8 pixels, where outside the media query, they're likely based on 10 pixels. And we saw that by changing the root element font size with 1 line of code, we can dynamically adjust all properties using rems. We also discussed how new properties are based on the new pixel value. And this also applied to adjusting existing properties. So in this example, we're adjusting the padding of our anchor tag to be 2 rems top and bottom and 4 rems left and right. But the 2 rems is now based on 8 pixels. So 2 times 8 is 16 pixels. The 4 rems is 4 times 8, which would be 32 pixels. But we discussed that this would be very painful to do for every single element. So we just need to think as if it's 10 pixels and continue to design for our base case. And then we would just iterate this value inside the browser until we land on a value we'd be happy with. Now I know this was a lot to take in, especially around some of the nuanced things happening with rems. But as usual, I'm going into a lot of detail so that you fully understand what's happening behind the scenes. And you'll soon see when we come and implement media queries on our Quill project, actually not that complicated. Next up, we'll explore how to define specific screen widths where styles change dynamically using breakpoints. We'll be discussing what are breakpoints and how to go about selecting breakpoints. So before we go and add media queries to our Quill project, we need to discuss what are breakpoints. Breakpoints are a specific screen width where a web page layout changes. Looking at this web page on the left, the browser width is currently at 981 pixels. You can see this same web page on the right, where the layout and elements have completely changed. This is at a browser width of 980 pixels, 1 pixel less than 981. You can see things like the font size changing and the positioning of elements like this image over here. 980 pixels is referred to as the breakpoint. That is, the point at which the website breaks to a new layout. So let's now discuss how we go about selecting breakpoints. Selecting breakpoints for specific devices is impractical as there are too many to cater for. We have mobile devices, where we have a range of different sizes. We have tablets, again with a range of different sizes. We have laptops that also come in a range of different sizes. And finally, desktops, which also come in a range of different sizes. Now, we don't design for specific devices, and when I mean specific, I mean something like an iPhone X or a Samsung Galaxy, because if we took this approach, we'd have to design for hundreds of different screen widths. So if we don't design for specific devices, how do we go about doing this? Well, knowing the ranges of common device screen sizes is helpful in thinking about breakpoints. Now, I do just want to highlight straight away that there is no universal standard when it comes to these ranges. These ranges are just a good framework for helping you think about breakpoints. So let's take a look at them now. We'll start on the right with large devices and move to smaller devices on the left. The first pixel value I want to look at is 1536 pixels. Anything bigger than this would be considered part of the large screens category. For example, an iMac 27-inch has a screen width of 2560 pixels. The next pixel value I want to look at is 1280 pixels. Between these two values would be our category of large laptops. An example of a large laptop in this range is the MacBook Pro 14-inch, which has a screen width of 1512 pixels. The next pixel value I'd like to look at is 1024 pixels, and this range is where our small laptops live. An example of a small laptop is a Dell XPS 13, which has a screen width of 1200 pixels. The next pixel value we're going to look at is 768 pixels, and this range contains our tablets. An example tablet is the 11-inch iPad Pro in portrait view. This has a screen width of 834 pixels. The last value we're going to look at is 576 pixels. Inside this range, we have phones in landscape. An example device is the iPhone 8 in landscape, which has a width of 667 pixels. This means the last range, which is anything less than 576 pixels, contains our phones in portrait. An example device in this category is the iPhone X in portrait, which has a screen width of 375 pixels. Where when we select breakpoints, it's a good idea to try select a breakpoint within these ranges, as it provides a helpful framework to ensure our web page does cater for these different screen types. Now, I said earlier that there is no universal standard. This is a framework I personally like to work with, but there may be others out there. Just to show you what I mean about there being no universal standard for these ranges, there are some devices that break these rules. For example, at 1366 pixels, we have the 12.9-inch iPad Pro. This is a large and high-resolution iPad that falls in the large laptops category. At the end of the day, it doesn't really matter, because the design we implement for the large laptop will be perfectly fine on this large iPad. So this framework is still very useful. Now, it's also common to give these ranges a more suitable name. So starting at phone portrait, we would call this XS for extra small. For phone landscape, we would call this SM for small. For tablets, we would call this MD for medium. Small laptops, LG for large. Large laptops would be XL for extra large. And large screens would be 2XL for 2 times extra large. Now, ultimately, selecting breakpoints should be design-led and determined by observing where the layout naturally breaks. So within these ranges, you just need to play around with your design to land on your actual breakpoints. So for example, a particular web page may have breakpoints that look like this. So it's not common to have your breakpoints at the line between different devices we saw in our framework, but rather you'll just play around with your design and pick a breakpoint that seems right to you, which will usually fall within the ranges. Let's take a look at an example of this. So I'm on this homepage. I'm going to open up DevTools, and I'm going to come click on the toggle device icon. This allows me to easily change the screen width of the web page and shows the width and height up here. So I'm currently at around 1800 pixels. The first range we looked at was anything above 1536 pixels. This was 2XL large screens. So let's go and approach that value, and you'll see there's no change. So the design we just saw above this value was for large screens. The next range for large laptops, which was XL, was 1280 pixels to 1536 pixels. So let's reduce the width and approach 1286 pixels. You can see at around 1300 pixels, the design breaks. Noticeably, the image reduces in size. So that breakpoint is in the range 1280 to 1536, which is the XL large laptops. The next range was 1024 pixels to 1280 pixels. This was the small laptop's LG for large range. So let's go and approach 1024 pixels. And you can see that around 1110 pixels, the design changes. Most notably, the navigation bar changes. The next range of values was 768 pixels to 1024 pixels, which is our tablet's medium range. So let's go and approach 768 pixels. And you can see at this point here, around 893 pixels, the design once again breaks. The next range was 576 pixels to 768 pixels, which was for phones and landscapes, which was our small range. So let's go and reduce the width of our browser. And you can see in this case, the breakpoint is actually at 768 pixels, which was the line between small and medium. Now the last range was anything below 576 pixels, which was for phones in portrait, and was XS, extra small. Now in this case, this web page actually doesn't have a breakpoint in that range. The change you just saw there was simply the heading going onto another line. And the same thing here, the paragraph just goes on to another line. Now this is totally okay. You don't have to have a breakpoint at every single range. It's totally dependent on what you think works for your design. What I do want to show you though, is that at some point, when we go to really small pixel values, the design just completely breaks. You can see it around 200 pixels, we have this white line appearing down the side here, and you can see this is actually being caused by these buttons overflowing. Now for such small pixel values, we're not really going to care about. The main thing I wanted to highlight was that this design does follow our framework in most cases, but in one or two places it doesn't, and that's totally okay. Selecting breakpoints is completely dependent on your design and what you think looks good. Just to show you another example of this, let's go check out the breakpoints on this page. I'll open up DevTools. I'm currently at 2000 pixels, which is very wide. Let's go reduce the width of the browser. Our first breakpoint is exactly at 1024 pixels. So effectively, this design has grouped small laptops, and large screens all together. That is, anything above 1024 pixels, which again is totally fine. Let's go find the next breakpoint. That's at 768 pixels. So this design seems to be following the exact breaks in the framework that I provided. Let's go find the next breakpoint. And you'll see that is in fact the last breakpoint. So this design only has 2 breakpoints. Now this does work, but my general advice would be to have more than 2 breakpoints. You probably want to have a minimum of around 3 or 4. Now the last thing I need to point out is that when using max width in media queries, there's no need to set a maximum range because styles will be applied automatically. Let's take a look at this in the diagram. Inside our media queries, these breakpoints would appear in our CSS like this, where you can see the largest max width value is 1600 pixels. Now anything larger than this is when our styles are not inside any media query and are applied automatically. So I just wanted to highlight, for whatever design you have for your largest screen type, those don't appear in a media query. The value of your first media query in your CSS is effectively the start of this larger screen type and also functions as the end of your large laptop. In this case, it's a max width of 1600 pixels. What this means is that the first screen type you'll be designing for is a large laptop, as the large screen is the default case you would have already designed for. So let's wrap up this chapter by adding to our summary card responsive design. In this chapter, we looked at breakpoints. A breakpoint is a specific screen width where a web page's layout changes. We saw these useful values, which provide us a range to keep in mind when selecting our breakpoints. Larger than 1536 pixels is for our large screens, which is 2XL. Between 1280 and 1536 is our large laptops, which is XL. Between 1024 and 1280 are our small laptops, which is large. Between 768 and 1024 are our tablets, which are medium. Between 576 and 768 are our phones in landscape, which are small. And anything less than 576 are phones in portrait and are extra small. Alright, so I'm back inside our Quill project, and let's start off by looking for our first breakpoint. I'm going to open up DevTools, and from the framework we looked at earlier, the first value we want to go to is 1536 pixels. So I'm going to head to that width, and anything above here is just our default case for large screens. Let's now start heading towards our next value, which was 1280 pixels. Now for me, I'm actually okay with this. I don't think the design is breaking at any point, and still looks good. So I'm actually going to skip that range. That is 1280 to 1536, which covers our large laptops. I'm now going to head to 1024 pixels, and I want to stop around here. The hero section looks good, but for me being pedantic, I don't love how this paragraph is now wrapping onto another line. If I expand it a bit more, you can see it's on 3 lines, and when I get to around 1138 pixels, the word clicks wraps onto another line. And for me, this just looks like a bit of a chunky paragraph. Now the horizontal space is also becoming limited. I also want to reduce the column gap between our group text and image inside our grid. And when I scroll down, for me, this gap between our CTA card and the footer is just too large. The large space looks good on large screens, but on smaller screens, it's kind of a bit pointless to keep scrolling down just to hit a footer. So the first breakpoint I'm going to choose will be around 1150 pixels. I want to pick that value to ensure I'm a bit above where this word clicks is wrapping onto another line, which is around 1140 pixels. So 1150 is a good breakpoint for me to work with. And this breakpoint covers me for small laptops, that is between 1024 pixels and 1280 pixels. So let's jump into VS Code and code this up. Alright, so I'm back inside our app.css file for our Quill project. Now in the demonstration I did earlier, we came and added our media queries at the bottom of the CSS file. Now instead of doing this, it's a much better idea to start a new CSS file which just contains our media queries. So I'm going to go to our file structure. I'm going to go right-click New File and create a new CSS file called queries.css. I'm going to head to index.html, and under our main app style sheet, I'm going to come add our media queries. I'll grab the link tag and look for queries.css. Now it's really important that this appears after app.css because we first want all our global styles, our components, and different section layouts to load in first. And then the queries come and handles any specific screen sizes once all these styles have loaded in. Doing this also makes coding our media queries much easier. What's really nice to do is have our app.css on the left and move our queries to the right. So on the left, we can toggle between our HTML and main CSS styles, where we pinpoint anything we want to change. And on the right, we just come and add our query. So the first thing I'm going to do is come add a comment. I'm going to have these comments serving as different headings for our different ranges. The first range we're designing for is large, which is for small laptops, which covers the range 1024 pixels to 1280 pixels. So let's come and add our media query. We grab the at rule, add max width, which I'm just going to leave blank for now, and add our curly brackets. So let's now work out the max width. We wanted our page to break at 1150 pixels. Now, as I've mentioned in an earlier chapter, the rem value in here is always based on the default browser font size, which is 16 pixels. So let's go and divide this by 16 pixels, and this gives us a value of 71.875. Now I generally like rounding up my values, so instead of using this rem value, I'm just going to round this to 72 rems. Just so I know our final breakpoint, 72 rem by 16 pixels equals 1152 pixels. So you can see it's just slightly above the breakpoint we're targeting. So I'm going to come here and add 72 rem. I'm just going to leave these comments here, so when we look back at our file, we know how we calculated our breakpoint. So the first thing we're going to do is grab the HTML root element. Looking in our main CSS file, the font size on the root HTML file is currently set to 62.5%. And as we know by now, when we change the root HTML font size, this changes the value of a rem. And we know that this is a nice, quick and easy way to scale all values using rems as the screen size reduces. The properties using rems are mostly font sizes, as well as different spacing properties, like padding and margin. So our base case is a font size of 62.5%. As a reminder, this is equivalent to 10 pixels. The 62.5% was calculated by dividing 10 pixels by the default browser font size of 16 pixels to give us 62.5%. In this media query, I want the default font size to reduce to 9 pixels. So 9 pixels divided by 16 pixels equals 56.25%. So let's come and update the font size of the root HTML element to 56.25%. So let's check out how this has changed our web page. So our breakpoint is at 1152 pixels. So let's head towards that value. You can see when I hit it, the font size and all spacing properties reduce. Let's check it out over here. You can see the font size has reduced. And just to see how the spacing changes, let's check out the margin between the features section and the CTA. You'll see this slightly shifts up as the margin has reduced. So that's a fairly common first step, to come and reduce the font size of the root HTML element, so all values that use rem scale down. We then look at our design and fine-tune any other areas we want to change. For me, this column gap is still too small. I want our image and group text to appear closer together. And also, this distance between our CTA section and footer is also too large. So back inside our CSS, the first thing I want to go change is that column gap. Let's go find it in our CSS on the left here. Inside our features section, you can see we're defining column gap here of 5 rems. So I'm going to simply copy this class, paste it, and I'm going to go override the column gap property with a new value. As we discussed earlier, the rem value inside this media query is now based on 9 pixels. But in my head, I just continue designing for our base case of 10 pixels. Let's start by making this 3 rem. So I'm thinking again of this as 30 pixels. And I can rest assured that my media query is just going to scale this down based on the new 9 pixel rem value. And honestly, this doesn't really matter because we're going to go look in the browser anyway to see what value we want to use. So let's check this out in the browser. I'll refresh. For me, this is looking better, but I'd still like to reduce this further. Jumping back in the CSS file, I'm going to update this to 2 rem. I'll refresh, and for me, this is now looking good. Our group text and images are a lot closer together for this smaller screen. The last thing I want to handle is this margin over here. Heading back to app.css, this is currently being handled in our CTA section with margin bottom of 30 rem. So I'm going to copy the CTA section class, and I'm going to change the value to margin bottom of 25 rem. Again, I'm just thinking of this as 10 pixels, so 250 pixels. And as I mentioned already, it doesn't really matter because we're just going to go check it out on our page anyway and see if we're happy with it. I'll refresh, and this is starting to look better. Our footer is moving closer to our CTA section, but I'd still like to reduce this. So I'm going to change this to 20 rem. I'll refresh, and for me, this is now looking good. There's still space between our footer and CTA section, but it's not like I have to scroll down just to be shown a footer. Now, this iterative process I just went through is very common. You start off with a particular value you think will work, and you just iterate with values until you find something you're happy with. Alright, so let's start looking for our next breakpoint. The next range of values was between 768 pixels and 1024 pixels. That is medium and tablets. So let's start heading towards 768. And you'll see here this paragraph text is left aligned and not centered. This is actually an issue in our base CSS file, but so far this is looking okay. Let's scroll down to our features section. We'll play in this range again. And for me, around here, you can see our heading is wrapping onto 3 lines. And again, this paragraph text is just looking a bit too chunky for me when it's wrapping onto multiple lines. You can see the word clicks is wrapping onto this line around 810 pixels. So I'm going to pick a breakpoint at around 815 pixels. At this breakpoint, I want our font size to scale down. And just so everything's consistent, we're also going to scale down the different spacing. So let's head back to our queries.css file. We'll grab app media, grab the max width property. I'll leave this value empty for now. And let's work it out. We want our breakpoint at around 815 pixels. We divide the root element's font size of 16 pixels to get 50.9375. Now again, I'm just going to round this up to 51 rem. Just so we know our final breakpoint, 51 rem times 16 pixels is equal to 816 pixels. So for max width, we're just going to pop in here 51 rem. In the previous media query, I changed our font size to 56.25%, which represents 9 pixels. And in this case, I'm going to change it to 8 pixels. 8 divided 16 is 50%. So I'm going to come and update our root element font size to 50 pixels. Let's check this out in the browser. So I'm going to come and approach 815 pixels, and you can see how our font size and spacing reduces. For me, the main thing is these headings look a lot nicer, not wrapping onto 3 lines. And all spacing has scaled down because our margin and padding is all in rems. So let's take a look at what we have so far. We have our large screens and large laptops grouped together. At 1152, we have our first breakpoint. And now at 816 pixels, we have our second breakpoint. Now at this breakpoint, I actually don't want to change anything else. I'm happy with how it looks. So all I've done for this breakpoint is change the root HTML font size. Now just before I forget, I'm going to come and copy this comment just to better organize this query's file. The range we just covered was MD for medium. This covers tablets and is the range 768 pixels to 1024 pixels. The breakpoint we selected was 816 pixels, which falls nicely between this range. Alright, before we move on to the next breakpoint, I do just want to fix up this issue with our text here. At the moment it's aligned left, which wasn't an issue for larger screens because we're using Flexbox to center this. However, when the width of the flex container is smaller than the width of the text, it's wrapping onto a second line, and we now actually want to center this text inside this flex item. Inside our main CSS file, in the hero section, we have this class hero paragraph. I'm just going to come here and add text align center. Let's check it out in the browser, and you can see now our text is nicely centered inside this flex item. Alright, so let's start looking for a breakpoint in the next range. The next range is 576 pixels to 768 pixels, which covers phones and landscape and is our small range. So let's start heading towards 576 pixels. I think this is all looking okay, but I'm going to scroll right to the bottom, and you can see that the CTA card is not looking great now. We have the word now wrapping onto a second line. This is all being caused by just too much padding on the CTA card. At this screen width, I also think the gap between our grid rows is too large. And because horizontal space is becoming very limited, we should reduce this column gap as well. I also think this distance between the features section and the CTA card is also becoming too large. And once again, our different features heading text is starting to wrap onto 3 lines, with this paragraph now wrapping onto 5 lines. So we should look at reducing all font size, as well as generally scaling down our margin and padding across the entire web page. So just to land on an exact breakpoint, you can see around 670 pixels. The word now is beginning to wrap. I'm going to use that as my reference for where I want the design to break. And I'm just going to pick a pixel value slightly above this of 680 pixels. So I'm going to grab this comment. I'll paste it here. The range we're designing for is now small, which is phone in landscape. The range is 576 pixels to 768 pixels. I'll grab our media query, add the max width property, leave it blank for now, and add our curly brackets. The breakpoint we selected was 680 pixels. To work out rems, we divide by the default browser font size of 16 pixels, which gives us 42.5 rem, which I'm going to round up to 43. Just so we know our final breakpoint, 43 rem times by 16 pixels is equal to 688 pixels. So let's pop in our breakpoint of 43 rem, and like usual, I'm going to grab the root HTML element, and I now want to work with a rem value of 7 pixels. 7 divided 16 is 0.4375, which is 43.75%. So let's come and change the 50% to that value there. I'll save, and let's check this out in the browser. So let's go towards our breakpoint of 688 pixels. So you can see this has had a big impact. Our heading and paragraph don't wrap as much. And most importantly, the CTA heading in the CTA card is looking better. However, I would still like to reduce this padding. For me at this screen width, it's just too excessive. So let's go find that class in our CSS. We have CTA card over here with this padding property. I'll copy CTA card. I'll grab the padding property, and I'm going to override these values to something like 8 rem and 16 rem. Let's check this out in the browser. All right, for me, this looks a bit better, where you can see when I get close to the edge of this range of 576 pixels, it's still not wrapping onto a second line. Now, as I mentioned, I also want to reduce the margin between our features section and CTA. In our CSS, that's currently being set over here with the features section class. I'll copy that. The rem value here is 30 rem. So I'll grab margin bottom, and I'm going to change to something like 20 rem. I'll save. I'll refresh, and you can see this distance now looks a lot better. Let's now go handle the grid. I want to reduce the row gap, and I want to continue to reduce this column gap. In the features section, we have row and column gap being set here. I'll copy this class. Let's do the row gap and change it to a much smaller value like 5 rem. For column gap, I want to reduce this very small to something like 0.5 rem. I'll save. I'll refresh, and you can see this content now is a lot more contained for this screen size. All right, just taking one more look at it. Yep, I think this looks a lot better. All right, we're on to our final breakpoint. We're now looking at the range less than 576 pixels, which is for phones in portrait and is extra small. So I'm going to start reducing the browser. Now, this orientation does start looking like a phone. And there's 2 things I want to point out about the hero section. The first is this word "the" is just looking a bit odd on its own line. The reason that is happening is because we added a break tag after our for. So for small phones, I want to effectively remove that break tag. The other thing I'd like to do is no longer have our hero section above the fold. I would like to push it up and have some of this content below, now above the fold for a mobile in portrait. The other major thing we need to start looking at is that this grid layout is just no longer working. The screen width is too small to have this display nicely. We effectively want to remove this 2-column grid layout and just have our different grid items stack on top of each other. And once again, this padding is just getting a bit too much. And I'd also like to generally scale down our font size and general spacing of margin and padding on our web page. So let's go find a breakpoint. I'm going to be guided again about the CTA section. You can see around 520 pixels, the padding is too large and forcing the get started now to wrap onto a second line. So I'm going to pick a breakpoint of around 530 pixels, which is less than the 768 pixel range we're designing for. So let's head back into our query's CSS file. The first thing I'm going to do is copy this comment. We're now designing for extra small screens, which is a phone in portrait, and the range is less than 576 pixels. I'll grab our media query, add the max width property, just leave this blank for now. To work out the rem value, the breakpoint we decided was 530 pixels. We'll divide this by 16 pixels, which gives us a value of 33.125, which I'm just going to round up to 34. Just so we know our final breakpoint in pixels, 34 rem multiplied by 16 pixels is 544 pixels. So let's pop our 34 rem value into our media query. All right, I'm just going to copy this HTML rule. I'll paste it in here. I'm now going to reduce the font size to 6 pixels. So 6 divided 16 is 0.375, which is 37.5%. So I'm going to update our root HTML font size to 37.5%. Now, just a general rule of thumb, if my font size is now 6 pixels, if I go look at some of our text properties, our paragraph text is now 12 pixels. That is 2 by 6 pixels, because 1 rem is now equal to 6 pixels. Now, we probably don't want to be going much below this, having a paragraph font size of 12 pixels. So this is just a good little check you can do when your root element font size starts reducing to much lower values like 6 pixels. So I'll save this, and let's check out this change in the browser. Okay, so our font size has reduced, and spacing across the web page has reduced. All right, let's work top to bottom and start fixing some of these issues. The first thing I want to do is effectively remove this break tag sitting in our HTML, forcing the word the onto its own line. Let's check that out in the markup. You can see in our hero section main heading, we have this break tag over here. Now at the moment, that doesn't have a class. So let me just go add one. I'll give it the name hero heading break. I'll copy that. Let's select it. And we're actually going to be using the display property and set its value to none. We've looked at the display property in great length already, where we've seen the values like block, inline block, display, and flex. None is actually another value. And what this does is effectively hides this element from the web page. The element is still there in the underlying HTML. It's just when the browser renders, this rule says to the browser, just don't display it. So let's check it out. I'll refresh, and you can see on our web page, the break disappears. Just to show you, it is still in our HTML. If I go to this H1 here, you can see the break tag is still there, but the display none property is just hiding it from the browser. All right, the next thing I want to handle is effectively removing the view height unit we're using on our hero section so that other content, like the feature section, now appears above the fold. In our app.css file, if I scroll down to our sections, you can see the hero section currently has this calculation being performed where we set it as 100 view height units, and we're just subtracting off the height of the navigation bar. I'm going to come and select this class, and I'm going to change the height to auto. And what this now does is calculates the height of the hero section to be based on its content. So we're effectively overriding this height value here based on view height units. And we just say, make the height of the hero section just the content inside of it. Let's check this out in the browser. So you'll see now the view height units has been removed and our feature section now appears above the fold. Now, of course, you didn't have to do this. I did just want to show you how you could achieve this. Okay, let's scroll down our page. The next thing we need to take care of is this grid layout, where we want our group text and our images to now stack on top of each other and no longer be in a 2-column layout. I'm going to go to our features section. At the moment, the column layout is being defined by this grid template columns. I'm going to copy this class. I'm going to grab the grid template columns property. And I'm now going to change it to a single column by just having one fractional unit. Let's see the effect of this in the browser. I'll refresh, and you can see this now looks a lot nicer. We have our group text and our image. But you can see we have a small problem. Over here we have our group text and image, but then over here we have our image and group text, and then we're back to our group text and image. The reason this is happening is because of this rule over here, where on larger screen size, for the second row, we were swapping the order of the image so it appeared on the left. But this is now messing with this view here. So we effectively want to cancel these out. To do that, I'm going to grab this class, I'm going to grab the grid row property, and I'm going to set its value to auto. This essentially just resets the grid row property to its default value. And then I'm going to do the same for grid column. So all we've done here is effectively reset it to the default placing that it would appear in the HTML. And if I check out our HTML, this is ordered correctly. We have group text followed by image, group text followed by image, and group text followed by image. And this is exactly how we want it to appear on our web page on a smaller screen. So let's check it out in the browser. I'll refresh, and you can see this is looking great. We have group text followed by image for each feature. Okay, the last thing I want to take care of is just the padding on our CTA. I actually want to start reducing the horizontal padding a lot more than the vertical padding. In our queries file, I'm just going to grab the CTA card we did previously. I'll paste it down here. I'm actually going to leave the top and bottom padding value at 8 rems, but I want to significantly change the horizontal padding left and right to 6 rems. Let's check out the effect of this in the browser. I'll refresh, and you can see this now looks a lot nicer. There's a lot more horizontal space for the content in our CTA card. Alright, so that wraps up media queries on our Quill application. Let's go check out our amazing work for each section as we reduce the width of the browser. Okay, that looks fantastic. Let's go check out the features section. Alright, this is looking really nice, with the different font sizes and spacing, changes for different widths, and eventually breaks into a single column layout. For our CTA card, you can see this always maintains a good font size and padding value. The last thing I want to mention is that if I make this width really small, you can see the design does start to break a little bit. But the truth is, we just don't really care about values this small. Just to give you some kind of benchmark, the first version of the iPhone had a screen width of 320 pixels. Now, there's not many of those floating around anymore, but if you want to be really safe, 320 pixels is a very conservative value you can choose where your web page should still look good. And for me, this looks totally fine. But in all honesty, most small devices will be much larger than this. We'll finish off this topic by understanding how CSS units relate to real-world screen resolutions by understanding CSS and physical pixels. We'll be discussing what is a pixel, physical pixels, CSS pixels, and pixels in DevTools versus devices. So, what is a pixel? A pixel is a single point of light on a digital display. We have a digital display like a desktop, and this display is made up of thousands of pixels, which emit red, green, and blue light at different intensities to create different colors. Now, so far in this course, we've actually been assuming the size of a pixel is the same across all devices. Earlier on, I mentioned that the size of a pixel is 1/96 of an inch, which is 0.0104 inches. But in real life, on an actual screen, that is not the case, which is why we need to distinguish between physical and CSS pixels. Let's start with physical pixels. A physical pixel does not have a fixed length and varies between screens. Looking, for example, at a MacBook Pro 16-inch, this contains 3,456 pixels wide and contains 2,234 pixels high. A MacBook Pro 16-inch has a screen size of 16.2 inches. We can use these numbers to work out the size of a pixel, where one pixel will equal 0.0038 of an inch. This also gives us a metric called the PPI, which stands for pixels per inch. In the case of a MacBook Pro, it has a 254 PPI screen. The higher the PPI value means the more pixels you have in an inch, which means the sharper the screen will be. Let's compare this to a Dell Inspiration 15.6 inch. The screen size of this device is 15.5 inches. Now, this is a fairly similar physical size to our MacBook Pro, but the major difference here is that there are a lot less pixels. In width, there are only 1,920 pixels, and this is roughly half the number of pixels. For the height, there's 1,200 pixels, which is also close to half the number of pixels in height on the MacBook Pro. So, although the physical size of the screen is fairly similar, there are a lot less pixels in width and height. This means a pixel is going to be close to double the size of that on a MacBook Pro. On this device, 1 pixel equals 0.0071 inch, which is close to double the size of a pixel on a MacBook Pro. The pixels per inch value on a Dell Inspiration is 141 ppi. This is a lower number, meaning the screen won't be as sharp as the MacBook Pro. Now, what this means is that if we were to use physical pixel values in our CSS, we would run into some problems. For example, if I set a font size of 10 pixels, on our MacBook Pro, the text "Welcome Aboard" would be 10 pixels, which is 0.038 of an inch. That is 1 pixel, which was 0.0038 times by 10. On our Dell Inspiration, the "Welcome Aboard" text would appear a lot larger, where 10 pixels would be 0.071 of an inch. So, using physical pixels would result in inconsistent sizing of our elements on the page. So, to handle this problem, we have CSS pixels. A CSS pixel has a length of 1 divided by 96 of an inch. That is 0.0104 of an inch. So a CSS pixel does have a fixed width. So applying font size of 10 pixels means that our text will be the same. That is 0.014 inch on our MacBook Pro, which is the fixed CSS pixel length of 0.014 times by 10. And on the Dell Inspiration, the font size will be the same 0.014 inch. That is the fixed pixel length times by 10. Now the difference is that the number of physical pixels actually used between the devices will be different. So on our MacBook Pro, 27 physical pixels have been used on the "Welcome Aboard" text, whereas on our Dell Inspiration, only 14 physical pixels have been used to make this text. So to achieve this, browsers will scale the CSS pixels that we set to use the correct number of physical pixels on different screen sizes so that our elements are styled consistently. So once again, in our CSS, we're using a fixed length of 1 divided 96 of an inch for our pixel. And then when our web page renders in the browser will work out the resolution of the screen size it's on, and then determine how many physical pixels need to be used in order to achieve the 10 pixel font size we set in our CSS. Now let me show you why I'm bringing this all up. I'm on this web page, and if I open up DevTools, we've so far been playing with different screen widths when using CSS media queries. Now we're currently in this responsive view, which allows us just to toggle the width and height as we please. But there are also these specific devices we can select. For example, a Google Pixel 7. This now models what our page would look like specifically on a Pixel 7. Now what I want you to see is that the dimensions we're showing are 412 pixels by 915 pixels. But when you go and check out the actual size of a pixel, you can see its resolution is 1080 pixels by 2400 pixels. That's very different to what's appearing here. So let's now talk about pixels in DevTools versus devices. Pixel values in DevTools are not the same as device pixel values. Inside DevTools, we're using CSS pixels. That is the fixed pixel of 1 divided 96 of an inch that we're also using in our text editor. So looking at our Google Pixel 7, the CSS pixel is always 1 divided 96 or 0.014 of an inch. Based on this fixed pixel length, the physical width of the phone would then be 412 pixels, and the height would be 915 pixels. In the background, the browser knows the actual physical dimensions of the phone, so you can work backwards for the browser to know how many CSS pixels this would be in width and height. Looking now at the actual device, this uses physical pixels. So for a Google Pixel 7, the physical pixel is 0.0024 of an inch, which means that there's 1080 pixels in width and 2400 pixels in height. Now, CSS pixels are scaled depending on the screen resolutions. Our Google Pixel 7 has 416 pixels per inch. So from DevTools to the physical device, in order for the browser to know how many physical pixels to allocate inside the device screen based on the CSS pixels that's defined in our code, the pixel is scaled by the device pixel ratio, the DPR. In this case, it would be multiplied by about 3. So what this means is if we have a font size set as 10 pixels in our CSS code, In DevTools, that would have a fixed width of 10 times 1 divided 96 of an inch. And then in the device, to get that exact font size, the browser works out we need to multiply the number of physical pixels in the device in order to achieve that CSS font size. Now, scaling across different devices happens automatically. Inside DevTools, we have the setup we just looked at before using the CSS Pixel. The Google Pixel 7 has a 416 ppi, which means that the length of a physical pixel is 0.0024. The browser knows to use 3 times as many physical pixels to achieve our desired sizing in our CSS. Now, popping back into DevTools, I'm going to come and select a Samsung Galaxy S20 Ultra, and I want you to keep your eye on the dimensions 412 and 915. You'll see they remain unchanged. And if we then take a look at the physical dimensions of the Samsung Galaxy S20 Ultra, you'll see it has a height of 3,200 physical pixels and a width of 1,440 physical pixels, which is much larger than the Google Pixel 7, which has a height of 2,400 physical pixels and a width of 1,080 physical pixels. So let's check out what's going on here. So looking at the Galaxy S20 Ultra, it actually has a 511 ppi. It's 1,440 pixels wide and 3,200 pixels high. On the Galaxy, the physical pixel is a lot smaller than the Google Pixel 7 at 0.00196 of an inch. And again, the browser will automatically scale this, where one CSS pixel will use about 3.5 physical pixels. Now, the reason why in DevTools both the CSS pixels of the two devices was the same is because it just so happens to work out that if you divide each physical pixel dimension by the DPR, you get the same CSS pixel. So for example, if I divide the height of the Galaxy by its DPR, it would be 3,200 pixels divided by 3.5, which would be around 915 CSS pixels. For the Google Pixel 7, if I divide its height of 2,400 and physical pixels divided by its DPR, which is actually 2.625, I just rounded it up, you get the same CSS pixel value of 915 pixels. So for these two devices, it just so happens that their CSS pixel values are the same, even though they have different physical pixel sizes and screen resolutions. So let's finish off the summary card responsive design. In this chapter, we looked at CSS and physical pixels. CSS pixels are a fixed size, whereas physical pixels in devices do not have a fixed size. We saw inside DevTools, we're using CSS pixels, which has a fixed length of 1 divided 96 or 0.014 of an inch. Inside an actual device, we're using physical pixels, where the pixel depends on screen size and resolution. And we saw that pixels are always scaled by the DPR, the device pixel ratio, to ensure sizing between different devices will be consistent. So long story short, when we're inside VS Code and DevTools, we're working with a fixed pixel of 0.014 of an inch, and then when it comes to the page being rendered in a browser, the browser will automatically calculate the number of physical pixels that are needed to match the CSS pixel of 0.014 inch inside DevTools and our text editor. And this is all done because the number of physical pixels across devices varies, and using a CSS pixel multiplied by the device pixel ratio ensures that the sizing of our web page is consistent across all devices. Now, I wouldn't stress too much about this chapter, as everything is calculated automatically between CSS and physical pixels. But like usual, I like going into the details so you have a solid understanding of what is going on behind the scenes. Great work, we've now finished responsive design. Now that you understand media queries, you're well equipped to build responsive websites that work across all different screen sizes. It's now time to move on to positioning. Positioning is a technique that gives you full control over the exact placement of elements on your page, helping you create detailed and precise user interfaces. As part of this topic, we'll also dive into stacking order and transformations to add depth and interactivity to your layouts. Let's begin by exploring how to precisely place elements on a web page using different layout techniques with positioning. We'll be discussing static positioning, relative positioning, absolute positioning, fixed positioning, and sticky positioning. So before we talk about positioning, I want to quickly talk about normal flow in a bit more detail. Elements occupy their own designated slot on the page, which allows them to be surrounded by other elements. So let's take a look at what I mean by this in diagram form. We have a container. Now we're going to look at block and inline elements, and I want to start thinking of these as being made up of kind of two parts. The first part of the block element is the slot. It's the area designated on the page for the element. We then have the element itself. So these would be block elements, where we have the slot on the page as well as the element itself. And the same thing for inline elements. We have the slot, that is the area on the page allocated for this element, and then the element in this allocated space itself. And these would be our inline elements. Now I know up until now, we haven't really thought about slots on the page, but rather just the elements being there. But for us to think about positioning, we now need to think of elements as being made up of two components. A slot, which is the area designated for the element, and then the element itself. So let's now talk about the position property. The position property determines how an element is positioned on the page. In CSS, it looks like this. Position is the property, and relative is an example of one of the values. The values we can have include static, relative, absolute, fixed, and sticky, where static is the default value. So let's first look at static positioning. Static positioning is when the element follows the normal document flow. In CSS, we have position static, where static is the default property. It's what we've seen so far, where elements just follow normal flow. In diagram form, we have 3 slots designated for our elements, and our elements just occupy these slots. These elements are block elements, so block elements will stack on top of each other like this. So let's check this out in VS Code. So I've gone ahead and created an index.html file and linked a style sheet which is currently empty. Inside the body, I want to go grab a div to act as a container. I'm going to give it the class container. And then in here, I'm going to add 3 divs. I'm going to number them 1, 2, and 3. And I'm going to add a class to each div. Box 1, box 2, and box 3. So we have a main container holding 3 divs. Let's head to app.css. The first thing I want to do is grab the Universal Selector and reset all margin and padding. I'm then going to grab the container. I'm going to give it a width of 800 pixels and a height of 800 pixels. Just so we can see it, I'm going to give it a background color of light gray. I'm also going to give the entire container a margin top of 100 pixels just to move it down slightly. And I'm going to give it a margin left of 100 pixels to move it right slightly. I'm also going to give it a font size of 40 pixels, which will be inherited by our different boxes. Let's go style the boxes now. I'll select box 1. I'm going to give it a height of 100 pixels, a width of 100 pixels, and just so we can see it, I'm going to give it a background color of light coral. I'm going to copy this rule, change it to box 2, change the height to 200 pixels, the width to 200 pixels, and change the color to light green. I'll copy this again, and for box 3, I'm going to give it a height of 300 pixels, a width of 300 pixels, and change the color to light sky blue. All right, let's check this out in the browser. Okay, nothing crazy going on. We have our main container in gray and our different boxes stacked on top of each other because they're block elements. Now let's go to block 2, add the position property, and give it the value static. If I refresh, nothing changes. Static is just the default value of all elements. And once again, what this means is that the element fills the slot it is allocated. Now I know this idea of slot may seem very new and not relevant at all, but let's now go and see this idea of slot and element by looking at relative positioning. In relative positioning, the element follows the normal document flow but can be offset relative to itself. In CSS, we would set position to the value relative. So looking at the green element, the element can move around relative to its original position. So what this means, we can separate out the element from its slot and move the element like this. So the slot remains, that is the area on the web page allocated for the element, but the actual element can move around the page. So let's get a better visual understanding of what's happening here. It's kind of like there's 2 layers going on here. All the other elements and slots are in one layer, where other elements remain in position as the slot of the relatively positioned element remains present. So in our first layer, because the slot is still there, the orange and purple elements stay in place, now with a gap between them created by the slot of the green element. And for the green element, this is now in its own layer and can move around. So how do we move this element around? We do this with offset properties. Offset properties are used to shift the element from its reference point. Now for this to work, the position property has a value other than static. So using offset properties wouldn't work for regular elements, because by default, regular elements have a position property of static. But the offset property does work when it has a non-static value, like relative and the other values we're going to be seeing soon. So for an element with the position relative, the reference point is the element itself. If you look at the green slot on the left, the reference point will be the top left of the image shown in red. And we can add in axes at this point. This is the reference point of the element. And it's easiest to think of this in the top left of the element. So let's go check out the offset properties. There's 4 of them. The first offset property is top, and in this example, it has a value of 20 pixels. Now for me, I find these values a little bit counterintuitive. So to help, I've come up with this sentence for how to think about them. So for the case of top, what this means is that you shift whatever the value is, in this case 20 pixels, away from the, and then the property top of the reference point. So let's read that out again. If you applied top 20 pixels to the element, what this would do is shift 20 pixels away from the top of the reference point. I just find it a bit confusing if I don't think of it in this sentence, because it's about moving the direction away from your reference point. We have left 10 pixels, and converting this to plain English, it would mean we're shifting 10 pixels away from the left of the reference point. We have bottom 40 pixels, which means we're shifting 40 pixels away from the bottom of the reference point. And we have right 30 pixels, which means we're shifting 30 pixels away from the right of the reference point. So let's go play around with these inside VS Code. All right, so picking up where we left off, I'm going to come to box 2 over here, and I want to change its position value to relative. I'll refresh and you'll see there is no change. But what's happening behind the scenes is that the element is now in its own layer, and the slot remains in place. Now that we've added position relative, we can go use our offset properties to move the element around in its own layer. Let's go add top of 30 pixels. And the way we need to read this again is we shift 30 pixels away from the top of the reference point. I'm going to think of our reference point as the top left here. So we're moving 30 pixels away from the top, which effectively means we're going to be moving down. If I refresh, you'll see our element moves 30 pixels down. Now this is why I find it a bit counterintuitive, because you may just look at this and think top means you move up. But in fact, you're moving the opposite direction. And that's because you're moving away from the reference point, where once again, the reference point is the slot of the element. Let's go add the left offset and set a value of 40 pixels. The way we read this is that we're shifting 40 pixels away from the left of the reference point. That is, we're going to be moving right. So I'll refresh, and you can see now we've moved 30 pixels away from the top of the reference point and 40 pixels away left from the reference point. Now I'm going to change the position property back to static, which is just the default value, and you'll see the offset properties do not work. And that's because the offset properties only work when the position value is anything other but static. Now, I really want to highlight for relative positioning, the slot still remains in place, and the offset properties move the element relative to its original positioning. That is where the slot is. So let's now take a look at absolute positioning. In absolute positioning, the element is removed from the normal document flow. In CSS, we are positioning with the value absolute. Let's take a look at this in diagram form. We're going to be focusing on the green element, and when we set position absolute, the actual slot of this element is entirely removed from our web page. So what this means is that any elements below it can now occupy that space. It's very different to relative positioning, where there, the slot of the element did remain in place. Whereas for absolute positioning, elements below move in as the slot is no longer present. So just like relative positioning, our green element is in its own layer now. Where in our first layer, the green box does not exist for these elements as the slot has been removed. The green box is in its own layer and can move around, using the same offset properties. So let's jump into VS Code and play around with this. I'm just going to remove the offset properties on box 2, and I'll refresh to get the element back in its original position. Now this is still positioned relatively, where we discussed for relative position elements, the slot remains in place. Let's go change this now to absolute. I'll refresh, and you'll see the slot of box 2 has been completely removed. And what that means is that the element below box 3 can now occupy that space, where box 2 is now in its own layer. Alright, I now want to spend a bit more time talking about the reference point for absolute positioned elements. When positioning an absolute positioned element, the reference point is the root HTML element. So on our page, we have our root HTML element, we have our div parent container, we have our two boxes in layer 1, and we have our green box in layer 2 absolutely positioned. Now the reference point when using offset properties is the entire root HTML element. The reference point are the edges of the root HTML element. We can't think of it as a single point with an X and Y axis like we did with the offset properties for relatively positioned elements. So for example, if we applied a left offset of 100 pixels, this would move our green element 100 pixels away from the left edge of the HTML root element. So it would end up over here. If we applied top of 50 pixels, this would move our element 50 pixels away from the top edge of the root HTML element. In this case, effectively moving it up. So for absolutely positioned elements, we're looking at the edges of the root HTML element, whereas for relatively positioned elements, this was the top left corner of the element itself. Let's play around with this inside VS Code. Alright, so picking up where we left off, let's go add the offset property top and give it a value of 400 pixels. What this is going to do is move our green element 400 pixels away from the top of the HTML element. I'll refresh, and the distance from here to here is 400 pixels. Let's go move it left 300 pixels. This is going to move the green element 300 pixels away from the left edge over here. I'll refresh, and the distance from here to here is 300 pixels. Let's go change top to bottom. This will move our green element 400 pixels away from the bottom edge of the root HTML element. I'll refresh, and the distance from here to here is 400 pixels. Let's go change this to right, and this will move the element 300 pixels from the right edge of the HTML element. I'll refresh, and the distance from here to here is 300 pixels. I also just want to show you can use percentage values here. So for example, if I change this to 50%, what this is saying is move the green element 50% the width of the root HTML element from the right. I'll refresh, and the distance from this edge here to the edge of the root HTML element on the right is 50% the total width of the root HTML element. Alright, I'm just going to change this back to pixels, but I do just want you to be aware you can also use percentages. Now, where absolute positioning gets a bit confusing is that the reference point can actually change. More commonly, the reference point is set by the nearest ancestor with a non-static position. Alright, that's a bit of a mouthful. Let's break this down. What we can do, for example, is on our div parent container, change its position to relative. By having a non-static position property, like relative, on our div container, we'll now make this the reference point. The div is closer in the HTML document structure to the green element compared to the HTML element. So the closest non-static ancestor, in this case the div, will act as the reference point. So if we applied the offset properties now, let's say left 100 pixels, this will move our green element 100 pixels from the left edge of the div, and top 50 pixels will move our element 50 pixels from the top edge of the div. So the reference point has completely changed. Let's go play around with this inside VS Code. Alright, so by default, like we saw earlier, the reference point is the root HTML element. But let's go and add position relative onto our div container. I'll refresh, and you'll see that the element shifted positions. And that's because the reference point is now the div container. Just to walk you through this, I'm going to remove these properties here. I'll refresh, and our absolutely positioned green element moves back into its original position. Let's go add left of 200 pixels. This will now move our green element 200 pixels away from the left edge of our gray container. I'll refresh, and the distance from here to here is 200 pixels. Let's go add a top of 10 pixels. What this will do is move our green element 10 pixels away from the top edge of our gray container. I'll refresh, and the distance from here to here is 10 pixels. We can even change these values to 0. So for example, setting 0 here will have no distance from the left edge, and setting 0 here will have no distance from the top. So it's moved to the top left corner. We can do the same thing by moving it to the bottom right. We can change right to 0 and bottom to 0. And this will move the element to the bottom right of the gray container. So this may seem a bit confusing, but it is fairly common to do this. where all we're doing is setting a position relative on a much closer parent, which kind of acts as an anchor point to reference the element we want to absolutely position. We're not using position relative on our container to move the container around, we're just adding position relative here in order to use the gray container as our reference point for box 2. Just see this declaration as kind of anchoring the container to be our reference point. Alright, let's now talk about fixed and sticky positioning. Fixed and sticky positioning are kind of like special cases of absolute positioning. Just as a recap, for absolute positioning, the element is removed from the normal document flow, where we saw any elements below it could now occupy the space of where the original element was. This was different to relative positioning, where the slot of the element remained in place. So let's first look at fixed positioning. This is absolute positioning, but the element remains fixed relative to the viewport and is unaffected by scrolling. So in a nutshell, it's absolute positioning, but it's fixed to the viewport. Let's jump into VS Code and check this out. So we have our position absolutely positioned, where our reference point is the gray container, because it is the closest ancestor with a non-static position property, which kind of acts like an anchor. Now what I'm going to go do is change the height of the container to a much larger value, like 1500 pixels. I'll refresh, and as you may expect, our element still remains 0 away from the bottom edge of the container and 0 away from the right of the container. Just to better see this on the container, I'm just going to go add some margin bottom of 100 pixels. Now I'm going to go change the position of absolute to fixed. I'll refresh, and you'll see straight away our element is positioned relative to the viewport. That is our browser. So it is absolutely positioned, that it still has been removed from normal flow. The reference point, however, changes to the viewport, that is the browser. And the other major difference is that this element now remains fixed when I scroll. So I'm going to scroll up the page and you can see it remains in the bottom right. So once again, a fixed positioned element is like absolute positioning in that the element is removed from normal flow. And that's why the 3 shifts up to occupy the original space where the 2 was. But the two subtleties of fixed versus absolute is that the reference point is the viewport now, and when I scroll, it still remains fixed in place. So let's now take a look at sticky positioning. In sticky positioning, the element is in normal flow until a certain scroll point when it then becomes fixed. So it's like fixed positioning, but it needs activation by hitting a certain scroll point, and actually remains in normal flow until we hit this point. Let's check this out in VS Code. Okay, so on box 2, I want to come remove the offset properties here and just set a top of 0. I'm going to leave position fixed for now. I'll refresh, and this now moves our element 0 pixels away from the top of the viewport. That is this top edge of the browser here. It's absolutely positioned, so its original slot has been removed, and fixed positioning means that when I scroll, it remains fixed in position relative to the viewport. Let's go now change this to sticky. I'll refresh, and you'll see the element actually goes back into its original position in normal flow. But when I now scroll, such that the element is 0 pixels away from the top of the viewport, that is the top edge of the browser here, it then changes to fixed, where when I scroll, it remains 0 pixels away from the top edge of the browser. So sticky is like fixed, however, it initially remains in normal flow until I hit an activation point by scrolling set by the offset property. So once again, it's in normal flow, I continue to scroll, when I'm 0 pixels away from the top edge of the viewport, it now becomes fixed. And of course you can change this value, let's make it 100 pixels, I'll refresh, and now when I'm 100 pixels away from the top edge, so about here, you'll see the element now becomes fixed. So let's now take a look at some positioning guidance. Absolute positioning is more commonly used than relative positioning because it removes elements from the document flow. This is preferred because the slot is removed, so there's no unexpected gaps in the layout. Looking at an example, we have this container over here, and we have these visual elements which would have the property position absolute and be positioned relative to the parent container. That is the blue div. For the next piece of guidance, absolute positioning should be used as a last resort for very specific cases, as it makes responsive design more challenging. So looking at this page over here, the star icon on the right of the image looks absolutely positioned. However, this is actually being achieved by Flexbox. Our image is a flex item, and the star is a flex item, and Flexbox properties would allow us to achieve this result. And using Flexbox is much more responsive friendly. So we rarely try avoid using absolute positioning unless we have to. More commonly used is fixed and sticky positioning. Fixed positioning is used for elements that need to be absolutely positioned, but also need to remain visible when the user scrolls. An example of an element we would want to remain visible when the user scrolls is something like this chat window over here. I'm sure you've had this experience where on a page, as you scroll down, the little chat box icon follows you down the page. Now in reality, you wouldn't actually be making this yourself, but you would be embedding code from a third-party chat provider like Intercom, and the code you embed would automatically have the fixed position property, so it goes to the bottom right and remains fixed. Sticky positioning is ideal for navbars as they stay at the top in normal flow and then become fixed when the user scrolls. Looking at this page over here, our navbar is initially in normal document flow, that is, it occupies its slot, but the navbar then becomes fixed when the user scrolls down. So for a navbar, we do want it to initially remain in normal document flow. We want the navbar in its original slot, but sometimes we want our navbar to remain at the top of the page when we scroll. And this is a perfect use case of sticky positioning. And we even classify our navbar as a sticky navbar. So let's wrap up by building the next summary card, positioning. I'm going to be summarizing everything we learned in this simple table, where I have the row headings, the value, a description of what's happening, what happens in document flow, how offset works, and a simple diagram. Let's look at static first. This is just the default positioning, where the element is in normal flow. For offset, it's ignored. You can't apply offset properties to a static positioned element. In diagram form, our block elements will just stack one on top of each other. The elements occupy their slots. For relative positioning, the element is positioned relative to its original position. The element remains in normal flow. That is, the slot of the element is still there. Offset properties can be applied. Looking at this in diagram form, if we set our green element to have a position relative, and applied the offset properties left 100 pixels, the element will move 100 pixels away from the left of the reference point. That is 100 pixels to the right. If we then set top as 50 pixels, the element will shift 50 pixels away from the reference point. That is 50 pixels down from the element's top left corner. So our relatively positioned element ends up looking like this, where its original slot remains in normal flow, and it's positioned relative to itself. That is, its original position. For absolute positioning, it's relative to the nearest non-static element, and if there are none, it's the root HTML element. However, we saw it's more common to anchor a parent element with the position relative property, so that we can position our absolutely positioned element in relation to that parent element. When absolutely positioned, the element is removed from normal flow, and offset properties apply. In diagram form, our green element is absolutely positioned, so its slot is removed, and the reference point is the closest non-static parent, where instead of an actual point, we think of the parent's edges. So applying offset of left 100 pixels and top 200 pixels will move our element 100 pixels away from the left edge and 200 pixels away from the top edge. For fixed positioning, it's relative to the viewport. The element is removed from normal flow, just like an absolute positioned element, and offset properties apply. So in diagram form, we have our fixed positioned element, which is just like an absolutely positioned element, in that it's removed from normal flow, but the offset properties are now relative to the viewport, where right 50 pixels and bottom 50 pixels will move our element here. That is, 50 pixels away from the right edge of the viewport and 50 pixels from the bottom of the viewport. The other big difference for a fixed element compared to an absolutely positioned element is that when the user scrolls, the element will remain in place. The diagram on the right represents the user scrolling down the page, where the orange element is no longer in view of the page. Finally, for a sticky positioned element, it starts static but becomes fixed after scrolling to a certain point. In terms of document flow, it starts in normal flow but is removed at a certain scroll point. And for sticky positioning, the offset property is actually required, so the browser knows at which point to make it sticky. In diagram form, our green element is initially statically positioned in normal document flow. Our reference point, just like fixed positioning, is the viewport, we set an offset property like top of 0. And when the user scrolls, such that the element is now 0 pixels away from the top of the viewport, it then becomes fixed. So sticky positioning is fixed positioning, but the element initially is statically positioned until we hit a certain scroll point as set by the offset property. Okay, let's go see how we can use positioning in our quill application. Now, just as a heads up, I'm actually happy with where the homepage is currently at. For me, it's perfect. It's looking really, really nice. And in the previous chapter, we also implemented media queries to ensure that the page is fully responsive for different devices. So me personally, I'd stop here. I think the page is looking great and doesn't need anything further. However, in this chapter and the next chapter, I am going to come and add more, just so we can implement what we have learned on our project. So the first thing I'm going to do is come and add a little chat window in the bottom right here. And I want it to be fixed so that when I scroll, it always remains in the bottom right, in order to easily contact support. Now, as I mentioned previously, you wouldn't actually code this up yourself. You would just copy and paste some existing code from a third-party chat provider. But just to put positioning in action, let's go code this up. I'm going to head over to Ion Icons, and I'm going to search chat. I like this filled one here, so I'll click it and download it as an SVG. Okay, from my downloads folder, I'm just going to rename it to chat.svg. I'll copy it and paste it into the images folder in our Quill project. Okay, I'm back inside our Quill project. Let's just double check the image is there. In our file directory, I'll go to images and we can see chat.svg. All right, so the first thing I'm going to go do is add the chat SVG to our HTML. I actually want to do this completely outside our different sections, because this layer is kind of going to be floating above our different page sections. I'm going to come right to the bottom here, just before the closing body tag. I'm going to grab the image tag. The source is images/chat SVG. I'm going to give it some alt text of chat icon, and let's give it a class of chat-icon. I also want to wrap this image inside a div container, as I also want to be using Flexbox to nicely position this chat icon inside a background circle. I'm going to give this the class of chat container. All right, let's head over to app.css. I see this chat icon as a bit of a component, as it could appear in other pages. So I'm going to scroll down to our components, and I'm just going to put it as the last component. I'm going to grab chat container. I'm going to give this a height of 7 rem, a width of 7 rem. Let's give it a background color. We'll grab the primary tint color, that's that lighter version of the primary color, and give it a border radius of 50%, which will make this chat container a circle. Let's check this out so far in the browser. Okay, so you can see our chat container with the blue background, with the chat icon inside of it, is just appearing in the bottom left, below our footer. That's just because in our HTML, it comes after our footer, and it's also not within the main page container, so it appears in the bottom left. All right, so let's first of all go make this chat icon a bit smaller. I'm going to grab the chat icon. I'm going to set its width to 5 rem and its height to 5 rem. I'll refresh, and you can now see the chat icon is smaller than the background blue circle. I'd like to nicely center this chat icon. Because the image is a child of the chat container, we can use Flexbox to easily center it. On the chat container, I'm going to go display flex. Our main axis is running from left to right, so we'll use justify content with the value center to center it horizontally, and align items with the value center to center it vertically. So our chat icon is now nicely centered inside our blue circle container. I also just want to change the color of the chat icon to be our primary blue. An easy way to do this is to open up the SVG, and we can just add a fill attribute and set its value to our primary blue. I'm going to scroll up, where our primary blue base is this hex code over here. I'll copy it and paste it as our fill. I'll refresh, and you'll see our chat icon is now our primary blue. Heading back down, so let's now go fix the chat icon so that it appears close to the bottom right of the page. I'm going to add position with the property fixed. I'm going to give it a bottom value of 2 rem. This means that the chat container will be 2 rems from the bottom of the viewport, and we'll add right 2 rems, which means that the chat container will also be 2 rems from the right edge of the viewport. I'll refresh. You can see we now have our chat container nicely positioned in the bottom right. And when I scroll, it remains in place. So once again, I personally wouldn't go and add this to our project, but I just wanted to implement something using the position properties we've just learnt about. Next up, we'll learn how elements are layered on top of each other and how to control their depth using Z-index and stacking context. We'll first look at Z-index and then stacking context. So to understand the concept of Z-index, let's first recap normal flow. Most web layouts have elements in the same 2D plane and do not overlap. So we can think of our web page as having an x-axis and a y-axis. There's no z-axis, so this is just a 2D plane. And inside our plane, we have our elements. In this diagram, I'm going to have 3 divs. This orange div, this blue div, and this red div. The elements are in the same plane, and they're not overlapping. However, elements can overlap in the same plane, with the stacking order being determined by the order they appear in the HTML. Looking at our diagram, the blue div appears after the orange div in the HTML markup. So if this were to overlap the orange div, it would appear on top. The red div appears below the blue div in the HTML markup. And because of this, if it were to overlap the blue and orange div, it would appear above them both, because it appears last compared to these 2 elements. Let's go play around with this inside VS Code. So I'm back inside the file we looked at in the last chapter. At the moment, our box 2 is set as sticky. So when I scroll down, it remains fixed. I'm going to go remove the positioning properties here and just remove the position relative on the container. I'll refresh and we're just back to our box setup. Okay, I'm going to go to box 2 and I'm going to go add a margin bottom of -80 pixels. I'll refresh and watch what happens. This kind of does the opposite of making space between elements. It now essentially creates space for box 3 to move up by 80 pixels. And you can see that box 3 is now on top of box 2. If we look at the original markup, box 3 appears last, so therefore, when it overlaps box 2, it will appear above. I'm going to remove this and refresh. I'm now going to go add a margin top of -50 pixels. I'll refresh and watch what happens. Box 2 has effectively moved up by 50 pixels. And you'll note it's on top of box 1. And again, that's because box 2 appears after box 1 in the markup. Now, this is not common to do, adding negative pixel values, but this is a good way for me to demonstrate what happens when our elements are in the same plane and overlap. Now, I just want to highlight, I specifically haven't used positioning properties here to move our elements on top of each other, because it's kind of like those created other layers. What I wanted to demonstrate here was that by using negative values for margin, I'm able to move our elements on top of each other, but they're in the same plane. And when they're in the same plane, the stacking order just depends on the order they appear in the HTML. So let's now take a look at Z-index. The Z-index property controls the vertical stacking order of positioned elements. By positioned elements, I mean there that the element has a position property like relative or absolute. In CSS, the property looks like this: Z-index with a numerical value like 2. The number represents the stacking order. We can think of Z-index like stacking plates. We have our bottom plate representing an element which has a Z-index of 0. The plate above this would have a Z-index of 1, and the plate above this, or the element, would have a Z-index of 2. So when elements have a position property on them, you can add the Z-index value to control the stacking order. Looking at this in diagram form, we have our 2D plane, x and y, and this plane by default has a Z-index of 0. So an element on this plane would have a default Z-index value of 0. On the right, I'm going to demonstrate what this all looks like on a web page. Initially, we just have our red element. Let's now go add a Z-axis. That is a third axis, creating a 3D space. Let's now go look at when an element has a Z-index of 1. We have an entirely new plane, and the element here would have a Z-index of 1. On the right, looking at our web page, the blue element would appear above the red element, because it has a higher Z-index value. Let's now go look at another plane, where the Z-index is 2. We have a green plane over here, an element with a Z-index of 2, and on our web page on the right, this would appear above both the blue and red elements, as it has the highest Z-index value. And I want to highlight again that Z-index only works on positioned elements. Let's go play around with this inside VS Code. Alright, so this is where we left off earlier, and we saw that when elements overlap, like when using a negative margin value, causing box 2 to overlap box 1, the stacking order was just determined by how they appear in the HTML. Because box 2 appears after box 1, it appears on top. Now simply adding a position property onto an element actually doesn't change this, It's only when you explicitly add a Z index value. Let me show you what I mean. I'm going to get rid of this margin top, and I'll refresh. Let's go position this element with the value relative. We know that this means that the element is now going to be positioned relative to itself, where the reference point is the top left corner. I'm going to go add a top value of 50 pixels. I'll refresh, and this moves our element 50 pixels away from the top of the reference point, that is, down 50 pixels. You'll see that it appears to overlap box 3. Now from CSS's point of view, box 2 is not actually in its own layer. It's still all within the same plane. The reason it seems to appear on top of box 3 is because as soon as you add a position relative onto an element, the browser will always give priority to rendering that on top of non-positioned elements. If I go and change this to bottom 50 pixels, again, it will appear above element 1. Okay, I'm just going to change this back to top. And what I want to go do now is just add the position relative onto box 3. I'll refresh, and you'll see that because box 2 and box 3 are now both position elements, the reason box 3 appears on top of box 2 is just because in our underlying HTML, box 3 comes last. So I just wanted to show you, although it seems like adding a position value onto an element, that it appears on top of other elements, we are still in fact in the same plane. Okay, I'm just going to add position relative back onto box 3, and I want to show you now how Z-index works. At the moment, the default Z-index value of any positioned element, like box 2 and box 3, is 0. Just to show you this, I'm going to add a Z-index of 0, and over here a Z-index of 0. I'll refresh and there is no change. Both of these elements are in the 0 plane, which you can just think of as the XY plane. But now watch what happens when I change the Z-index of box 2. I'll change it to 1, and I'll refresh. What this is saying is that box 2 should now appear in its own layer in another plane. Think back to the diagram we looked at earlier. Box 2 is now essentially in the Z plane of 1. So it now actually is in its own layer. I can change the Z-index value here to 2, and that will now push box 3 into its own layer. So box 1 is in layer 0, box 2 is in layer 1, and box 3 is in layer 2. And whatever the highest Z-index value is will always be on top. For example, I could give this a Z-index of 99. And this is now in the Z99 layer, way above the box 3 in the second layer. We can also use negative values. So for example, if I gave this a Z-index of -1, you'll see this effectively disappears. And that's because it's gone behind our container, which is just in the default Z-index of 0 layer, that is the XY plane. Box 2 is now behind this layer. All right, I'm just going to bring it back to layer 1. So just to recap, when your element is positioned, like box 2 and box 3, we can explicitly define a Z-index value which moves that element into its own plane. And whichever element has the highest Z-index will always appear on top. Okay, so now let's discuss the concept of stacking context. A positioned element with Z-index creates a new stacking context, where its children are stacked independently of other elements. All right, that's a bit of a mouthful, so let's understand this in diagram form. I'm going to first split out our different planes. Focus now on the Z-index 1 plane. I'm going to expand this element vertically. This element will now act as a container, and I'm going to give it a child element in black. Now the Z-index of this child is only relevant within the parent. So for example, if I gave this child a much larger Z-index compared to what else is here, like a Z-index of 10, take a look on the right to see how this would appear on the web page. The black element doesn't actually appear above the orange element, even though it has a much higher Z-index value. And that's because any child elements within a container that already has a Z-index value, like the blue container, is only relevant to its parent. So each of our elements, the red Z-index of 0, the blue Z-index of 1, and the orange Z-index of 2, each have their own stacking context, which means that any child elements which have Z-index values are only compared to inside the parent element. It's kind of like the other elements in the other planes don't exist to the child element. So even though our black element, which has a Z-index value of 10, is the highest Z-index value across all the planes, the value 10 is only considered within its parent. So let's go check this out in VS Code. All right, so I'm back where we left off. I just want to move box 2 slightly up. So I'm going to change the top offset to 20 pixels and refresh. Let's now head to index.html And I'm now going to go add a div with the text child1, and I'm going to give it a class of child-1. I'll copy this div, change this to child2, and give this a class of child2. I'll head to app.css. Let's go select child1. I'm going to give it a height of 50 pixels, a width of 150 pixels, and a background color of red. I'll copy this class, change this to child2, and give child2 a background color of yellow. All right, I'll refresh, and we can see child1 and child2 inside box 2. So what's happening here is that our box 2 has a z-index value of 1. Now, child1 and child2 are children of box 2. So inside box 2, it's like we're back to a z-index value of 0. And that is what we mean by stacking context. Box 2 is its own stacking context. So let's add position relative to child2. I'm then going to add the bottom offset property and give it a value of 20 pixels. This now moves child2 above child1. And we discussed earlier, this is occurring because any element in the same plane that has a position property will always appear above. I'm also just going to go add position relative onto child1. I'll refresh and there's no change. Because both of these are now positioned relative, child2 will still appear above as it appears last in the HTML. But if I now go add a z-index value of say 1 to child1, you'll see it now appears above. Child1 is now in the z-plane of 1 inside box 2. And like we saw earlier, if I come and add a huge z-index value, which is well above the z-index value for box 3, child1 is only going to be the highest stacked element inside box 2. I'll refresh, and as you can see, child1 is still above child2. But watch what happens when I change the top value of box 2 to something like 120 pixels. I'll refresh, and you'll see that child1 is going behind box 3. So even though it has the highest z-index value compared to box 3, which has a z-index value of 2, this z-index of 99 is only being considered within box 2, which is its stacking context. So just be mindful when applying z-index values to children elements that they could be within their own stacking context, being set by its parent. So let's wrap up by building our next summary card, z-index, stacking, and transform. In this chapter, we looked at z-index and stacking context. We saw that the z-index property controls the vertical stacking of positioned elements. We looked at this diagram where we had an element with z-index of 0, which is just the default value. And on our web page, it would appear like this. We then added a z-axis and added a new plane which contained an element with a z-index value of 1. On our web page, this would appear above the element with a z-index of 0. We added a third plane, which had an element with a z-index value of 2, and this element would appear above the blue and red element, where the highest z-index values are on top. Each of these elements, which had different z-index values, created new stacking contexts, where any children inside these stacking contexts that had a z-index value were only considered in relation to their parent. For example, if we expanded the element z-index of 1 to become a container, and we added a child element with a z-index value of 99, the z-index of the child is only relevant within the parent. So even though it has the largest z-index value in this setup, it would never appear above the orange element, because it's a child of the element with a z-index of 1. And the z-index of the child element is in a new stacking context defined by the parent z-index of 1. Alright, so I'm back inside our Quill project. Now, we just spent a lot of time on the theory behind z-index. And honestly, it's one of those things that's just more important to know about. And at this stage, won't have too much use. But I am going to show you an example of where the concept of z-index would come up. On our Quill homepage, not too long ago, we created this chat icon, which is fixed to the bottom right of the viewport. Now I want you to imagine that when you land on the page, after say 10 seconds, a full screen modal window appears. A modal window is the same thing as a pop-up. So at the bottom of our HTML, we have our chat container, which is living outside the main container. I'm now going to go define in HTML a modal window. I'll create a new div. I'm going to give it the class modal. Let's add an h2 with New Year discount. I'll add a paragraph with get 50% off now. And let's add a button with the text claim now. All right, I'll refresh. And our modal window is just at the bottom left here. Let's head to app.css. In our components, I'm going to scroll down to just below chat icon, and let's go select the modal. I'm going to give it a position of fixed. I'm going to position it from the top of 0 and the left of 0. This effectively positions our modal in the top left. That is 0 away from the top of the viewport and 0 away from the left of the viewport. I'm then going to give it a width of 100% and a height of 100%. In our HTML, the modal's parent is just the body tag. So the modal's width and height will just be 100% of the body. So I'll refresh, and our modal is now taking up 100% of the page. Just to better see this, I'm going to add a background color of white. I'll refresh, and you can see the modal is taking up 100% of the page. Let's just vertically and horizontally center this. We'll add display flex. We want our main axis running from top to bottom, so we'll change flex direction to column, and to vertically and horizontally center, we'll set align items to center and justify content to center. I'll refresh, and our content now appears in the middle. Now this chat icon in the bottom right is appearing above our modal. So what's going on there? Because our modal has a position property of fixed, and our chat container also has a position property of fixed, our modal and chat container are both positioned elements. The chat icon appears above the modal because that's the order in the HTML. The chat icon comes after the modal. So one simple fix would just be changing the order. I could cut this and paste this before the modal. I'll refresh, and you'll now see the modal appears on top. Let me just put it back to where it was. I'll refresh, but a better practice is to instead add a Z index onto our modal with an extremely high value. So we know that no matter what the HTML is, the modal will always appear above everything else. So in app.css, let's grab Z index and give it a value like 999. I'll refresh, and you'll now see that our modal appears above all the other elements. And that's because it has an extremely large Z index value. So even though the modal in the HTML appears before the chat container, it has a very high Z index value and will always appear above everything else. Okay, this was just for demonstration purposes of where Z index may come into play, but I'm going to remove it from our Quill project as we won't need it moving forward. In the final chapter, we'll dive into applying rotations, scaling, and other visual effects to elements using transform. We'll be discussing the transform property, transformation functions, and positioned elements and translate. So what is transform? Transform applies visual transformations to an element like scaling, rotating, translating, and skewing. In CSS, it looks like this, where transform is the property name, with the value being a transformation function. In this case, it's a scale transform function. The different values can be scale, skew, rotate, and translate. So let's take a look at the transformation functions in more detail. The first one we have is scale. This resizes an element horizontally and vertically. It looks like this, where the first value in the parentheses is the x-axis scale factor, which is then comma separated by the second value, which is the y-axis scale factor. So in this case, our element will be scaled 2 times horizontally and 0.5 times vertically. The next function is skew. This distorts an element by slanting it horizontally and vertically. The function looks like this, where the first value is the x-axis slant angle, and the second value is the y-axis slant angle. So for this element, it's being skewed 20 degrees horizontally and 50 degrees vertically. The next function was rotate, and this rotates an element around its center. It looks like this, where the value in the parentheses is the angle the element's being rotated by. The last function was translate, which moves the element horizontally and vertically from its position. It looks like this, where the first value is the x-axis translation. In this case, a percentage value is used. And the second value is the y-axis translation. In this case, a negative pixel value is used. So let's go play around with these inside VS Code. Alright, so I've gone ahead and set up an index.html file and linked a style sheet which is currently empty. Inside our HTML, I'm going to add a simple div and give it a class of card. In our CSS file, I'm going to select the card. I'm going to give it a width of 200 pixels, a height of 200 pixels, and a background color of salmon. Okay, let's check it out in the browser. To better demonstrate this, I'm just going to move the element away from the edge of the browser. I'm going to give it a margin left of 100 pixels and a margin top of 100 pixels. I'll refresh, and this just moves our element slightly away from the edge of the browser. So let's now go add our transform property. I'll grab transform. The first transform function we looked at was scale. The first value is the amount to scale in the x direction. Let's make this 1.2. And the second value was the amount to scale in the y direction. Let's make this 1.5. Okay, I'll refresh, and you can see our element has scaled by 1.2 times horizontally and 1.5 times vertically. Now, this might seem a bit random. We could have just made the card this size. That is a width of 1.2 times 200 pixels, which would be 240 pixels, and a height of 1.5 times 200 pixels, which would be 300 pixels. What we can do, which is quite cool, is select the card's hover state and add the transform property there. I'll refresh, and now when I hover over the card, you'll see it scales. And this is quite a cool dynamic effect. The next transform function we looked at was skew, where the first value was the x-axis slant angle. For now, I'm just going to make this 20 degrees. And the second value was the y-axis slant value, which for now I'm going to set as 0, just so we can see how it skews in the x direction. I'll refresh and hover over the card, and you can see it skews by 20 degrees horizontally. Let's go swap these around now. I'll put 0 there and 20 degrees here. I'll refresh, and you'll see now the element is skewing 20 degrees vertically. Let's make them both 20 degrees. And you'll see the element is scaling both 20 degrees horizontally and vertically. Okay, the next function was rotate, and this was a single value which rotated the element around its center. Let's make this 45 degrees. I'll refresh, and you'll see how the element rotates by 45 degrees around its center. The last function was translate. The first value was the amount to translate in the x direction, which I'll set as 100 pixels, and the second value was the amount to translate in the y direction, which I'll also set as 100 pixels. I'll refresh and hover over the element, and you can see it's moving to the right by 100 pixels and down by 100 pixels. So those are the default positive value directions. A positive x value, like 100 pixels, moves it to the right, and a positive y value of 100 pixels moves it down. If I now make these negative, so negative 100 pixels and negative 100 pixels, I'll refresh, and you'll now see the element moves the opposite direction, that is, to the left and up. Okay, I now want to spend some time talking about positioned elements and translate. One thing you may be thinking is, what is the difference between translation and using the position offset properties? Well, using positioning and translate together provides precise control over element placement. Let's look at an example of this in diagram form. Let's say we have a web page defined by the root HTML element. Inside the page, we have a purple container, which is a div. We can absolute position this div with the property position and value absolute. We know this removes the element from normal flow and allows us to use the offset properties. For an absolute positioned element, we know that the offset properties are in relation to the closest non-static parent element. And if there are none, it's just the root HTML element. So in this case, our reference points are the edges of the root HTML element. So if we applied position left, this would move our purple div 50% from the left edge of the HTML root element. That is 50% of the parent. I'm going to draw a dashed line to mark 50% the width of the HTML root element, and our purple div will move like this. If we then applied a top of 50%, our HTML element will move 50% of the parent. That is 50% vertically of the root HTML element. I'll draw a line on our root HTML element, dividing it in half vertically. So our purple div will move like this. So what we end up with is that the top left of the element is centered, using our offset properties when our element has a positioned value like absolute. Now, this doesn't actually help us if we wanted to get our element smack bam in the middle of our web page. The top left of the element is in the middle of the web page, but in a lot of cases, we would actually want the middle of our element to be in the middle of the page. So to achieve this, we also need to use the transform property with the translate function. And it would look like this. For the x value, we're using minus 50%, which will move the element 50% of itself to the left. So it moves like this. And for the second value, which is the y-axis, we're again using a negative value of 50%. So it moves 50% of itself upwards. So it ends up perfectly in the center of the web page. So this is a good demonstration of using offset properties with positioning and translate, and how you can use them together to achieve precise placement of elements on your web page. Let's go play around with this inside VS Code. All right, so I've gone ahead and set up an index.html file and linked a style sheet which is currently empty. In index.html, I'm first going to add some paragraph tags and add a whole bunch of lorem ipsum text by typing lorem times 30. I'll then come down to the bottom, add a div, give it the class modal, as we're going to be making a modal window, that is a pop-up. Inside the modal, I'm going to give it an h2 with the heading modal window and some paragraph text modal paragraph. All right, in app.css, I'm first going to go clear out all the default margin and padding so we can work with a blank slate. I'll select the modal. Let's give it a width of 300 pixels, a height of 300 pixels, and a background color of light gray. All right, let's check this out in the browser so far. Okay, we can see all our lorem ipsum text, and if I scroll down, our modal window appears at the bottom here. So let's first go use position offset properties to start centering this modal window. On the modal, I'm going to go add the position property and give it a value of absolute. I'll refresh, and our modal window is now absolutely positioned. I'm going to move it left by 50%. The parent of the modal window is just the body tag. So it's going to move 50% the width of the body, and I'm going to move it from the top 50%. So the modal is going to move 50% from the top of the body tag. I'll refresh, and scrolling up, our modal is now 50% the width of the body tag and 50% the height of the body tag. But we want to get it into the center. So to do that, we use the transform property, grab the translate value, translate it negative 50% of itself, which will move it 50% to the left, and negative 50% of itself in the Y direction, which will move it 50% of itself up. I'll refresh, and you can now see the center of our modal window is perfectly in the center of the web page. Now if I scroll down, it doesn't scroll with me. But we can easily fix this by changing the position value to fixed. I'll refresh, and you can see the modal window now perfectly remains in the center of the web page even when I scroll. So you can see that for positioned elements, using offset properties, in addition to the transform translate value, enables us to have precise control of the placement of elements. Now, one question you may have at this point is why can't we just use Flexbox? Flexbox is a great way to center elements horizontally and vertically. Now, the reason Flexbox wouldn't be a good option here is because we want our modal window to appear above other content. By default, when setting a positioned value on an element, the browser will automatically render this above other content. Also, using a position value like fixed gives us access to the z-index property. So I could add a z-index value of, say, 999, and this would ensure that this modal window always appears above the other content. You just can't achieve this with Flexbox. The z-index property only becomes accessible when you're using a positioned value. So for a case like this, where we want a modal window to always appear above other content, it's better practice to position it and use offset values, and then use the transform property and translate function to perfectly center it in the middle of the page. Now, of course, Flexbox is available to use inside the container. So for example, if we perfectly wanted to center this content, the heading and paragraph, which are children of the modal, we could add display flex. We would change the flex direction to column. We would apply align items center and justify content center. I'll refresh, and doing this is perfectly acceptable. We're centering the content inside the modal window. What we're not doing is using Flexbox to center the entire modal window on the page. We're using the offset values and the transform property. So let's now take a look at some transform guidance. Scale is often used when hovering over an image to create a dynamic visual effect. So this transform is being triggered by state change, which we played around with earlier in VS Code. Taking a look at an example, looking at the middle image, if you were to hover over this on the web page, its size scales up. So the image enlarges when hovered over, creating an interesting visual dynamic effect. Translate is used on position modals to achieve precise centering within their containers. Here's an example of exactly what we did in VS Code earlier. Here's a modal, which is centered on the web page. This is achieved by positioning the element with a fixed value, offsetting it 50% top and 50% left, and then using the translate function to center itself left and up. Translate is used on positioned alerts to achieve precise alignment in the top right corner. Taking a look at Etsy, which is an e-commerce site, I'm going to zoom in on the cart in the top right corner. We have a parent element, which we would give a position relative value to act as an anchor so that our notification circle can be positioned absolute so that we can offset the notification number in reference to the closest positioned ancestor. In this case, the shopping basket icon. On the number 1 notification, we would use our offset properties like top 0 and right 0 to move the icon to the top right of the shopping basket icon. And then we could use the translate function to move it 50% to the right and 50% up so that it would appear in the top right corner. So let's finish off our summary card, Z-index, stacking, and transform. In this video, we looked at transform functions. We saw there were 4 types. There was scale, which resizes an element in the X and Y direction, where the CSS value looks like this. We have skew, which slants X and Y, and the CSS function looks like this. We have rotates, which rotates an element around its center, and the transform function looks like this. And we have translate, which moves an element X and Y from itself, and the transform function looks like this, where you can use percentage or pixel values. We then spent some time discussing positioned elements and translate, where we saw we could have precise control of placing an element using both positioned offset properties and the translate function. We have our web page in gray, and a red container element like a div. We would absolute position this element. Now, because the element is absolutely positioned, and there are no other elements on the page, its reference point are the edges of the web page, that is, the root HTML element. So using offset properties, you could apply left of 50%, which would move our element 50% of the parent. So it would end up over here. We could then use the offset top and set it to 50%, which would move the element 50% of the parent's height. So it would end up over here. And then to perfectly center the element, we would use the transform property with the translate function and set the X value to minus 50%. So it would move to the left 50% of itself and end up like this. And the Y value is set at minus 50%. So again, it will move 50% of itself in the upwards direction. So it would end up like this. So our element is perfectly centered on our web page, using both positioned offset as well as the translate function. Alright, as I've mentioned already, I'm actually happy with where the Quill project currently is. However, I do want to demonstrate the transform property on our homepage. So the first thing I'm going to do is I'm going to go add a little beta symbol in the top right corner of the Quill logo to signify that this application is in beta. The second thing I want to do is very slightly scale our buttons when we hover over them, just to give a bit of a visual dynamic effect. So let's go handle the buttons first. Alright, so I'm back inside our app.css file of the Quill homepage. I'm going to scroll down to our button components. And for our hover and active states for each button type, I'm just going to come and add the transform property, grab the value scale, and I'm just going to scale it by a very small amount of 1.05, which would be 5% in the X direction, and then 1.05 for 5% in the Y direction. I'm going to copy this and just add it to the hover and active state for each different type of button. So for our outline button and for our secondary button. Okay, I'll refresh and let's go see this effect. I'm going to hover over Get Started, and you can see it just pops a little bit more. It's a very subtle visual effect that just makes the element a bit more interesting. There's our primary button, there's our primary outline button, and for the secondary button, you can see that little pop just makes the homepage seem a little bit more dynamic. So now let's go handle the beta in the top right corner. The first thing I'm going to do is head over to index.html. I'm going to locate the logo, which is over here. We have an image self-closing tag wrapped in an anchor tag. Now to achieve this, I'm actually going to go use a pseudo-element. We covered this much earlier on in the course, where we saw we could use pseudo-elements to inject decorative elements onto our page without actually adding the content in the HTML markup. I want to do it this way because I don't really want beta to be inside the HTML markup. It's a little bit more of a decorative element that's being added to the page. So what I'm going to do is come add a class onto this anchor tag and set its value to beta. I'm going to head to app.css. I'm going to scroll down to the bottom of our components, as this is a piece of UI that we may want to reuse elsewhere. The first thing I'm going to do is select the beta class, and I'm just going to give this a position of relative. The aim of this is just to create our anchor point for our pseudo element. So effectively, all I've done is I'm saying that this anchor tag should now be our anchor point for when we come and position our pseudo element. So let's go do our pseudo element now. I'm going to select beta. For pseudo elements, we add 2 colons, and I'm going to do this after. I want this decorative element injected after our anchor tag. So the first thing I'm going to do is grab the content property. We saw this earlier in the course where we can add some text like the word beta. I'm now going to use the position property and set its value to absolute. So I'll refresh, and you can see straight away we have our beta icon being injected after the anchor tag. And now we're going to go use offset properties to better position the beta. Now, if you remember, for absolute positioned elements, its reference point is the closest non-static ancestor. And that is why I added position relative onto the beta class. I did that because our pseudo element over here now has a reference point of the anchor tag itself. So if I open up DevTools and inspect the anchor tag over here, the edges of this blue box is now the reference point for the beta text. So I want to initially get it in the top right corner. So I'm going to add an offset property of top with a value 0, and the offset property of right with the value 0. I'll refresh, and this now moves our beta into the top right corner of our quill logo. Now again, this might seem a bit confusing, so let me just go through it one more time. Our beta pseudo element, which is the content beta, is absolutely positioned, and its reference point is the logo itself. That's because we added a class onto our anchor tag, which is wrapping the image, beta. So the edges of the blue box that you see here is the reference point for our pseudo element. So setting a top of 0 moves our element 0 away from the top of the logo, and a right of 0 moves it 0 away from the right of the logo. And once again, this is all being achieved because for absolute positioned elements, like our pseudo element over here, its reference point is its closest non-static ancestor, which for us is just the anchor tag itself. So that's why it's really important we added position relative onto this class over here so that it could act as the reference point for our pseudo element. Now, before we go and use the transform function, I just want to improve the style of this. Let's give the beta a font size of 1.2 rem. I'm going to give it a background color of our tertiary base, so that orange color. Let's give it some padding of 0.5 rem and 1 rem. And I'm going to give it a border radius of 4 pixels. All right, I'm just going to refresh this. All right, this is looking a lot better. The last thing I want to go do is just change the font color to our white. I'll refresh, and this is looking good. So now all we want to do is move the beta icon a bit more up and a bit more to the right. So to do that, we're going to use the transform property. We're going to grab the translate function. To move it to the right, we need to use a positive value. I'm going to initially try 50%, and to move it up, we need to use a negative value. So I'm going to use a negative value of 50%. Now, you could use pixels here. I just want to use percentages. And if you recall, for this first value is the width of the parent, and for the second value is the height of the parent. The parent is the logo itself. So let's refresh this. And this is looking good, but I actually want it a little bit more up and to the right, as this is just blocking too much of the text. So I'm going to come and change this value to 70% and minus 70% here. I'll refresh, and for me, this looks great. It's moved to the top right and isn't covering the text of the logo. Okay, so once again, I just wanted to demonstrate the use of the transform function. We've added a nice scale effect onto our buttons, and we've added in this decorative beta element. As I've mentioned, I'm actually happy with the page how it looked before, but I did just want to demonstrate this so you could see the transform property in action. And don't worry too much about the pseudo element. This may seem a bit advanced because pseudo elements are always confusing, but just remember, a pseudo element is just injecting some content after the page renders, and we're just absolutely positioning this pseudo element, where its reference point is the logo itself. Well done, positioning is complete. You now have the skills to control the precise placement of elements on your web page, giving you full flexibility in your designs. Next up, we'll dive into how we can enhance our web page design with shadows and transitions. We'll kick off by learning how to add depth and dimension to elements on your page using shadows. We'll be discussing how shadows work, the shadow property, shadow design guidance, and flat design versus shadows. So let's first talk about how shadows actually work. I'm going to be explaining it using this table and carpet setup. I'm going to place a torch above the table so that it's positioned right in the center of the table. This would result in a shadow being cast directly under the table. If we were to look at the table from top down, all we would see is the top of the purple table. And I'm just going to mark the current position of the torch. Now, moving light in the same plane as the table moves the shadow horizontally and vertically on the floor. So I'm going to move our torch to the bottom right of the table. And looking top down, it would appear as if our shadow has moved up and to the left. In CSS terms, we would call this the X offset horizontally and the Y offset vertically. So that's the first thing we can do. We can move the position of the torch, which would result in the shadow moving in the X direction and in the Y direction. Let's look at the second thing we can do. Moving light up and down creates a blur, resulting in edges that appear soft or sharp. So what I'm going to do is move the torch up, and this would result in the edges of our shadow blurring like this. So as we move our torch up and down, the edges of our shadow will become soft or sharp. And in CSS terms, we call this the blur radius. Now for the last factor, the size of the table impacts the size of the shadow. So if we increase the size of the table, this in turn would cast a larger shadow. And in CSS terms, we call this the spread radius. So let's now take a look at the shadow property. In CSS, it looks like this, where the property name is box-shadow, and we have 5 different values. I'm going to be talking about them in reference to the table we just looked at. The first value, 10 pixels, represents the X offset, and this moves our shadow horizontally, where a positive value like 10 pixels will move it to the right, and a negative value would move it to the left. The second value, minus 20 pixels, represents our Y offset. This moves our shadow vertically, where a negative value like minus 20 pixels moves our shadow up, and a positive value would move it down. The next value, 5 pixels, represents the blur radius, which softens the edges of the shadow like this. The next value, 30 pixels, represents the spread radius, which will enlarge the size of the shadow, as if the element was larger in size, just like we increased the size of the table. Now the last value is color, so we can actually change the color of our shadow to something like a blue. Now the X offset and Y offset values are always required. We have to provide those for box shadow to work. The other 3 values, blur radius, spread radius, and color, are all optional. So let's go play around with this inside VS Code. Alright, so I've gone ahead and created an index.html file and linked a style sheet which is currently empty. In our HTML, I'm just going to go add a div and give it the class container. In app.css, I'm going to select the container. I'm going to give it a width of 400 pixels, a height of 400 pixels, a background color of gray, and just to move the container away from the top left of the browser, I'm going to give it some margin top of 200 pixels and margin left of 200 pixels. All right, let's check it out in the browser. Okay, so here's our gray box. Now let's go play around with the box shadow property. I'll go grab box shadow. And as I mentioned, we have to provide an X and Y offset value. I'm first just going to set these both to 0 pixels. I'll refresh. And at the moment, the shadow is directly under the box, just like we saw with the table example when the light was shining directly into the center of the table. Let's first add 50 pixels for the X offset. I'll refresh, and you'll see the shadow moves to the right by 50 pixels. I'll add 50 pixels for the Y offset, and you'll see the shadow moves down 50 pixels. And as I mentioned, we can also make these negative values, so it moves in the opposite direction, in this case, left and up. Okay, I'm just going to change them back to positive values, and let's now take a look at the next value. The next value is the blur radius, which just has a default value of 0 pixels. So I'll refresh and you'll see there's no change. Let's now change this to a value like 10 pixels. I'll refresh and you can see the edges of the shadow are beginning to blur. Let's increase this to 20 pixels and you'll see it blurs even more. So a higher blur radius value will result in the edges of our shadow being softer. The next value was the spread radius. The default value is 0, so if I refresh, you'll see there's no change. Let's change this to a value like 30 pixels. I'll refresh and you can see the shadow has now increased in size. Now, one thing I do want to discuss at this point is that if you just wanted to add a spread radius and no blur radius onto your shadow, you'd explicitly have to give your blur radius a value of 0 pixels. I'll refresh, and the reason you have to do this is because the third place value will always be the blur radius, and the fourth place value will always be the spread radius. So if I just did this and refreshed, the browser's interpreting this as a 30 pixel blur radius, not spread radius. So to ensure we get a 30 pixel spread radius, we have to explicitly give the third slot for the blur radius a 0 pixel value, so that our value of 30 pixels is now in the fourth slot, which is for the spread radius. All right, I'm just going to change this back to 10 pixels. And the final thing we can do is change the color of our shadow. I'm just going to make this blue. I'll refresh and you'll now see our shadow is blue. So let's now take a look at some shadow guidance. Shadows can be used to add depth and dimension to a design to create separation between UI elements. Looking at this web page here, this UI element in the center of the page, listing the main use cases of this web application, has a shadow to create a separation between it and other elements on the page. Another common example of this is on cards, where they have shadows to add depth and dimension in order to separate them and create contained units. The next piece of guidance is that shadows should be light, as darker shadows can create a harsh and unnatural appearance in the design. Looking at this web page over here, the shadows should be light and not too dark. You can see the light shadows on each of these cards is subtle and helps contain the content, where a dark shadow would just look a bit too overpowering. Let's now talk about the sizes of shadows. Smaller shadows are ideal for enhancing smaller components like buttons and cards, which add subtle depth. Looking at this page over here, this card has a small shadow which helps create a subtle depth. Medium-sized shadows can be used for larger components, helping them stand out. Looking at this web page over here, this main image has a medium-sized shadow, helping it pop a bit more. Large shadows are used when an element should appear to be floating above the rest of the design. A good example of this is on a drop-down for a navigation bar, where a large shadow is used, which gives it the appearance as if it's floating above the rest of the page. Now, the last thing to discuss is flat design versus shadows. Flat design uses borders and background colors to achieve separation instead of shadows. Looking at an example of this, on this web page, we have a border on our navigation bar, as well as borders on all of our cards. The borders contain related content and create separation between different content. You can see no shadows are used on this page. Another example is this web page here, where both these cards are using background color to contain their content and create separation. Now, me personally, I'm a big sucker for flat design. I don't personally like using shadows, as I love simple, flat design. However, if you do plan on using shadows, shadows should not be used too often, as overuse can make a design look cluttered and overwhelming. This web page is a good example of how to use shadows. You can see these testimonial cards have shadows which make them pop, but below we have a card which is just using background color. So shadows are being used throughout this design to help elements pop, but are not being used too much. So let's wrap up this chapter by starting to build our next summary card, shadows and transitions. In this chapter, we looked at shadows, which we saw were used to add depth and dimension to elements. The CSS property looked like this, box-shadow, and looking at this in diagram form, we looked at a table on a carpet. The first value, 10 pixels, is the X offset. The second value, minus 20 pixels, is the Y offset. And this will move our shadow in the same plane as the table. In this case, 10 pixels to the right and 20 pixels high. The next value is the blur radius, which will blur the edges of the shadow, like we see here. The next value of 30 pixels was the spread radius, which increases the overall size of the shadow, like we see here. And the final value was the color, which changes the color of the shadow, like we see in the diagram here. Now, the X offset and Y offset are required, whereas the blur radius, spread radius, and color are all optional. Alright, so I'm back inside our Quill project. As I've mentioned a few times by now, I'm already happy with how the design looks, and I'm personally a big fan of flat design, so I generally don't like adding shadows. But for the purpose of implementing the shadow property we just looked at, I am going to go add some shadows. I'm going to add shadows to the hover state of our buttons. When I hover over our buttons, I'd like a small shadow to appear beneath them. Now I'm actually going to go handle the secondary button first, because that has a blue background. And the color of the shadow needs to work on this button when there's a colored background, as well as our primary and outline buttons, which just have a white background. So I'm going to scroll down to the button secondary, hover, and active state. I'm going to add our box shadow property. Now, I just played with these values earlier to make them look good. So usually you'd go through a bit of an iterative process to find values you're happy with. I'm going to set an X offset of 0. I only want the shadow to appear below the button, and not move left or right. I'm then going to use a 3 pixel Y offset value so that it moves down by 3 pixels. I'm then going to set a blur radius of 6 pixels, and I'm going to set a spread radius of 0 pixels, as I don't want the shadow to get any larger. For the color, I'm going to use our gray base color. I'll refresh, and you'll see when I hover over the button, we get a very subtle shadow appearing below it. Now, just to note, for the spread radius, I don't actually have to include that, so I could remove it, because the browser is smart enough to know that this value is to do with color and not spread radius, so it just ignores the value over there. So I'll refresh, and you'll see there is no change. Now, I know I mentioned in the guidance, we generally want our shadows to be lighter, but the problem is, if I use the gray tint value, you'll just see how funny this looks. It's just a bit too overwhelming when we have a gray tint on the blue background. So I'm just going to change this back to the base color. So I'm now going to copy this declaration, and I'm going to add it to our primary outline, hover, and active state, as well as our primary hover and active state. I'll refresh, and you'll see when I hover over these buttons, we get that same shadow appearing below. Now, in a perfect world, I probably want these to be a bit lighter, but we are being a little bit forced to make it darker because of this case down here. But it still does look fine, and makes these buttons pop quite nicely when you hover over them. Next up, we'll explore how to create smooth, animated style changes with transitions. We'll be discussing what are transitions, timing functions, and transitions design guidance. So before we start discussing transitions, I want to discuss how things work when we don't have transitions. When an element moves between states, the changes occur immediately. We're talking about between states here, so we're thinking about pseudo-classes. As an example of this, if we have a button and our cursor, and on the button we have a pseudo-class for the hover state to make it change color, this is what would happen. As soon as our cursor hovers over the button, it changes color immediately. Let's go play around with this inside VS Code. Alright, so I've gone ahead and created a new index.html file and linked to style sheet, which is currently empty. In our body, I'm just going to add a single div, and I'm going to give it the class card. In app.css, I'm going to select card. I'm going to give it a width of 500 pixels, a height of 500 pixels, and a background color of light blue. I then want to select the hover state of this card using a pseudo class, and I'm going to change its background color to light coral and its border radius to 50%, so that when we hover over our card, the background color will change, and it will change from a square to a circle. So let's check this out in the browser. So you can see, initially, we have our light blue square, and watch what happens when I hover over it. It instantly changes to a light coral circle. The main point I want you to take away is that the change in state is instant. So transitions are used to create a smooth, gradual change to an element's properties when it undergoes a state change. So looking back at the example before, if we now hover over our button, you'll see it gradually changes to purple and is not instant. This user experience is just smoother and doesn't feel so jarring. So let's take a look at the transition property in CSS. It looks like this, where transition is the property, and there are 3 possible values. The first value, in this case background color, is the property we are wanting to undergo a transition. The next value is the duration of the transition, measured in seconds, in this case 0.5 seconds. And the last value is the timing function. This is the rate at which we want the transition to occur. We're going to be looking at the timing function in more detail soon, but it is responsible for how we use our 0.5 seconds. Do we want the transitioning happening really fast to start and then slowing down, or really slow to start and then speeding up? Now, some important notes. The transition property is defined on the initial state. So not on the pseudo class, but the initial state. Now, the next note is that for the property you specify, it defaults to all properties that are changing if not defined. So we don't actually have to provide a property that's undergoing the change. We can leave this blank. And what this means is that any properties that are changing between the initial state and what's in the pseudo class will automatically all go through the transition. The duration is required, and for the timing function, it defaults to ease properties if not defined. Ease is just one of the timing functions, so if we don't specify a timing function, it will just be ease. And we will explore timing functions in a bit more detail soon. So let's go play around with this inside VS Code. So picking up where we left off, let's go add a transition onto our cards so that the properties that are changing, the background color and border radius, doesn't happen instantly. As I mentioned, we add the transition property on the initial state, in this case the card, and I'm just going to put the single value that is actually required, which is the time. I'm going to make it 2 seconds. I'll save and refresh and watch what happens when I hover over the card now. Over a 2-second time period, the card is nicely transitioning from a blue square to a coral circle. Now, because I haven't specified the properties I want to change, the transition will automatically change any properties from the initial state to the hover state. In this case, the background color is changing between the two. And although the border radius isn't explicitly defined on the card, the border radius on the card is 0. And the border radius here is 50%. So that is changing from 0 to 50%. Something like width and height is not changing between the card and hover state. So that isn't being picked up by the transition. The transition is only picking up properties that are actually changing. Just to explore this a bit more, if I come and add a border on our initial state of 5 pixels solid and black, I'll refresh, you can see the border is there, and when I hover, our 5 pixel border is not changing. If I wanted it to change, I would need to add a border property onto our hover state. Let's make it something like 20 pixels dashed and green. And now because our border is changing between states, that will be picked up in the transition. So I'll refresh, and you'll see the border changes to our dashed green. Now let's check out the case when I only want a specific property to change. For example, let's just change the background color. So to do that, the first value would be background color, and we keep the 2-second duration. I'll refresh, and you'll now see only the background color undergoes the transition, whereas the border radius and border will instantly change. Let's check that out. So you'll see we went immediately from a square to a circle, and a black border to a green border, whereas the background color does take time to transition, because that is the only property we're specifying to undergo a transition. If I wanted to specify another property, we would comma separate this, and for example, let's do border radius, and set its value to say 3 seconds. I'll refresh, and you'll now see the border radius and background color undergo a transition, whereas the border will instantly change. So let's check this out. You'll see the green border instantly changed, whereas the background color and border radius underwent transitions. Now, in most cases, it's fairly simple, and we do just want all our properties on the hover state to change. So a lot of times, the property value will be blank. So let's now take a deeper dive into timing functions. Timing functions controls the speed of the animation. I'm going to be going through some of the more common timing functions. The first one is ease. This starts slowly, speeds up, and then slows down. Now for each of these, I've got a small visualization. This green ball starts slowly, speeds up in the middle, and then slows down. The next timing function is linear, and this is a consistent speed start to end. Looking at this visualization, the green ball is just remaining at a constant speed. The next timing function is ease in. This starts slowly and accelerates to the end. In our visualization, you'll see our green ball starts off slowly, but then accelerates towards the end. The next timing function is ease out. This starts quickly and slows down towards the end. It's the opposite of ease in. In our green ball visualization, you'll see it starts very quickly and then slows down towards the end. The final timing function we're going to look at is ease in out. This starts slowly, speeds up in the middle, and slows down at the end. In our green ball visualization, you'll see it starts slowly, speeds up towards the middle, and then slows down. Now, if you don't specify a timing function on your transition, it just defaults to ease. And in all honesty, I wouldn't worry too much about these. The timing functions are there to provide precise control of how you want your transitions to play out. But I wouldn't stress about them too much, and in most cases, I would just use the default ease state, which means that you don't even need to specify a timing function. But let's go play around with these inside VS Code. Alright, so I've gone ahead and prepared this file ahead of time. In our HTML, I have repeated units like this. I have a paragraph denoting the timing function name, for the first one ease, and then I just have a div where I've given it the class of the same name. These units are repeated for each timing function, so linear, ease in, ease out, and ease in out. In our CSS file, each of the divs are styled the same. The only difference between them is the timing function. You'll see each div has the same width and height, the same background color, and the same margin bottom just to create space. These 4 properties are repeated on every single div. The hover states are also the same. The only thing I'm changing is the border radius for each div. So ease hover has a border radius of 50%. And linear hover also has a border radius of 50%. The only difference between each of these divs is the timing function on our transition property. So for ease, the transition property is ease. For linear, the transition property is linear. For ease in, it's ease in. For ease out, it's ease out. And for ease in out, it's ease in out. So let's go through these one by one. I'm going to hover over ease, and this is the default value, which starts slowly, speeds up, and then slows down. For linear, the transition happens at a consistent speed. For ease in, it starts slowly and accelerates to the end. So you'll see there it got a lot faster towards the end of the transition. For ease out, it's the opposite. It starts quickly and then slows down. And for ease in out, it starts slowly, speeds up in the middle, and then slows down at the end. Now, just to note, ease and ease in and out may seem the same. They're both starting and ending slowly and speeding up in the middle. So there's ease, and there's ease in out. Now, the difference has to do with the acceleration in the middle. And you can see how these timing functions can just be a bit overkill. And just to show you how far it can go, there's some incredibly complicated timing functions. There's this thing called a cubic bizer, which is like a very complicated mathematical curve. So you can have a timing function looking like this. I'll refresh. And this timing function is just doing some wild stuff that honestly is just not necessary for most everyday application. I wouldn't worry too much about all these different timing functions, and for now I would just stick to not even specifying one and having the default value of ease. But timing functions are just something you need to know about. So let's now take a look at some transitions guidance. Transitions on buttons add subtle visual feedback. For example, on this web page here, the primary button translates when you hover over it. That is, it moves to the right. And this translation doesn't happen instantly because a transition is being applied so that the change is more subtle. Let's check this out in the browser. So I'm on the web page here. I'm going to hover over this primary button, and you'll see it moves to the right, but doesn't happen instantly as a transition is being applied to move it gradually. Here's another example of a transition being applied on a button. When I hover over it, you'll see a shadow appears, and again, it's not appearing instantly because a transition has been applied, which almost makes it look a bit animated. The next piece of guidance is that transitions can make card components pop. For example, on this web page here, when you hover over one of these cards, they rotate. And the rotation doesn't happen instantly, but it's smooth and gradual. Let's check this out in the browser. So when I hover over these cards, you'll see they each rotate, but the rotation isn't happening instantly, as the transition helps gradually rotate the cards, giving a really cool animated effect. On this web page, transitions are also being applied on these cards here. When I hover over it, the background color and font color change, and there's a subtle transition so that this change doesn't happen instantly. So let's now finish building our summary card, shadows and transitions. In this chapter, we looked at transitions, where a transition creates a smooth, gradual change to an element undergoing a state change. The CSS property looked like this, where we had 3 different values. The first value is the property we want to undergo a transition. The second value is the duration of the transition. And the third value is the timing function. We saw some important notes, where the first value defaults to all properties if none are set. The duration is the only value actually required. And for the timing function, it defaults to ease if none set. We also spent some time discussing timing functions, where timing functions control the speed of the transition. And some common values we looked at were ease, linear, ease in, ease out, and ease in out. And I mentioned I wouldn't worry too much about these, as they're just a bit overkill, and the default value of ease will work perfectly fine in most of your projects. Alright, so I'm back inside the Quill project, and we're finally up to adding our last property. At the moment, our buttons, when we hover over them, are scaling and have a shadow applied, but this is currently happening instantly. So let's just go add a simple transition onto them to smooth this out. The transition is added onto the initial state and not the hover or active state. Now, the best place to add the transition is on the link and visited pseudo-class for each button. We don't want to add the transition on this button class here, as these properties have much more to do with the actual structure of the button. We want to come and add the transition on the link and visited pseudo-class. So I'll grab transition, and all I'm going to do is add a 0.5 second duration. I'll refresh, and you'll see now when I hover over the button, the state change is just a lot smoother. So I'm now just going to copy this transition declaration and add it onto the link and visited state for each of our different buttons. So I'll add it here for our outline button, and I'll add it here for our secondary button. I'll refresh and let's go try them all out. There's a nice smooth transition, again a nice smooth transition, and for our secondary button down the bottom, again a nice smooth transition. Now once again, I don't want to be adding a transition over here because this handles all our button structures. It's better practice to add it here as it gives us precise control over the transition for each button type. Alright, we are now finished the Quill project. Let's go full screen and check it out in all its glory. Now if this is your first web page and you've understood all the concepts we've gone through, this is a fantastic start. We've used CSS to build a fully responsive, well-designed page that follows CSS best practices. So amazing work on being able to finish this project. That's shadows and transitions ticked off the list. You've unlocked the ability to enhance your designs with depth and fluid animations. It's now time to move on to the last topic of the CSS Full Course, where we'll be doing a deep dive into CSS Frameworks. CSS Frameworks provide pre-built styles and components to help you quickly create responsive, well-designed web pages. We'll explore the most popular frameworks, Bootstrap and Tailwind, and see how to use their pre-designed components and utilities to speed up web design in CSS. So before we finish the last topic, I just wanted to quickly let you know a bit more about my mission at Future Fullstack. Future Fullstack has been built to be the world's best online full-stack web development bootcamp that delivers a world-class learning experience at an affordable price. As you've hopefully seen from this course, I value creating incredibly high-quality material that comprehensively covers everything you need to know in a fun and engaging way. The bootcamp is designed for complete beginners with no coding experience, and by the end, you'll be able to build sophisticated full-stack web applications. It's ideal if you're looking to start a career in software engineering or wanting to launch your own dream web applications. This CSS Full Course you are currently watching is part of this bootcamp, where the same high-quality teaching can be experienced in all other topics. The bootcamp is split into two major sections, where first we cover web development fundamentals, with the topics Introduction to Web Development, HTML, CSS, and JavaScript. The second section of the course is Full Stack Development, where we take what we have learned from the fundamentals and extend our knowledge to build a full-stack web application. We cover the topics databases, web design, Node, Express, and React. Now, most bootcamps out there build different projects within different topics, often referred to as capstone projects. In this bootcamp, we work on the Quill Major Full Stack project, from the very first video to the very last. This approach is much smarter, as the most challenging aspect of full stack web development is getting a real understanding of how the front end, back end, and database all work together. And you will not be able to see this in smaller topic-based projects. Now, for complete transparency, the fundamentals of the bootcamp will be completely free on YouTube. This means no matter what, you can master HTML, CSS, and JavaScript without spending a cent. If you're serious about learning web development, you'd likely be paying for similar courses on other platforms. But with me, not only will you save money, but you'll also get a superior learning experience at no cost. For those ready to take their skills to the next level, I'm offering the Full Stack Development section as a paid option. Head on over to futurefullstack.com to learn more. While I'd love to give everything away for free, I have a family to support and bills to pay. That said, even with the paid section, you'll still be saving thousands of dollars compared to a traditional bootcamp, while receiving the highest quality learning experience. I hope I've done a good job at convincing you why Future Full Stack is the best option for learning web development. But let's now get back to it. We're going to start off this topic by exploring the fundamentals of CSS frameworks and how they can help you speed up the development process with an introduction to CSS frameworks. I'll first be giving a word of warning. We'll then discuss how CSS frameworks work, and then we'll take a look at the types of CSS frameworks. So first of all, a big word of warning. Do not touch CSS frameworks until you have a solid understanding of CSS fundamentals. Now, when I started out, I was so eager to use CSS frameworks that I jumped into them straight away without fully mastering CSS. and it just becomes a very frustrating experience because you just can't work with CSS frameworks until you really understand the fundamentals of CSS. So to understand this a bit more, we have our web page, and we know that the core of our web page is built in HTML, that is, all the content. CSS is then a layer that sits on top of HTML, and you need to know HTML to work with CSS. CSS is all about the styling of HTML elements, and if you don't know about HTML elements, you can't style them. It's the same thing with CSS frameworks. They're a layer that sits on top of CSS, and you need to know CSS to work with frameworks. Just like you couldn't work with CSS without knowing about HTML, the same thing is true with CSS frameworks. You just won't be able to use them properly without understanding CSS properly. Now, as always in this course, I am going to be walking through two very popular CSS frameworks in detail to give you a solid understanding of how they work, but I really do beg you that when you finish this course, don't jump into CSS frameworks, rather go build a handful of web pages yourself just using regular CSS. I know it's a longer journey to eventually get to a framework, but I promise you it will make your life much easier. So what is a CSS framework? A CSS framework is a ready-made collection of CSS code to simplify and speed up the process of styling web pages. To understand this, let's look at different ways we could build a cupboard. The cupboard is an analogy for a web page. Now, to build a cupboard, we need to work with raw materials. With wooden planks and screws, this represents CSS code. Now, the first way you could build your cupboard is use the raw materials to build it yourself. You could go to the hardware store, buy some wood, some nails, and some other pieces to build your cupboard. But an easier way to do this is going to a store like IKEA. And IKEA represents our framework. For anyone that doesn't have IKEA in their country, IKEA is a very popular furniture store where you can buy items for your home. So say, for example, a cupboard. Let's say we wanted to build this cupboard here. You would go to IKEA and you would purchase a flat pack of materials. If I go over here, product details, assembly and documents, assembly instructions, your flat pack would contain the large wooden pieces and all the bits needed to build the cupboard, like these big and small screws. And you're provided instructions with how to build the cupboard. So with IKEA, raw materials are packaged up by IKEA, and then we use IKEA parts and instructions to build the cupboard. So through this analogy, you can see how using a framework can be a much faster and efficient way of building a cupboard versus doing it yourself from raw materials. So the last thing I want to discuss are the different types of CSS frameworks. CSS frameworks are built around core philosophies. There are three main types of CSS frameworks. The first is component-based. This is where the framework provides ready-made UI parts. These parts are responsive, so out the box, they're ready for all screen sizes, and often contain JavaScript in them, so they are a lot more interactive and respond to user actions. An example of a component is something like a button, where in this class here, we have btn and btn primary, and with these two lines of code, we would be given a button that's already styled for us. The most popular component-based CSS framework is Bootstrap, which we'll be looking at in the next chapter and build a mini project from scratch. The next type of framework is utility-based. Utilities are simple classes for styling. You can see an example of a utility here, MB-8. This stands for margin bottom, and the number 8 represents a particular rem value. And for margin bottom, the values would be MB1, 2, 3, 4, 5, 6, 7, 8, etc., where each number represents a rem value which is provided in the documentation of the framework. A very popular utility-based framework is Tailwind CSS, which will also be building a mini project after Bootstrap. The final type of CSS framework is CSS in JavaScript. This is where you can work with CSS directly inside JavaScript. Now at this point, that may not make too much sense, but the reason this is helpful is because in a language like React, being able to use CSS inside JavaScript effectively allows you to write HTML, CSS, and JavaScript all within the same document. Now again, that won't make too much sense right now. For now, you just need to know that CSS in JavaScript is just another type of framework. And just to show you, here's a snippet of what it would look like. And again, don't worry at all about the syntax. A very popular CSS in JavaScript framework is styled components. And we're going to be using styled components later on in the React module of the Fullstack bootcamp. Now, just a small comment, I don't know what's up with this logo. Why is nail polishing the logo for this? I just don't get it. Anyway, one thing you're going to quickly learn in the development community is that it's very quick to learn which tools only have developers on their team, because their logos just kind of suck. Anyway, nowadays, the frameworks integrate core features from other approaches for more flexibility. So while something like Bootstrap is at its core component-based, there are still utilities available. And the same thing with Tailwind. At its core, it is utility-based, but there also are components available. So frameworks today have a core philosophy, but also take good things from other types of CSS frameworks. Now it's time to dive into one of the most widely used component-based CSS frameworks and explore how it simplifies creating responsive and modern web designs using Bootstrap. We'll be discussing what is Bootstrap, why is Bootstrap helpful, we'll be doing a Bootstrap walkthrough, and then we'll work on the Bootstrap homepage project. So what is Bootstrap? Bootstrap is a component-based CSS framework for building responsive websites with pre-designed components and utilities. The component-based is Bootstrap's core philosophy. It's responsive, which means it works across all devices. At its core, it has pre-designed components, which are pieces of UI like buttons, cards, nav bars, etc. And it also has utilities, which are simple classes. Bootstrap is very popular and is used by small and large companies. Let's take a look at some example web pages using Bootstrap. Airbnb is an example of a very big company using Bootstrap, and this e-commerce site selling chewable toothpaste bites is also using Bootstrap. So Bootstrap is used on very large applications like Airbnb and smaller applications like Bite toothpaste. So why is Bootstrap helpful? To understand this, I want to look at a little bit of the history of why Bootstrap was developed. Bootstrap was initially developed in response to major limitations in CSS layout features. Bootstrap was actually developed by the team at Twitter and was made open source so people like you and I could use it. Twitter is now Elon Musk's company X. So let's take a look at a quick timeline. The first date I want to look at is 2017. This is when Flexbox and CSS Grid were fully implemented, which means that layouts were very difficult before 2017. Having used both Flexbox and CSS Grid, you know how powerful they are in helping lay out web pages. And you can just imagine how hard it would be to achieve those kind of layouts without these CSS features. So in 2011, Bootstrap was released with its grid system and components. Bootstrap's grid system is different to CSS Grid, but it provided developers with a much easier way of laying out elements on a web page. Bootstrap also gave us a whole array of UI components, like buttons, so you didn't have to write them from scratch. So both the grid system and these pre-built components made coding up web pages a lot easier. Now from 2011, Bootstrap was continually improved by making the framework more responsive and adding more components, up until the present day. Another major date is 2018, where utility classes were embraced in Bootstrap while retaining its component-based structure. Now this was done because the use of utility classes, which we're going to look at in a second, was quickly becoming very popular and was championed by frameworks like Tailwind CSS, which we're going to be looking at in the next chapter. So because of this emerging trend, Bootstrap integrated a lot more utility classes while still maintaining its core component-based philosophy. So let's check out the project we're going to be using Bootstrap to build. It's a simple homepage for my Fullstack developer bootcamp. We have an above the fold hero section where we have some heading text, some paragraph text, and 2 buttons. When you scroll down, there's a how it works section with 3 grid items. There's then a frequently asked questions section where an accordion is being used, where you can click on a different menu item. That menu item expands and the other ones contract. So if I click on this one here, it expands and the one above contracts. There's then just a very simple footer. So let's open up DevTools. I'm going to focus on the how it works section over here. You can see that when I reduce the width of the browser, spacing between the grid elements changes until we hit a certain breakpoint, and then the grid items each become stacked one above another with some vertical spacing between them. So through doing this project, let's take a look what we will learn. We're going to first look at installation of Bootstrap. We'll be covering layout by taking a detailed look at Bootstrap's grid system. We'll then add components to our project, like buttons and the accordion menu you saw earlier. We'll then add some various utility classes. We'll look at using Bootstrap's icons. We'll learn about adding custom CSS to extend Bootstrap. We'll be taking a look at responsive design in Bootstrap. And then finally, how we can go about adjusting the visual theme of Bootstrap, like changing the default colors Bootstrap provides. So before we get started, let's take a brief walkthrough of Bootstrap documentation. I'm currently on the homepage, getbootstrap.com. On the navigation bar up here, I'm first going to go to Docs. This is the detailed documentation of how to use Bootstrap. The first menu item here, Getting Started, just contains important information about getting started with Bootstrap. For example, in the introduction, it contains information of how to quickly get started with Bootstrap in your project, which we'll be looking at soon. This next menu heading, Customize, contains documentation of how to customize default Bootstrap styles. For example, if I go to Color, this shows all the different colors used inside Bootstrap, like this gray body color, or this primary blue color. Lower down in this documentation, there's information of how to adjust these colors, something we'll also be looking at in our project. Scrolling down to the next menu item is Layout. This contains important information about Bootstrap's grid system, which is fundamental to how elements are laid out on a page. And we'll be looking at this in a lot more detail in the course. There's also information on breakpoints, which we'll be discussing when talking about responsive design. And Layout also deals with the main page container, which we'll also be looking at soon. The next heading, Content, is about how HTML content is styled in Bootstrap. For example, if I go to Typography, you can see here the default sizing of headings in Bootstrap. The next heading is Forms, which is about how to use forms inside Bootstrap. For example, here's how a drop-down menu would appear, which require a special Bootstrap class. The next heading is all about Components, which is what Bootstrap really prides itself on, and contains all the different pieces of UI we can insert into our project. For example, Bootstrap comes with a whole range of pre-built buttons. Here's the primary button, that blue button here. Here's our secondary button, and you can see all the other button types here. Another example of a component is an accordion, which we're going to be using in our project for our frequently asked questions, where this code over here can just be copied and pasted into your project to give you this accordion menu. And just a note, there's also JavaScript in this, which is the driving force for how this accordion works, where clicking this item is an event which expands this window. And you can't do that in CSS alone. You need JavaScript. Another great example of a popular component is a navbar. If I scroll down here, you can see by pasting all this code here, I can get this fairly sophisticated navbar, which has drop-downs part of it and a form input. So Bootstrap provides a whole bunch of different components that are very helpful for building your project, and I suggest you check these out yourself. Now, of all the menu items we've looked at so far, Components is probably one of the most important. Next up, we have Helpers, which typically combine multiple styles or behaviors to solve a specific design problem. For example, color and background. This class here, TextBG Primary, gives us a blue background with white text. So there's two different styles being applied in this one rule, both color and background color. Now, in all honesty, I wouldn't worry too much about helpers right now. They're used in very specific circumstances. The next menu item's Utilities is where you'll also be hanging out a lot. Utilities just apply one property at a time through simple CSS rules. For example, if I go to Borders, if I scroll down to Radius and Sizes, you'll see we have these different classes with different rounding. Rounded 0 is just square edges, where incrementing the number increases the amount of rounding. And this is what a utility does. Instead of selecting your element, adding border radius property, and giving it a specific value, Bootstrap allows you just to add something like rounded 2, which gives a slight rounding on your corners. Now, just another small note on how Bootstrap is laid out. On the right over here, we have a navigation for this particular page. So for example, if I go to Color, this is how we can apply different border colors, like border primary and border secondary. The heading Extend is just about information for how to extend Bootstrap. And the last menu item, About, like the name suggests, is just information about Bootstrap. Now I also want to show you that something very powerful in Bootstrap is this search box here. So say, for example, I want to apply some margin. I can easily just search margin here. You can see the heading Spacing appears. If I click Margin and Padding, it will take me straight to that section of the documentation. So the search box over here is usually your first port of call for finding documentation on different components or utility classes or anything else inside Bootstrap. Let's now take a look on the navigation bar at Examples. Examples provides you with entire sections you can download. For example, if I go down to pricing under custom components, I can get the source code in Bootstrap for this entire pricing section. Or over here is a checkout. So you can imagine how long it would take to code this up. But with Bootstrap, you can just download this and put it straight into your project. And of course, you can customize this how you like. For example, you could change this color or increase the heading size. All you do is click Download Examples. This will download all the different examples on your device, and then you just need to go find which one you want. For example, this pricing page over here, all I need to do is add the pricing folder into VS Code. I could then copy all this HTML, which as you can see, contains a whole bunch of Bootstrap specific classes, as well as add the custom style sheet to the project. The next item I want to look at is icons. Bootstrap have a whole array of icons you can easily import into your project, so you don't have to go to another source to add your icons. And Bootstrap makes it really simple to add these icons with a special Bootstrap HTML tag. And we'll be doing this in our project. The final menu item I want to look at is themes. Now, themes provides you with code for an entire web page, not just a section. Now, for a lot of these, they are paid. So for example, you could use Bootstrap to build an online supermarket. If I click Live Preview, this page contains the information about the template. You can see there's a whole bunch of different home pages you can get. And there's also a range of other pages and components. For example, this quick view element over here, there's UI components for ratings, a price range, drop-downs, and there's also whole pages for other sections of the site. For example, a shopping grid which is filtered, which you can see over here. If I go Purchase, under the description, I'm given the list of all the features I would get as part of this package. And of course, I can go and add and extend the pages and components using Bootstrap. All right, so let's make a start on our project. In VS Code, I'm going to go open a new folder. On my desktop, I've previously created a folder called Bootstrap, which is currently empty. And I'm just going to open this inside VS Code. Okay, inside the Bootstrap folder, I'm going to create a new file called index.html. I'm straight away going to grab our boilerplate by hitting !Enter. Let's update the title of the HTML document to Future Fullstack. And just to start off with, I'm going to add a simple H1 with the title Bootstrap. So let's check this out in the browser. All right, you can see Bootstrap has appeared. And at the moment, we just have the default browser styles in terms of properties like font family, font size, as well as default margin and padding on the page. So step one is let's go add Bootstrap to our project. To do that, I'm going to go to the Bootstrap homepage. I'm going to go to Docs, and I'm straight away taken to the Get Started with Bootstrap page. I'm going to scroll down. Step one was create a new index.html file, which we've already done. Step two is include Bootstrap's CSS and JavaScript. There's specific instruction of where to place this. Place the link tag in the head for our CSS and the script tag for our JavaScript before the closing body tag. So I'm just going to copy this link tag, which I need to paste under the title in our head. So I'll jump back, and under the title, I'm just going to pop that link tag. And then the script tag, which is for JavaScript, I'm going to paste that just before the closing body tag. So in our markup, that would be over here. So let's check what this has done for us. I'm going to refresh the page, and you'll see the font style has completely changed. Bootstrap has now taken over the styling and has applied its text properties. Bootstrap has also done a kind of CSS reset, whereby default margin and padding have also been removed from the browser. So adding an initial H1 is a good way to see that Bootstrap is working. And just to show you what's actually being imported through this link over here, if I just copy this URL and go to it in my browser, you'll see this is the actual Bootstrap code that is being imported into our project. And it contains all the different properties and values that Bootstrap is using behind the scenes. Now on this tab over here, I have our completed project, which I'll keep referring to as we build out each section. The first thing I want to do is add our main page container. So I'm going to head over to the docs. In layouts, there's containers, and this documentation explains how containers work. Now, there are actually different kinds of containers. It's summarized in this table here. The standard container, which has the class container, shows you the width of the container at different breakpoints. Bootstrap has 6 inbuilt breakpoints. There's extra small, which is less than 576 pixels, small, greater than 576 pixels, medium, greater than 768 pixels, large, extra large, and XX large. Now, we might be used to thinking about breakpoints in terms of a specific range, as opposed to just a greater than or equal to value. And when we cover responsive design a bit later, we'll be talking more about this. But for now, this is how we need to understand the table. Our regular container class, for screen sizes less than 576 pixels, will just be 100% of the page. And for each of these other breakpoints, you can see the width of the page. Now let's take an example for how to read this. For anything greater than 992 pixels, up into 1200 pixels, our container width will be 960 pixels. So for now, just see large as a range between 992 and 1200. And as I mentioned, we're going to be talking more about why these are greater than or equal values as opposed to specific ranges. But you can see as you move down the table, you can use a class like container XXL or extra large, which for most breakpoints has the container width at 100%. Except for extra large screens greater than 1400 pixels, the container width will remain at 1320 pixels. Okay, so for our project, we're just going to use the standard container class. So I'm going to copy this back in index.html. I'm going to come and add a div, which is going to be the div for our main container. So I'll add a class and I'll add the word container. Just to show you that this is working, let's just pop in our temporary h1 inside this container. So let's now check this out. I'm going to refresh and you can see Bootstrap moves in slightly to the right. And that's because our container is being applied. Let's open up DevTools. I'm going to click on this toggle device icon. I'm going to come and reduce the width of the browser. And you can see we have a container, which is always less than the browser width, until we hit a breakpoint where the container then stretches 100%. And that's this breakpoint over here. When we're less than 576 pixels, the container will stretch to 100% of the browser width. So let's see that value come into play. Watch over here as I reduce down to 576 pixels. You'll see now at 578, let's scroll very slowly. And at 575, you'll see the container disappears, and we're now stretching 100% of the browser width. Just a small note, there is a tiny bit of padding on our container, which we can see in the box model here, of 12 pixels left and right. Okay, just going to close DevTools. Heading back to the completed page. Let's now go add all this content in our HTML. So I'm just going to first remove this placeholder h1. Let's now add in a new h1. Now just to avoid boring you, I've already copied the text, so it's sitting in my clipboard. In the description below, I have provided a Google Doc, which contains all the content, so you can also just copy and paste it. Now just a note, this icon I didn't copy, and we'll be talking about how to add that in a bit later. I'll next grab a paragraph tag, and I'll just paste in the content. And then we have these two buttons. Those two buttons are being structured in an unordered list. We then have a list item, which contains an anchor tag. The text of the first anchor tag is get started. And for now, I'm just going to put a hash as we don't have any other pages to point it to. I'm then going to copy this list item and change its text to learn more. Now this content is the hero section of our page. So I'm going to use some semantic elements to better structure this. I'm just going to cut it for now. I'm going to add a header as is good practice for your page to have a header, a main section and footer. And we'll add those other two structural elements soon. And inside the header, I'm going to add a section tag, which is specifically for our hero section. I'm then just going to paste in the content for the hero section we just wrote earlier. So this is what we have so far, our heading, paragraph, and unordered list for our anchor tags. So let's quickly discuss what Bootstrap is using for its sizing of different text elements. If I go to the documentation and scroll down to utilities and click on text, and then scroll down to this section of the page, talking about Sass variables, this contains the variables behind the scenes of the different font sizes. You can see there's this variable called font size base, which is 1 rem, and this assumes the browser default, typically 16 pixels. This font base is then being applied to different text elements. So for example, our headings over here are just a multiple of this font size base. So for example, our h1 is 2.5 times 1 rem, or 2.5 times 16 pixels, which is 40 pixels. You can see this also contains other variables for other text properties, like font weight normal being 400, or font family serif, which lists the prioritized list of different font families. Now, you might be wondering exactly what Sass is. Behind the scenes, Bootstrap is built in something called Sass. Sass is an extension of CSS and just has this notation for variables with a $sign. Now, I wouldn't worry too much about Sass. The reason Sass was ever on the scenes was because CSS lacked some important features. For example, in previous versions of CSS, you couldn't actually define variables. But with modern CSS, you can. So today, there's just less of a need for Sass. but Bootstrap behind the scenes is built in it. So that's why you'll see some scary notation with this $sign. I just wanted to show you what's happening behind the scenes so you do know where these values are coming from. Okay, let's head back to our project. The next thing I want to do is remove these bullets from our anchor tags. Back in the documentation, I'm going to head to the content section, go to typography. I'm going to scroll down, and you can see there's this section dealing with lists. You can see under unstyled that this class list unstyled is effectively removing the bullet points from the list items. So I'm just going to copy this class. Back in our project on our unordered list, I'm going to add the class and paste in list unstyled. I'll refresh, and you can see those bullets have now been removed from the list items. Let's now style these anchor tags as buttons. We're going to do that by using our first component. I'm going to scroll down to the components, and I'm going to click buttons. The way Bootstrap does this is exactly how we did it in our Quill project. There's this base btn class, which sets the structure of the button, and then we just add on a specific style that deals with color and background color. And another variation like btn success has a green background with white text. So for our primary button, I'm going to copy this class here. In our project, for the anchor tag, I'm going to add a class and paste in that class. For our secondary button, I'm going to copy this class here. I'll add the class tag and paste that in. Okay, back in our browser, I'll refresh, and you'll see straight away we now have buttons by just using a single class. And this is a great example of how easy Bootstrap makes it to use pre-built components. All right, continuing on our completed page, our hero section is all above the fold. And I'm setting 100 view height units on the hero section to achieve this layout. Okay, view height is a unit, and I'm going to scroll down to utilities over here. And view height is about sizing. So I'm going to click here. The first part, relative to the parent, deals with utilities for percentages. If I scroll down here, relative to the viewport, you can see this class here, VH100, is what we want to use. So I'm going to copy that. Inside our HTML, on the hero section, I'm going to add a class and set it to VH100. So let's check this out in the browser. Now there's not going to appear to be a change here, but if I open up DevTools and I come and select the section, you'll see this blue background extends the full height of the page, confirming that we have set 100 view heights on the hero section. Now, just a comment at this point, you'll see under sizing, we only have view height units for 100. Now, not that you'd want to do this for a hero section, but if I did want to use a value of VH75, that is 75% of the viewport, I just can't do that using Bootstrap. And this is where some of the limitations of Bootstrap comes in. While there are utilities that are provided out the box like this, usually in a project, you have to go and add your own custom CSS. So let's check out how we would do that. In our project, I'm going to come and add a new style sheet called app.css. I'll head back to index.html, and under the link tag importing Bootstrap into our project, we're going to come and add our custom style sheet. Now, it's really important that this style sheet goes after the Bootstrap one, because we initially want all our Bootstrap styles to load in, and then we're adding or overriding these with any of our custom styles. So I'll add app.css. What I could then do is define my own custom utility called VH75. And the height would just be 75 view height units. And then I could use this custom class inside my project. So at index.html, let's change this to my custom class of 75. Let's check it out in the browser. I'll refresh. I'll select the section, and you can now see that the height of the hero section is 75% of the viewport height. Okay, I'm just going to change it back. Now, we're not actually going to be using this in our project, so I'm going to remove it. But coming up soon, we are going to have to add our own custom styles to achieve our desired design. Okay, the next thing I want to tackle is getting our content centered vertically and horizontally in our page. And to do that, we're going to use Flexbox. Heading back to the Bootstrap documentation. So in addition to the menu items down the left here, we can also use this search box, which is pretty powerful. If I click search and type flex, you can see properties with Flexbox come up. So let's first click enable flex behaviors. This takes us to the utilities section and the Flexbox chapter. So in the documentation, the way we enable Flexbox is through the utility class dFlex. This is like adding display flex. Let's scroll down. We can set flex direction with flex row reverse, and for column, flex column, and flex column reverse. And note that you have dFlex still there. So it's very common in Bootstrap to use multiple utility classes to achieve what you want. So looking at where we currently are, we have all this content inside a div container, which is contained inside the hero section, which currently has 100 view height units. So what we want to do is center this div container horizontally and vertically to achieve this layout. Back to the Flexbox documentation, we're going to be using the justify content property, which aligns flex items along the row axis, and we're going to want to center it along the row axis. So we're going to be using justify content center. We also want to center our div container vertically. So to do that, we're going to be using the align items property, which aligns items along the cross axis, and we want to center it using align items center. So let's jump back into our HTML. All right, so let's come and add our Flexbox utilities to vertically and horizontally center all of this content. Inside our section, I'm going to activate Flexbox with dflex. I then want all this content to go vertically down the page. So we need to change the flex direction to column. We use the utility flex column. And then I want to horizontally and vertically center all our content on the page. Our main axis is now running from top to bottom, which means to vertically center our content, we're going to be using justify content center. Our cross axis is running from left to right. So to center our flex items horizontally, we're going to be using align items center. Okay, I'll refresh and let's check out this change. Great, so now our content is now appearing perfectly centered in our hero section. Because our text is wrapping onto two lines, both the heading and paragraph, inside the flex item, it's left aligned. So we want to go and center that. Jumping back to the documentation, if I search text center and click this first option here, you can see this is all about text alignment, where we want to use the text center class. Back in our file, on our H1, I'm going to add text center, and I'm also going to add text center on our paragraph. Let's check this out. Okay, great. Our text is nicely centered, and all our content is centered vertically and horizontally on the page. Let's now go sort out these buttons, and we're going to be again using Flexbox to get them next to each other and add some small gap. In the documentation, I'm going to search gap. I'll click this first option, and you can see here the gap property with a hyphen and a number. Now this is being applied to grid, but we can use the same property on flex items. Now, what is this gap -3? So just like we saw earlier with font size, with spacing properties, specifically gap, margin, and padding, which we're going to be adding soon, they all have these numbers added after the property. I'm going to scroll down in the documentation, and under this heading Sass maps, this is how the spacing is defined. This is back to those Sass variables we spoke about earlier, where effectively we're taking one rem, which is 16 pixels, and multiplying it by different numbers. So for example, gap 0 would be 1 rem times 0, which would be 0. Gap 1 would be 1 rem times 0.25. So that's 0.25 times 16 pixels, or 4 pixels. Gap 2 would be 0.5 times 16 pixels, which would be 8 pixels. Gap 3 is just 1 rem, or 16 pixels. Gap 4 is 1 rem times 1.5. So that's 16 pixels times 1.5, which would be 24 pixels. And gap 5 is 1 rem times 3, which is 3 times 16 pixels, which is 48 pixels. Now, this is again a fairly big limitation with utilities in Bootstrap. This is where they stop. If you want to add larger values of margin, using this kind of notation, you have to extend it yourself with your own custom CSS. Now for us, we only need a small gap value, so we can use the values provided. But later on, when it comes to things like padding and margin, like between these different sections, we are going to need to define our own custom margin utilities. So for now, I'm just going to be using gap 3 on our buttons. So jumping back to our HTML file, we need this unordered list to become a flex container where the list items are the flex items. So let's activate Flexbox by adding dflex. We want our buttons to remain in a row, so we don't need to add flex column. We don't need to do any alignment using justify content or align items. We just need to add a small gap value between our buttons. I'll use the value gap 3 for now, and we'll see how this looks. Jumping back into our page, I'll refresh, and this looks pretty good. Our buttons are now in a row with a small gap value between them. If I open up DevTools, let's go see this gap value. You can see the gap is set as 1 rem. And that's being taken from what we looked at before, where the 3 value represents 1 rem. All right, our hero section is nearly complete. The last thing we need to do is just add this icon at the end of the heading. Now, Bootstrap actually provides a whole library of icons that are really easy to import into your project. If I go to icons over here, it takes me to a subdomain of Bootstrap, icons.getbootstrap.com. Now I'm going to scroll down to where it says install over here, and it's going to take me to the bottom of the page. Under CDN, I now need to add in our project a specific style sheet to access these icons. I'm just going to copy this link over here. Back in our HTML file, I'm going to scroll up, and underneath the link tag importing Bootstrap, I'm going to paste in the link tag to import the icons. Now, having done that, it's really easy to now add icons to our project. I'm using a laptop icon, so I'm going to search laptop. This is the icon I'm using here, so I'll click it. And then all I do is copy this special syntax, which has an I tag. I'll copy it. Back inside our HTML, inside our heading 1 tag, I'm just going to paste this icon. Now, it's really important that this icon goes inside the heading 1, because this icon is being treated as kind of a text element. So styles that are applied on the H1, like the font size, will also now be applied on the icon. So I'll save this, and let's check it out in the browser. I'll refresh, and our icon now appears on the heading. Now we just need to add a small space between the word bootcamp and the icon. So back inside the HTML, I'm just going to pop a space there. I'll save and refresh. All right, that's our hero section complete. So up to now, you've had a good taste with how to use components like buttons and how to use different utility classes like activating Flexbox and different text properties like Text Center. For the next section, we're going to come and use Bootstrap's grid layout, which is fundamental to how Bootstrap is structured. So back inside our HTML file, our header is complete. So let's now go and add our next semantic element for the main content of the page using the main tag. This main tag will contain both the features section with how it works, as well as the frequently asked questions over here. So I'm going to add 2 sets of section tags. The first section tags will be for the how it works section, and the second section tags will be for the frequently asked questions that we'll get to soon. So the first thing I want to do is add this how it works text, and I want it centered on the page. So inside the section, I'm going to use an H2. The text is how it works, and then I'm going to come and add a class and use the utility value we used earlier, text center, to horizontally center the text on the page. So I'll refresh, and we can now see down here below the fold, we have how it works, centered on the page. Looking back at the completed project, you can see that between how it works and this grid section, there is some margin between them. So I'm going to come and add some margin bottom onto the how it works. Back in Bootstrap, I'm going to search margin, and you can see margin and padding come up here. And the documentation here explains how we can use margin and padding properties. The way it works is you first select your property type, whether it's margin or padding, M for margin, P for padding. You then come and append on a specific letter, depending on what you're trying to achieve. For example, MB would be margin bottom, whereas something like MX sets both margin left and right. So for us, we're going to be using MB for margin bottom, and then you come and use one of the numerical values we looked at earlier, ranging from 0 to 5. So let's add this to our project. In our class over here, I'm going to write MB for margin bottom, and I'm going to use the maximum value available, which is 5. Back in our project, I'm going to refresh, and you'll see some margin bottom has now been added to the H2. Let's confirm this in DevTools. If I select the H2, you can see the orange box appearing below to signify that margin has been added below. So the next thing we're going to go do is define this grid section, where we have 3 grid items. Now, as I've mentioned a few times now, Bootstrap's grid feature is fundamental to how the framework is structured. On the navigation bar on the left here, if I go to Layout Grid, this documentation explains how the grid system works. So you can see over here, we use our powerful mobile-first Flexbox grid to build layouts of all shapes and sizes thanks to a 12-column system. So what is this 12-column system? So the way it works is you add the class row on what you want your grid container to be. This then activates Bootstrap's special grid system. And the way it works is that inside this grid container, you have 12 equal columns. You then define a grid item with this class col. So in this case, what's happening, we have our grid container with row, which is all this content here. And then there's 3 columns being defined by these 3 divs. Now the grid has 12 columns. So if you were to just define 3 columns, effectively what's happening is that each column would be taking up 4 of those columns from the 12 columns. Now that can be a bit tricky, so let's check out what I mean in our project. I'm going to come and add a div, and I'm going to give it the class of row. This now creates a grid container. This grid container has 12 slots on it. I'm going to come and add a div here. I'm going to give it the class col to signify that this is a grid item. And I'm just going to give it a bunch of lorem text. Now let me copy this to give a total of 3. Now to explain this, let's check it out in the browser. So what I've effectively done is I've defined a grid. This grid has 12 columns as part of it. But because I've only set 3 columns, mathematically what's happening is that each of these divs is going to use 4 of those columns from Bootstrap's grid system. So this is using 4 columns, this is using 4 columns, and this is using 4 columns, giving us a total of 12. Now let me copy these and paste them. So in our markup, we have 6 columns, and from Bootstrap's perspective, its 12 columns now need to be divided into 6, which means that to get to 12, each of these grid items is using 2 of Bootstrap's columns. Let's check this out in the browser. I'll refresh, and you can see we now have 6 columns, each of which are using 2 columns of the 12 inside the grid system. And of course, I could double this one more time. I'll copy it and paste it here. Now we have 12 columns, which would each be using 1 column from Bootstrap's grid system. So I'll refresh. So what we can now see is Bootstrap's 12-column system, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. I'm going to open up DevTools. I'm going to select where we're defining this row, and you can see these purple dashes outline the 12-column system, where the number of grid items in here will distribute those 12 columns differently, where we saw, for example, only having 3 of these distributed 4 units of the Bootstrap grid column to the grid item. Now I just want to clear these. Let's go back and add only 3 columns. So we'll give it the class of col. I'll add the lorem text, and I'll copy this 2 times. So now we're back to having only 3 columns defined, but Bootstrap is going to distribute 4 slots of its grid system to each of these grid items. So what you're going to see is that these 4 slots will be given to grid item 1, these 4 slots will be given to grid item 2, and these 4 slots will be given to grid item 3. I'll refresh and watch as that happens. Now, just having col like this for each of these divs is just going to take the 12 units and divide it equally. And you can explicitly set this by doing something like col-4. I'll add that on to the other divs. And what this is saying is that for each grid item, give it 4 units from Bootstrap's 12-unit system. Back on our page, I'll refresh and you'll see there is no change. But what these numbers allow us to do is to use the 12 units however we like. So for example, I could give our first column 6 units, our second column I could give 4 units, and our third column I could give 2 units. 6 plus 4 plus 2 equals 12. Let's check this out in the browser, and you'll see now how those 12 units have been distributed between our 3 different columns. Now, the other thing you can do is not even use all the columns. So for example, I could give each of our columns only 2 units. So 2 plus 2 plus 2 is 6. So we're only using half of the 12 available slots. So if I check this out in the browser, you'll see that each grid item only has 2 slots used. And because there's 12 available, they only fill up half the space. If I open up DevTools, and if I click over here, you can see the grid is only taking up half the page, and that's because each column has only been distributed 2 of the slots, and there's 3 of them, so 6 slots have been distributed, and the other 6 on the right are currently empty. Now just a quick note, on this div class, you can see the word flex is here, not grid. And this is because behind the scenes, Flexbox is actually being used to establish Bootstrap's grid. That was mentioned in the documentation, where it says, use our powerful mobile-first Flexbox grid to build layouts. And we're soon actually going to be using Flexbox properties for alignment on the grid in Bootstrap. So looking at our project, what I effectively want to do is have 3 grid items, and I only want them to occupy 3 of Bootstrap's columns, because I specifically want to have space to align them like this. So jumping back into our project, I'm going to come and change col2 to col3 for each of our different grid items. So we're using 3 plus 3 plus 3, which is 9 slots from Bootstrap's 12-slot system, which means there'll be additional space inside our grid to align these items. Jumping back in our project, if I refresh, we now have our grid items with some extra space on the right here. So let's come and distribute that space. Now, as I just mentioned, grid is actually using Flexbox behind the scenes. So we're going to come and use flex alignment properties under the utilities to distribute the space. For this flex container, our main axis is in row running from left to right. To align these items along the row axis, we need to use the Justify Content property. So I'm going to come over here and click Justify Content. Looking at the different options here, I want this one here, which is Justify Content Between. And this is the same thing as applying Justify Content with the space between value. Because row is using Flexbox behind the scenes, we don't need to come and apply display flex. We can just add the Justify Content Between utility. If I save and refresh, our columns are now distributed with space between them. All right, so let's move on and swap out this placeholder lorem ipsum text for actual cards containing an image and text. Now, this is actually a component inside Bootstrap. If I head to Bootstrap and go to the Components menu, there's a component called a card. Bootstrap contains a whole bunch of different cards, like one with images, text, and buttons, and more specific cards like this one here with images, text, groups of text, and some anchor tags. For our project, we're just going to be using a simple card, which contains an image and text. So I'm going to copy all of this code here. Inside our project, I'm going to remove this lorem ipsum text, and I'm going to paste the card inside this div, which is setting the column. Okay, so here's our card inside our column. Now, the first thing I want to do is just get rid of this style tag here, which is setting a fixed width of 18 rems. I want the width of our card to just extend the full width of our column. So let's check this out so far in the browser. In our project, I'll refresh, and you can see the card is starting to appear. We have this gray border, a broken image, and some text. Now for the images in this project, I've just gone to one of my favorite open source image library, Undraw. This first image had to do with a video. So under Browse Now, I went to Search and looked for video. And you can see that image over here called YouTube tutorial. You'll see the images contain this blue color, which is the same as our primary color here. Now to find the hex code of that color, I'll type in the search box primary. I'll click this link here. This page deals with documentation around the different colors on our page. I'm going to scroll down. You'll see over here all colors, where this hex code is our primary blue color. So I'm going to copy this hex code, and then inside Undraw, I click this color swatch icon, and I'll paste in the hex code here. And this then updates all the images to contain that blue color. Now to avoid boring you, I've already downloaded these illustrations, and you can also grab them in the description below. So then inside our project, I'm going to come and add a new folder called Images, and I'm going to drag the images from my Downloads folder into this Images folder. So now back in our index file, for the source attribute, I'm going to go images/icon1. For the alternate text, I'm just going to write video. So let's check this out in the browser. I'll refresh, and you'll see our icon nicely appears inside this card. Now in our completed project, we have a heading and some paragraph text. So let's go reformat that. Inside this div, I'm just going to come and add an H3, which is the title of the card, with the text high quality. For the paragraph, I'm then just going to update this placeholder text to the text from the final page. Okay, let's refresh and check this out. Okay, this is looking great. We have our image, our heading text, and paragraph text all nicely contained in this card. So now what I'm going to do is copy this entire structure with the col and card. I'm going to remove these other two divs and just paste this twice. So we'll now have the structure for our 3 cards. I'll refresh, and you can see it all appears here. So let's now go update the content for the other 2 cards. So this is our second card. We're going to update the image to icon 2. For the alt text, I'm just going to put coding. The H3 text is detailed, and I have sitting on my clipboard the paragraph text for this section, which I'll just paste in. For the third card, the heading is structured, and again, I'm just going to remove this text and paste in what I have in my clipboard. And of course, I also need to update icon 3. You can see how our images and text have updated. Now, one problem you'll see is that because these images are different heights, it's causing our cards to just look a bit funny. If you look at the final project, you'll see that inside our cards, the heading text is all nicely aligned horizontally. So to achieve this, we're going to go and add a minimum height onto our images. Now inside Bootstrap, if I search min height, you'll actually come to learn that there is no Bootstrap utility for minimum height. So we are going to now have to set a custom property. So inside our app.css file, I'm going to go define a new class, min height feature image. I'm going to set this height to 300 pixels. So I'll just copy this text in our index file. For each of our images, Inside the class, I'm going to go and add that new property I just created. I'll paste it there, there, and there. So let's refresh. And you'll now see, because our images have a minimum height of 300 pixels, the position of our headings is horizontally consistent. All right, so this is our How It Works section complete. The next section we're going to tackle is the frequently asked questions. Now, the first thing I want to go do is add some margin bottom onto the How It Works section to create some vertical space. Now, back in the documentation with margin, as I mentioned earlier, the largest value we can go up to is this 5, which is 16 pixels times 3, which is 48 pixels. Now, that is not a very large value that you often need for creating white space in your design. So once again, we're going to have to go extend Bootstrap to give us larger margin values. So back in app.css, let's go add a whole bunch of new margin values. The largest one we have access to in Bootstrap is the value 5, which is 48 pixels. And that's 3 times by 16 pixels. So let's go add a new value, MB6, which we're going to define margin bottom, and I'm going to make it 64 pixels, which is 4 times 16 pixels. Let's go add MB7. We'll give it margin bottom of 80 pixels, which is 5 times 16 pixels. Now I'm going to continually increment our MB value by 1 and increase each margin bottom value by 16 pixels. So to avoid boring you, I'm just going to go add those all now. Okay, I've added all the values now up until MB12, which has a margin bottom value of 160 pixels. And I've also just put a small inline comment next to each value so you know where it's coming from. So I'm going to grab this MB12 value, and back in our HTML file, on our How It Works section, I'm going to come and add a class and add MB12. Back in our project, I'll refresh, and we now have 160 pixels of margin below this section. All right, so for the frequently asked questions section, let's go add that heading text. In our HTML file, we're now in this section over here. I'm just going to copy this H2 from the previous section, as I still want the text to be centered, and I also want it to have some small margin bottom on it. I'm just going to change the text to FAQ. So let's check this out. You can see our FAQ has appeared with some small margin below it. So next up, we're going to use Bootstrap Grid to define a container and center it. Okay, so let's go set up our grid structure. I'm going to add a div. I'm going to add the class row, which activates Bootstrap's grid layout. And then I'm just going to add a single div, which I'm just going to put some lorem text in for now. And I'm going to give this the class of col. And I want it to use 8 units of Bootstrap's 12 units from its grid system. So let's check this out in the browser. I'll refresh, and you can see this text is using 8 units of the 12 available units from Bootstrap's grid. If we inspect this in DevTools, and I select this row, you can see the purple dash space on the right are the additional 4 columns which are unused. Now in our final design, we're using this UI element called an accordion, where by clicking different menu items, they expand where the previous one contracts. And JavaScript is actually being applied to achieve this. You need JavaScript because the browser is responding to user actions. By me clicking something, things on the page are changing, and JavaScript is needed for that. Back in the Bootstrap documentation, under Components, there's an accordion, where you can see a sample over here. I'm going to copy all of this markup. I'm going to pop back to our file. I'm going to remove this lorem ipsum text, but keep our div col structure, and I'm going to paste in the accordion. So now our accordion is inside our column. Let's check this out in the browser. I'll refresh, and you can see the accordion now appears here. Now let's go and center this accordion. Like we saw earlier, behind the scenes, Bootstrap Grid is actually using Flexbox. Our row, which acts as the flex container, contains a single flex item, this div over here. The main axis, by default, is in row, going from left to right, which means that to horizontally center this, we need to use a justify content value. So back in Bootstrap, let's go search justify content, and we want our single div to be centered. So we're going to be using justify content center. So inside our row here, which acts as our flex container, I'm just going to come and add justify content center. I'll refresh, and you'll see the accordion centers on the page. Now in our final design, there's also some margin between this entire section and the footer. So let's go add that in our project. I'm going to use this same large value over here, MB12, we used on our How It Works section. So I'm just going to copy that. For our FAQ section, I'm going to add a class and add MB12. I'll refresh, and you'll see now there's a lot more white space between the FAQ section and where eventually our footer will appear. All right, let's go update the content of this accordion. The accordion main text appears here. For the first one, it is who is this bootcamp for? The content is then inside this div tag. I'm just going to remove all the content here. And from my clipboard, I'm going to paste in the correct text. Let's check that out. I'll refresh, and you'll now see we have the correct content. Now, just to avoid boring you, I'm going to go update accordion item 2 and its respective text, and accordion item 3 and its respective text. Okay, I've gone ahead and updated that content. Let's check it out on the page. I'll refresh, and you'll see this all looks really great. Now, in our final design, we had an additional accordion menu item. So let's go see how we can add that. Each accordion item is contained inside this div here. So I'm going to simply copy it and paste it over here. Now, for this to work, we do need to go update a value in a few places. You can see there's this data BS target #collapse3. Anytime we have the word 3, we need to now change that to 4. So I'll copy 4, I'll update it here, and I'll update it here. I'll then come and update the text, which is, do I need any prior knowledge to join? And then in my clipboard, I have the answer. Okay, I'll save that. Let's refresh. And you can see now we have that fourth accordion item, which works perfectly, that when I click it, it also closes the other ones. Okay, great. That's our FAQ section done. The final section of the page is this simple footer down the bottom. Now, one thing I want you to notice is that the background color is actually extending the full width of the page. So to do that, I actually want our footer to appear outside this main div container. So I'm going to come below here. I'm going to add our footer. And inside my clipboard, I have the content, which is the copyright symbol, 2025 Future Fullstack. For the footer, let's give it a class. I want to use the primary blue background color. So inside Bootstrap, I'm going to search background color. We can simply apply the class BG primary. So I'll copy that. I'll add BG primary. We want our text to be white. So I'm just going to search the color property. And you can see down here, we just have text white. So I'll copy that class there. I'll add it in there. I then want the text to be centered. So I'm going to use the utility class text center. And the final thing I want to do is have some vertical padding on this text. Back in Bootstrap, we'll search padding. Padding uses the same notation as margin in terms of combining different letters. For padding, I'm going to use P, and I actually want to apply, in this case, padding top and bottom. So I'm going to use this Y value here. And I just want to apply a small value of padding like 2. So I'm just going to write PY-2. I'll refresh, and you can see we now have a nice simple footer at the bottom of the page. Okay, I just wanted to make a small note about the footer and our container. Now, this markup we have isn't the best practice. When you know elements are going to be extending beyond the container, like this footer, what you instead want to do is actually place the container on each section. So what I'm going to do is I'm going to totally remove this div and move the closing div tag here. And then I'm going to add the container onto each section. So for our hero section, we'll come and add the container class there. For our how it works section, I'm going to add the container class there. For the frequently asked questions section, I'm going to add the container class there. And then I'm just going to re-indent our HTML. So now this markup is just a bit cleaner. We have our header, main body tag, and footer all in line. And if I go back to the page and refresh, you'll see there is no change. But now the container, instead of being applied globally, has been applied to each section. All right, so our page is complete and looks great on desktop. However, if I inspect and click on the toggle device toolbar, you'll see that we're now going to run into problems on smaller devices, where, for example, this grid is just breaking now. You'll also notice that when I reduce the width of the browser, text properties and spacing are not changing. Now, usually in a CSS file, you'd be controlling that with changing the root HTML's font size, and because all these values would be in rems, they would adjust accordingly. So let's go see how we can use Bootstrap's responsive classes to help fix this grid layout for smaller screens, as well as change some different property sizes for different screen sizes. So let's go take a look now at responsive design documentation inside Bootstrap. On our navigation bar here, I'm going to go to Layout and Breakpoints. Under Core Concepts, you'll see the sentence about mobile-first responsive design is the goal. The way breakpoints and responsive design works in Bootstrap is that you first need to think about your design on mobile and then work your way up to desktop. Now, the way responsive design works in Bootstrap is that we have these different values for different breakpoints. And the way we need to think about it is that we start at mobile and apply the default value we want, and then that applies until we then change it with another one of these values. So for example, thinking about extra small screen sizes first, less than 576 pixels, we might want our H1 to have a font size of 40 pixels. That font size would then apply for the tier above it, that is SM, and the tier above it, MD. But then if we set a font size for LG, like 70 pixels, it means that anything above 992 pixels would now take on that new font size. So basically the way it works, you start with what you want your design looking like for extra small screens, that is less than 576 pixels. And then for when you want it to change, you take the breakpoint, like MD, and the property, like font size, and change its value. So let's go do this for our grid. So at the moment, our grids are being defined by col3. We have one here, and one here. Now we need to think about our grid starting at mobile and working our way up to desktop. At the moment, if I go to a small screen size, we still have our grid occupying 3 units of the 12 available units. What we actually want is one grid item to take up all 12 units, so that our grids stack on top of each other. So what I'm going to do is actually update col3 to col12, because I need to take a mobile-first approach. I'll copy that and paste it for the other grid items. I'll refresh, and you'll now see that our grid items are appearing on top of each other. And that's because they're now occupying all 12 columns of Bootstrap's 12-column layout. So this looks great for mobile. But this rule is being applied to every single screen size. So as I expand the window, you'll see that we still have this grid item occupying 12 units. But at some point, we actually want to break this so that we do get our grid, with our 3 grid items in one row. So if I go back to breakpoints, what I want to happen is that when I hit the medium screen size, that is greater than 768 pixels, I want our grid to now occupy 4 units of the 12. And then when it hits large, that is greater than 992, I want it to occupy 3 units from the 12. And this will get us back to the original layout we had. So to implement this, what we do is I come here, I add col, then the breakpoint, MD, and then the value 4. I'll copy this, paste it there, and paste it here. So what this is effectively saying is that using a mobile-first approach on small screens, we're going to be using all 12 units of the grid. And then when we hit the MD breakpoint, which is 768 pixels, our grid is going to then use 4 units of the 12. And this will continue up for all screen sizes. That's why it's greater than 768 pixels. So let's go back to mobile. I'll refresh. I'll expand the browser width. And as soon as I hit 768 pixels, you'll see we're now back to a grid layout, where each grid item is occupying 4 units of the 12. Now this works well for medium screen sizes, but for larger screen sizes, I want to go back to having space between our items. So now for large screen sizes, that is above 992 pixels, I'm going to go back to what we originally had. So I'm going to come here, I'm going to add col-LG for large, and now the value 3. So I'll copy that and add it onto each grid item. Okay, I'll refresh, and now you'll see we're back to the original layout we had. So let's go back to the beginning. We take a mobile-first approach and apply the value we want. In this case, col12, because we want our grid items to expand the full width of the grid container. We then hit our medium breakpoint, where our grid items occupy 4 of the 12 units. And then we hit our large breakpoint, where the grid items occupy 3 of the 12. And because there's no further breakpoint defined after this, this design just remains for no matter how large the screen is. So let's check this out again. Our grid is occupying 12 units until we hit 768 pixels, where then each grid item occupies 4 units. We then hit 992 pixels, where the grid items then occupy 3 units, and the space between value is now coming into play. So you can see how appending these different breakpoints onto properties like grid column make responsive design really simple. Now, something else I want to take care of using these responsive properties is that on smaller screen sizes, I want to add some margin top and bottom on this grid item so that we have some space between them. Now, I do want to note that this margin I'm going to be adding is not needed at all as soon as we hit the MD breakpoint. I only need it for smaller screen sizes. So the way we do this is that I'm going to come to our middle grid item here, and on the card, I'm going to set margin Y, that is above and below, with the value of 5. So I'll refresh, and you can see we now have space between our grid items vertically. But of course, when I go for larger screen sizes, that margin is still being applied. So we need to turn it off. At the same time, our grid changes from this layout to this layout. We know that's happening at the MD breakpoint. So all we do is start with MY5, and then we say MY for medium screen size, make it 0. So I'll refresh, and you'll see that margin Y now disappears, but it is still being applied for smaller screen sizes. So that's a good example of how you can also use breakpoints to apply different spacing values like margin. All right, so now that we've fixed this issue, I now want to quickly talk about responsive heading text with Bootstrap. I'm going to click on this H1, and you'll see the font size is 2.5 rem. And if you remember earlier, we saw this documentation where H1 font size is the font size base times 2.5, where the font size base is 1 rem. So H1 font size is 2.5 rem, which we can see over here. But watch what happens when I hit a certain breakpoint. The font size changes to this calc 1.375 rem plus 1.5 VW. And you'll see that when I go to computed, the font size is at 40 pixels, and then as I reduce the width of the browser, it continues to scale down, which is being driven from this 1.5 VW unit, which is based on the viewport width. So it's changing as I scale down. So behind the scenes, Bootstrap is actually making our headings responsive. Now, with regard to paragraph text, you'll see there is no actual style being applied here, like we saw with heading. And that's because it's just the base font size of 16 pixels. If I go to computed, you can see the font size is computed at 16 pixels. And no matter what the width, it remains at 16 pixels. Now, I guess this is sensible because you probably don't want your paragraph font size to go much smaller than this, even on smaller screen sizes. All right, so the last thing I want to talk about is overriding the color themes inside Bootstrap. Back in the documentation, on this left navigation, I'm going to go up to Customize and click Color. Now, on the right over here are all the different variables that are used to set the colors inside Bootstrap. So what I want to go do is grab this BS body color, which is setting the base body color for all our text, and I want to go change it. In our custom style sheet app.css, I'm going to come to the top. I'm going to select the root pseudo class. I'm going to paste in the variable, and I'm just going to go change the color. Just to see it's working, let's go change it to something crazy like orange. Let's refresh the browser. So you can now see our heading and paragraph text have been overridden with this orange color. Now this obviously looks awful, so let's go change it to some kind of gray value. Just to find one, I'm going to type gray. The swatch will appear. I'll change it to hex code, and let's go pick a dark gray value like this one. Okay, let's refresh. And we've now manually overridden the Bootstrap body color. Now, when it comes to changing colors like primary colors used in our button, this method won't work. So for example, to change the primary color in our Bootstrap documentation, we have BS primary. So if I copy this, go back to our custom style sheet, paste that in, and let's change the color to something like purple. Just to get a more appropriate hex code, I'll click up here, and let's select that color there. Okay, back on our page, let me refresh. And you'll see something like the primary button has not changed. Now, the reason this didn't work is that something like a button is made up of a lot of different properties. So we need to go explicitly define this new primary color on the button. The body color is just changing the color of a single element, like some text, whereas our primary color is used on a lot of different components and elements throughout the application. For example, back in the documentation, we know that our buttons can be primary, secondary, success, etc. But just to show you another example, if I go to alerts, which are little alert pop-ups, that you can see they're also using the same primary, secondary, etc. themes. So this single variable is used in a lot of components, and Bootstrap just doesn't want to give you the power to completely override them all. And it also sees this being applied to a component which is made up of lots of parts, very different to just color on some text. So to make this work, we need to explicitly go add this to the primary button. To do that, we'll select btn primary. We'll add a background color, grab our variable function, and paste in the variable bsprimary. I'll save and let's go check this out. I'll refresh, and you'll see our button is now that purple color. You can see the button also has some border around it, so we'd need to update that as well. The border of a button is just 1 pixel, it's solid, and then we're just going to copy and paste the same color. Okay, I'll save that and refresh. And you'll see we've now overridden the color of our primary button, but we had to do it by explicitly declaring it on the primary button. So there you have it. You've just gained a solid foundation in being able to use Bootstrap to build fully responsive pages. We've looked at using utility classes, we've looked at components, we saw how to use Bootstrap's icons, we've added custom CSS to do things like set new values of margins, we've learned about the Bootstrap breakpoints to ensure our design is fully responsive, and we've also just looked at adjusting the visual theme. So walking away from this, you should now have a very solid base with what is Bootstrap and how to use Bootstrap. And as I've recommended, I highly recommend, instead of playing around with Bootstrap right now, rather go ahead and build a handful of pages just using HTML and CSS. Next up, we'll look at the fastest growing utility-first CSS framework that allows for complete flexibility and customization by using Tailwind. We'll be discussing what is Tailwind, why is Tailwind helpful, we'll be doing a Tailwind walkthrough, and we'll be working on the Tailwind homepage project. So what is Tailwind? Tailwind is a utility-first CSS framework for creating custom responsive designs with predefined low-level styles. So let's look at some keywords here. Utility first is the core philosophy of Tailwind, where utilities form the foundation of the framework. This is different to Bootstrap we looked at earlier, which is where components form the foundation of the framework. Responsive refers to the framework being inbuilt to handle all devices. The word predefined means that the special classes we use are systemized, and we're going to see how this works soon. Finally, the word low level means that our utility classes are just single properties, so things like color, font size, or margin. Tailwind CSS is becoming very popular, and for good reason. It's an incredibly powerful and versatile framework. On the Tailwind showcase page, you can see some major applications using Tailwind. OpenAI and ChatGPT use Tailwind, and Shopify, which is one of the world's biggest e-commerce platform, is also using Tailwind. And you can see down here are some smaller applications that are also using Tailwind as their CSS framework of choice. So Tailwind is used by very large companies and smaller companies. Alright, so Tailwind is available at tailwindcss.com. I'm going to head over to Docs, and before we look at these in detail, on this left navigation bar, I want to scroll down to Core Concepts and click on this title, Utility First Fundamentals, to give you an idea of how Tailwind works and how powerful it is. So let's read this together. Traditionally, whenever you want to style something on the web, you write CSS. In this setup here, the documentation is showing us using a traditional approach where custom designs require custom CSS. So this chat component here, we would have our HTML markup, we would set a whole bunch of different classes, and then in our CSS document, we would style all of these different classes to achieve this design. Now let's compare this to how we write this in Tailwind. Tailwind uses utility classes to build custom designs without writing CSS. So this same component is just coded up over here. This is it. The CSS is contained in these different utilities. So for example, BG white refers to the background being white. Over here, text XL is extra large text. So this is a bit interesting. We're kind of writing our CSS inside our HTML. And this might seem counterintuitive to this being useful, because the general rule of thumb is you want your CSS in a separate style sheet. But by using a framework like Tailwind, where styles are systemized, this drastically simplifies our code. You can see we've built the exact same component as above, but the amount of code has drastically reduced. So why is Tailwind helpful? Tailwind overcomes limitations of traditional CSS frameworks and custom CSS by providing more flexibility and customization. Looking at an example component written in CSS, I want to look at 4 reasons why Tailwind is helpful. The first is reusability and consistency. Reusable utilities and design settings ensure a consistent and easy to manage design. So for example, you can see this paragraph has a utility class TextSlate 500. You can see the button has the color TextPurple 600. These are inbuilt styles inside Tailwind, where these classes are reusable throughout the page and provide consistency. The second reason Tailwind is helpful is it helps reducing context switching. By this I mean that styling directly in HTML minimizes the need to switch between HTML and CSS files. So for example, this paragraph over here has large black text which is semi-bold. We don't need to flip between a CSS and HTML file, we can see it all in one place. The third reason is that we're avoiding pre-designed styles. We use low-level utilities allowing for custom designs without needing to override pre-designed components. In the previous chapter, when looking at Bootstrap, it was just a bit frustrating. When using some different components, we often had to customize it. So by using low-level utilities, that is, single property utilities, we never have to go and add our own custom CSS. The Tailwind framework gives us everything in the toolbox we need. For example, this button class has a lot of different styles applied to it. There's some padding, rounding corners, and much more. The final reason is that Tailwind helps simplifying responsive design. Tailwind has built-in responsive and mobile-first utilities, making it easy to create layouts that adapt seamlessly across different devices. To show you an example of this utility class sm::text_left, where sm: is a special Tailwind responsive utility that's easily applied and avoids us writing more complex media queries. And we'll learn more about this in the project we build. So in a nutshell, Tailwind is just great. I'm a big fan of it because I love their approach, and they're also really slick with how they've designed their documentation and how they've systemized their components. Now, once again, I encourage you not to touch Tailwind until you've played around with regular CSS and built a few projects on your own, because Tailwind especially needs a very strong foundation in CSS. Because at the end of the day, you're still styling using CSS, you're just using these special utility classes, which at the end of the day is just CSS. Alright, so let's take a look at the homepage project we're going to build. I've built this simple homepage for my Fullstack Web Development Bootcamp Future Fullstack. Our hero section has group text on the left and buttons, and on the right is a picture of me. Scrolling down, we have a How It Works section, which contains a grid of icons and text. We then have a CTA section inside this blue box, and then a very simple footer at the bottom. So let's take a look at what we will learn through this project. We're going to be covering Tailwind installation. We're going to be using a whole variety of utility classes. We're going to be using some components so we can see how those work in Tailwind. And then finally, we're going to make our design fully responsive. So before we get started, let's do a quick walkthrough of Tailwind. Tailwind is available at tailwindcss.com. I'm going to head straight to Docs. Straight away, we're taken to Get Started with Tailwind, which provides information of different ways for installing it, which we're going to do soon. If I scroll down on the left, we have the core concepts, where we looked at utility-first fundamentals earlier. And then we have a long list of all the different utilities. You can see compared to Bootstrap, there are just way more. And that's because Tailwind is a utility-first framework. There's also a very powerful search box. So for example, if I want to look at margin properties, margin straight away comes up here, and I'm taken to the documentation about margin. And you can see compared to Bootstrap, there are just way more margin utilities. And that's because the aim of Tailwind is to give you everything you need so that you don't need to write custom CSS. And just a side comment, I just think these docs are just so well designed. For example, if I go to background color, which we'll be using in our project, you can see Tailwind out the box has a whole variety of beautiful colors to use. In our CSS bootcamp, we've been using open color. And I did mention that Tailwind color is another great resource for writing custom CSS. But you can see Tailwind just provides us, straight out the box, some beautiful colors we can use straight away. Anyway, I'm just a big fan of Tailwind's approach to design. So we've briefly looked at docs, let's now go look at components. So while Tailwind is a utility-first framework, it does also provide you with some components. You'll notice that this is actually on a different URL, tailwindui.com. If I go to components and scroll down, the components are organized into different categories. For example, we have a whole bunch of different page sections, like hero sections, CTA sections. And if I scroll down, there's different elements like banners. Now, as an example, let's go to pricing sections. I'm going to zoom out a bit. And you can see Tailwind provides us some different examples of pricing pages. And some of them are pretty comprehensive. Like this one has our 3 different pricing tiers with a table of the different features in each pricing tier. Anyways, there's a whole bunch to choose from here. And what I hope you're noticing is that these designs are absolutely fantastic. Now they're really easy to add to our project. We just go code and copy this to our clipboard and add it in. And we're going to be doing this inside our project. where we'll be copying in a component and customizing the Tailwind CSS so it better matches our design. Now, just a note, this is where Tailwind does make its money. Some of the components you do need to pay for. So the one we just looked at here, I can just straight away grab the code, whereas for other ones, it has this button, Get the Code, which takes me to a pricing page. Now, in addition to different page components, under templates, you can buy full pages. If I go to Browse Templates, I like this one here, Salient. You can see it costs $99, but look what you get. Again, this one does have a cost, but let's check it out. If I go Live Preview, you're able to get this full design written in Tailwind, which you can just copy into your project. And of course, you can further customize it using Tailwind's utility classes. All right, so let's get started on our project. The first thing we need to do is install Tailwind. I'm on the Tailwind CSS homepage. I'm going to go to Docs, and I'm straight away taken to the documentation on installation. Now, in a professional project, you're going to want to install Tailwind as a dependency in your project, using npm node package manager. Now, as this is a beginner CSS course, at this point in your journey, you're not going to have a clue what this is. It's something we're going to be covering in detail in the node topic in the Fullstack bootcamp. But just in a nutshell, what this is doing is actually installing the source files of Tailwind into our project. And it's the recommended thing to do. Now, Tailwind does provide a play CDN. This essentially lets us import a simple script tag, just like we did in Bootstrap, and allows us to use Tailwind straight away. You can see here, the documentation says, the play CDN is designed for development purposes only and is not the best choice for production. Development purposes just means for the purpose of building this locally on our device, whereas production is a live web application. So in a real project that's live on the internet, the play CDN is not what you want to be using. You do want to install it properly with Node Package Manager. But besides the two different methods, the use of Tailwind we're going to be using in this project is the exact same as if you were using the npm install method here. So the only difference between these two is just how you install it. Once it's installed, it's the same Tailwind you're going to be working with. Okay, so let's go start a new project and get Tailwind installed into our project using the play CDN. So I'm inside VS Code. I've created an empty folder on my desktop called Future Fullstack, which I'm just going to drag into the project now. I'm going to remove this welcome page. I'm just going to go add a new file and call it index.html. Like always, I'm just going to go grab the boilerplate. Let's update the title to Future Fullstack. And let's go install the play CDN. All we do is copy this line of code and add it inside our head tag. I'm going to place it just above the title. All right, so I'll save. And just to get started, I'm going to add an H1 with the title Hello World. Let's go check this out in the browser. All right, we can see Hello World there. I'm going to zoom in quite a bit. And you'll see straight away that this Hello World is looking different to what it would look like with the default browser styling. Just to show you this, I'm going to comment out this script tag. I'll refresh. And here we are, back to the default browser styling. Okay, let's add this back in. I'll refresh, and you can see Tailwind has been successfully installed. You can see there's kind of been a CSS reset applied, where margin and padding has been stripped away, and our font style has changed. Now we're going to come and remove this soon, but just so we can start getting comfortable with the use of Tailwind utility classes, let's go add some simple ones to this heading. Back inside the documentation, let's go change the font size. All I do is simply search font size in the search bar, click the result, and you can see here a systemized table of all the different font sizes. For example, the utility class TextLG has a font size of 1.125 rem, or 18 pixels, and a line height of 1.75 rem, or 28 pixels. Let's go add this text 3XL, which is a font size of 30 pixels. All I do is in the H1, I add a class and paste that utility. Let's go bold the text. I'll search font weight. Here the different utility classes are, with their corresponding properties. Let's give it a font bold, which is a font weight of 700. In the class, I just simply add that. So let's check these out in the browser. Our font size is now much larger and is bold. So you can see how Tailwind's utility classes makes it so easy to style different HTML elements. All right, so looking back at our completed project, the first thing I want to go do is add our main page container. If I open up DevTools and click the device toggle icon, you can see we have this container, which is setting a maximum width for large screen sizes. And as I reduce the width of the browser, the main page container is keeping the content away from the edge of the screen. Okay, so in Tailwind, I'm going to search container. This is under layout. Now you can see there's just one container class. And on the right here, it shows you what's happening at different breakpoints. So for example, at the small breakpoint, that is at 640 pixels, the max width is set at 640 pixels, which means that for our container, the width is set at 640 pixels until we hit the next breakpoint at 768 pixels. So for example, at 700 pixels, which is between these two values, our container is going to have a width of 640 pixels. You can see that anything less than 640 pixels will just stretch the full width of the screen, because the width is set at 100 pixels. Now there's some important documentation on how to use the container. I want to highlight this sentence here. Note that unlike containers you might have used in other frameworks, Tailwind's container does not center itself automatically, and does not have any built-in horizontal padding. And it explains here how to center the container by using this MX auto utility. M stands for margin, X is for the X direction, that is left and right, and auto is the auto value. We're going to be looking at all the different margin properties a bit later, but hopefully this one is fairly intuitive. It's setting an X direction margin to auto, which is something we always need to do when writing our own CSS for a container. Now, as I mentioned earlier, for less than 640 pixels has a width of 100%. Now for my containers, I always like to have a little bit of extra space left and right. So the documentation says we just need to go and add a small padding value. And we'll see how to do this in a second. So first up, I'm just going to copy the container utility class and the MX auto utility class. Inside our project, I'm going to create a new div. I'll add class and paste in those utilities. And I'm just going to put my h1 inside our main container. All right, back on the page, I'll refresh. And you can see our hello world has moved in slightly. If I open up DevTools, you'll see that when I select the H1, the blue box is no longer going right up to the left and right edge. And this shows how our container has been activated. Now, as I mentioned earlier, for smaller screens, less than 640 pixels, the container is going to stretch to the full width of the page. So you can see here at 553 pixels, our H1 is going right up to the edge of the page. Now to fix this, I'm just going to go add some small padding value left and right, just like the documentation suggests we do. So I'm going to go search, padding, I'll click this. Now for padding, there's a whole long list of different sizes. Now the way these are structured is that there's different characters followed by a hyphen and then a number. So let's look at some common padding utilities we're going to be using. Just the value P represents padding on all four sides. The value 0 representing 0 pixels. P followed by X is padding in the X direction, that is padding left and padding right. 0 representing the value left and right. PY is in the Y direction, so padding top, padding bottom. We have padding top, padding right, padding bottom, and padding left. And you can see this pattern is repeated for different values. So for example, P3 represents padding in all directions of 0.75 rem, which is 12 pixels. And we have the same thing for the other padding utilities. For example, PY3 is padding in the Y direction, top and bottom, of the same value, 0.75 rem. And if I scroll down, you'll see we're provided with a long list of values to avoid us ever having to write our own custom CSS. So for example, we go up to the value P96, which is 24 rem or 384 pixels. So this long list of values should cover us for most cases. And just to show you, margin works the exact same way. It's the same notation, but instead of a P, we have an M, where the second character, like X and Y, represent left and right and top and bottom, and the numerical value is the exact same, where, for example, 3 is 0.75 rem or 12 pixels. Okay, let's jump back to padding. I want to go just add a small left and right value, so that's going to be PX, and let's use PX5. That is 1.25 rem left and right. So back inside our project, I'm just going to paste that utility. Okay, let's check it out in the browser. I'll refresh, and you'll now see we have a small padding value, which looks great on small screens. Now this padding value is still being applied on larger screens. You can see it in green over here. Now we don't really need that, and we will be removing this padding for larger screen sizes when we look at responsive design. All right, so let's start working on our main hero section. So the first thing I want to go do is define the height of the hero section, which is set at 100 view height units. So all of this content is above the fold. In Tailwind, I'm going to search height. And the first thing I want you to notice is that these same numerical values are being used for the height property. For example, H3 is 0.75 rem, which is the same value that was on padding and margin. And this is what I said earlier about Tailwind being very systemized. This numerical value 3 is used as 0.75 for different properties throughout Tailwind. I'm going to scroll down, and you can see this hScreen value is the height of 100 view height units. So I'm going to grab this utility. Back inside our project, let's go add the HTML for our hero section. I'm going to remove this h1. I'm going to add the semantic header tag. I'm then going to add a section tag for our hero section. Let's add class here, and I'm going to add the utility hScreen. So this section is 100 view height units. Now, just so we can see it in the browser, let's go add some background color. In Tailwind, I'll search background color. And for now, it doesn't matter what color we use. I just want to be able to see our hero section. So I'll just choose BG Orange 500, and I'll paste that in our class. Okay, let's check this out in the browser. I'll refresh, and you can see we now have our orange background color. And we can see the 100 view height is working because as I increase and decrease the height of the browser, the hero section is stretching the same height. Okay, so let's now go set up the structure for this group text and image. To do that, I'm going to be using CSS Grid. This is a simple grid with 2 columns and 1 row. So to show you how grid works, I'm just going to go grab 2 divs, which will be our 2 grid items. So in the Tailwind documentation, let's now go use this left navigation bar. I'm going to scroll up to Flexbox and Grid, and I'm straight away going to go to Grid Template Columns. So here are all the utilities for setting different columns. Now we're going to use Grid Cols 2, which simply sets 2 grid columns, each with 1 fractional unit. If I scroll down, you'll see that to use this, we also need to use the grid utility to activate grid. So I'm just going to copy this. Back in our project, I'm going to come add grid, and then I'm going to paste in Grid Cols 2. Now, just so we can see these 2 columns, I'm going to cut the BG Orange 500 color. I'm going to come and add it onto this column. I'm going to add another class, paste it, and just increment the value to 600, which will be another shade of orange. So what we should see now are 2 equal columns with slightly different orange background colors. Let's check it out in the browser. So I'll refresh, and you can see we now have our 2 columns, each set with 1 fractional unit, so they're each taking up 50% of the available width. All right, so let's start adding in the content for our hero section. Now the hero section contains 2 images, the logo over here and me standing with my laptop. So the first thing I want to do in our project is create a new folder called Images. Now I've made these available for you to download in the description, and I'm just going to drag them across into the Images folder. So here we have a PNG with me holding my laptop and the future Fullstack logo. So in the left column, we have a logo, heading text, paragraph text, and 2 buttons, and on the right, we have a single image. Now, just so you can follow along, all text content is available in a Google Doc in the description below, and I'm just going to be copying and pasting it from my clipboard. All right, for now, I'm just going to leave these background colors so we can better see our columns. Inside the first column, I'm going to grab the image tag and add the logo by going images/logo.svg, and I'll just give this the alt text logo. The next element I'm going to add is an h1, and I'm just going to copy in the content for the h1. The next element will be a paragraph, and I'm just going to paste in the content. We then had 2 buttons. I'm going to structure these inside an unordered list. It'll contain 2 list items for our buttons. I'll add an anchor tag. As I have no other pages, I'm just going to put the pound symbol as the href value. The text for the first button was get started. I'll copy this anchor tag, paste it in our second list item, and the text over here was learn more. All right, so that's our first column done. For our second column, I'm going to remove the div and just add our image, as that is the only grid item. For the source, I'll go to images, and this is Dan holding his laptop. For the alt text, I'm just going to put Dan holding laptop. Okay, the final thing I want to do is just remove this background color, as we no longer need it. So let's check this out. I'll refresh, and we now have all the content on the page inside our 2 grid columns. Now, our images are obviously way too big, and I also want you to notice our text is the same size and style. Our h1 is no different to our paragraph. So now we need to go resize our images and go apply some text utility classes, as well as make our anchor tag actually look like buttons. All right, so let's first go sort out the sizing of our images. Inside Tailwind, I'm going to search for width. And just like height, we have the same systemized notation, where instead of h, we have w followed by numerical values. For the logo, I want to set its width as 192 pixels, or 12 rem. So I'm just going to copy this utility. Inside the image, I'm going to add class and set w48. I'll refresh, and you can see our image is now a much more appropriate size. Let's go sort out the image of me holding my laptop, as right now it's way too big. Now with this image, I don't want to set a fixed size. I rather want it to be a proportion of the column it is in. So to do that, I want to be using a percentage width value. You can see here how it works. For example, if you want to set a width to 1/3 of a container, you would use W-1/3. Now I want my image to be 3/4 or 75%. I'm simply going to copy this utility here. On the image, I'm going to add a class and paste in that value. All right, let's check it out. So our image has now reduced to 75% the width of the grid column. Next up, let's go and align our grid items. On the left column, our text has been vertically centered, and in the right column, our image has been horizontally centered. So back inside the documentation, I'm going to scroll to Flexbox and Grid, and we know that to center grid items inside grid cells, along the row axis, we're using Justify Items, and along the column axis, we're using Align Items. So let's go to Justify Items. So for Justify Items, we want to center our content along the row axis. So I'll grab Justify Items Center. In our HTML file, I'm going to come and add that onto our main section container, where we're defining our grid. Back on our page, I'll refresh and watch how the image is going to shift to the middle of this column. So you'll see the image is now horizontally centered. Now because Justify Items was applied to the entire grid, the div containing all of this content has also been centered. But it has no effect, because the div is a block level element expanding the full width of the column. Just to show you this in DevTools, if I come and select this div, you'll see that its width in blue is the full width of the grid column. So Justify Item Center is being applied here to center the div, but because the div is the same width as the column, there's no space to move, so nothing happens. Whereas the image, you can see its width is smaller than the width of this column. That is, this grid item has a smaller width than this grid cell. So there is space for this grid item, the image, to center horizontally inside the grid cell. All right, let's go center vertically using the Align Items property. To set Align Item Center, we're going to use the utility class Item Center. I'll copy that and add it onto our grid container. All right, I'll refresh and watch how both our image and div containing all this content vertically centers on the page. Okay, great, this is looking a lot better. Now applying Align Item Center did center both the container, because you can see its vertical height is a lot smaller than the height of the column, and the image, because the image height is also less than the height of the column. That is, both these grid items have a height that is less than their respective grid cells. All right, so next up, let's go handle applying different font styles to our heading and paragraph. So it ends up looking like this. Now the way I want to do this is I first want to go set up our base font style. I'm going to come and add this as a class onto the body tag. This is a fairly common approach, where we come and apply a base font style, which will be applied by default to all text elements through inheritance on the body tag. And then for headings, we go and customize those individually. So back in the docs, let's first go handle the font size. I'll search font size, and I want our base font size to be 18 pixels. That is 1.125 rem. So I'll copy this class. I'll come on the body tag, add class, and paste in that utility. Next up, let's go handle the font weight. I want our base font size to have a font weight of 400, which is just normal weight. So I'll copy this and add it to our class. The final text property I want to add is the color. I'll search color. Under typography, we have text color. And for our base color, I want to use this value of text slate 600. Now Tailwind provides some really nice base gray colors. There's slate, gray, zinc, neutral, and stone. So you have a whole variety to choose from. I'll copy text slate 600 and I'll add it into our project. All right, so let's check this out so far. I'll refresh and you'll see all our text, including the heading, paragraph, and anchor tags, have had those text styles applied because I've added it as a global style to the body tag and it's all been inherited. So our paragraph is done through the base font style, but let's go now sort out our heading. I'll first go back to font size. For our H1, I want our text to be quite large, at 60 pixels. So I'll copy text 6XL. On our H1, I'm going to add a class and paste in that font size. Let's go change the font weight. I want our headings to be bold with a weight of 700. So I'll copy this and add it onto our class. For the color, I want to use a darker shade of our base text slate 600 color. So I'm going to choose 800. I'll copy this and add it onto our class. Now the last thing I want to do is tighten up the letter spacing. I'll search letter spacing, and I want to have a small negative value, like -0.25 rem. So I'll copy this class, tracking tight, and I'll add it onto our H1. All right, let's check this out on our page. I'll refresh, and you can see this heading is looking great. All right, next up, let's go style these buttons. We want them to look like this, where the buttons are placed next to each other horizontally. So let's go first implement the layout and get them next to each other using Flexbox. Inside the documentation, I'm going to scroll up to Flex Direction. Now for us, our buttons are going to be in a row, which is just the default value, so we don't actually need to use a class like Flex Row. But here you can see all 4 Flex Direction values. Now you can see with Flexbox, just like Grid, we need to use the Flex Utility class to activate it. So on the left menu here, you can see Gap. And just like margin, padding, width, and height, we're back to the same systemized approach, where different characters and values represent different directions and space units. Now for Flexbox, I just want to come and add a small gap value of 1.5 rem, which is 24 pixels. You can see gap 6 is the one to use, whereas gap X and gaps Y are specifically used inside Grid. So I'll copy this utility. All right, so in our project, I want our unordered list to be our Flex container, and our 2 list items are the Flex items. So let's go and add a class. I'll add Flex to make this a Flex container, and I'll paste in gap 6. I'll refresh, and you can see our anchor tags are now next to each other, with a small gap value between them. And I didn't need to set a Flex direction, because by default, our main axis is in row going from left to right. All right, let's now go style these 2 buttons. The first thing I want to do is add a blue background color to this primary button. Inside the documentation, I'll search background color. I'm going to scroll down to the blue color, and I'm going to select BG Sky 500. On our anchor tag, I'm going to come and add a class and paste in that utility. While I'm here, I also want to set the hover state. Inside the documentation, I'm going to scroll up to core concepts where it says hover focus and other states. You can see this is really easy to do. All we do is put the word hover with a colon and then the color we want it to be. So back inside the project, I'm just going to copy this. I'm going to add the word hover, add a colon, paste in that style, and just change it to a darker shade of 700. Okay, the next thing I want to do is make the text color white. So I'll search color, text color, and you can see over here, text white sets a white color. So I'll copy that and add it onto this class. Okay, let's check this out so far. I'll refresh, and you can see the button is starting to take form. You'll see when I hover over it, the color also changes. So to finish this off, let's go and add some padding around it and round the corners. So I'll search padding. Now the rule of thumb for button padding is we want our width to be double the height. So I'm going to add padding left and right of 32 pixels or 2 rem, which is this px value here. I'll copy it and add it onto our class. Now half the height is going to be py4. I'll scroll up, and you can see py4 has a padding top and bottom of 1 rem. So I'll copy this and paste it in our class. Now the final thing we need to do is add some border radius. So I'm going to come here and search border radius. I just want a small border radius of say 6 pixels. So I'm going to copy rounded MD for medium. So in our project, I'll just paste that class. All right, let's check this out. I'll refresh, and you'll see our button is now complete. So let's talk about what's happening here, where this padding is kind of overlapping the content above. In the box model topic of the course, we spent some time discussing that when you apply box model properties like padding onto an inline element like this anchor tag, they just apply weirdly. And we sought to fix this. We converted our inline element into an inline block element. So in Tailwind, I'm going to search inline block. This is handled in the display property. And you can see here we have display inline block. So I'm going to copy this class. And just a note, in this display property, you can also see where we're grabbing flex from and where we're grabbing grid from. Okay, so on our anchor tag, I'm just going to come and add inline block. On our page, I'll refresh, and you'll see that fixes the issue. All right, let's now go and style our secondary button here. So I'm going to come and add a class. For the background color, I'm going to use the same slate as we use in our text, but I'm going to give it a lighter color of 400. We'll then do the hover state by setting hover, BG slate, and I'll give it a value of 500 for the hover state. I want the text to be white, so we'll use text white like we used above. And then I'm just going to copy the same padding values, rounded values, and also make it inline block. All right, that's the work done. I'll refresh, and we now have a good-looking secondary button with a hover state. All right, the last thing we need to do on the hero section is just create some vertical spacing between this content by adding in some margin. I'll search margin, and I'm going to use the margin bottom property on our different elements. You can see that's our class here, MB for margin bottom. Inside our left column, on the image, I'm going to go add some margin bottom 4. I'll copy this. I'm going to add the same margin bottom onto our heading. And then for our paragraph, I'm going to add margin bottom of 8, as I want to create more space between these elements and our buttons. Okay, I'll refresh and watch how our content spreads out horizontally. All right, nice. That's our hero section done. So moving across to the completed project, let's now go handle this how it works section. For this section, I'm actually going to be using one of Tailwind's components, so I can show you how that works and how we can go modify it to fit our exact design. In the Tailwind documentation, I'm going to head to Components. I'll click this link here. I'm going to scroll down, and in Page Sections, I'm going to go to Feature Sections. Tailwind gives us a few feature sections we can copy straight into our project, as well as some paid ones down here. For our project, I'm just going to be using this feature section here. If I click Code, you can see the underlying code that will be copied into our project. And I just click this clipboard icon over here. All right, heading back to our HTML file. I'm going to first set up the HTML structure by grabbing the main tag, and then I'm going to grab a section tag for the hero section. I'll then paste in the page section sitting in my clipboard. Okay, so just zooming out a bit, you can see all this code is using Tailwind utility classes to style the how it works section. Let's go check it out in the browser. I'll refresh, and you can see down here, we have the how it works section. We have the feature section from Tailwind's components. So now what we're going to do is modify some of the styles so it better matches the styles in our project. For example, the primary color used here is this purple color, and we want to change that to our primary blue color. Okay, let's work top down and start modifying this component. The first thing I want to do is actually just get rid of this small heading. That isn't really in line with our style, and on the final project, we don't have it. So in the HTML file, I'm going to come here and just remove this H2, which says deploy faster. I'll refresh and you'll see it's disappeared. Now, because that was a heading tag, the component puts this as a paragraph. That no longer makes sense in our markup, so I just want to go convert this to an H2. So you can see here the paragraph. Let's just go convert this to an H2. Okay, I'll refresh and there's no change, but this is now a better markup. So let's now take care of the styles on this heading. We'll go through these utilities one by one. MT2 is margin top 2, which I'm going to leave. We then have this text pretty style. So let's go see what that is. I'll head back to the Tailwind documentation and I'll just search text pretty. So you can see here under text wrap, text pretty sets text wrap to pretty. So what is this pretty value? I'm going to scroll down and you can see it says use text pretty to prevent orphans, which is a single word on its own line at the end of a text block. So this is quite a cool property. You can see this heading, Beloved Manhattan Soup Stand closes. The word stand could fit over here, but to make this text more pretty, the word stand is being pushed onto the second line. And this just looks a lot nicer than having a single word on a line by itself. So I'm going to leave this utility as it is. Now text 4XL, to work out if that's appropriate, let's go compare this to our H1. Over there, we're using text 6XL. So this is actually fine, because we want our H1 to be bigger than our H2, so text 4XL is appropriate. Now the font weight is being set by font semi-bold. I do want to update this to the same font weight we use in our H1, as I like my font weights for headings to be consistent. So I'll copy this utility here, and I'll replace it with font bold. Tracking tight, we also used on our H1, which just reduces the letter spacing. Text grade 900 is the text color, which we do want to update to our text color we set on our H1 of text slate 800. So I'll copy that, I'll remove this and paste it there. Now these two classes here, SM with a colon, text 5XL, and LG with a colon, text balance, has to do with responsive design, so that this heading is responsive. Responsive design is something we're going to be looking at towards the end of this project. And just a note, we're going to have to go make some different elements in here responsive as well. But to make things a bit simpler, for now I just want to ignore it. So in this markup, anytime you see something with a colon after it, like LG colon or SM colon, just ignore it for now. We will be looking at a great length a bit later, but just know for now, this is to ensure our elements are responsive. So let's check out what we've done so far in the browser. I'll refresh, and you can see now this H2 is looking much more like our H1 here. Next up, let's go handle this paragraph. MT6 is margin top 6, which I'll just leave for now. Now in our project, we're setting the base text properties on our body class so that elements like the paragraph will just inherit these. So I'm actually just going to go remove these styles over here. Checking back in our project, this paragraph is now the same style as this paragraph here. So next up, let's go handle the content inside this grid. All right, so back inside our HTML file, let's go identify the different features. I'm going to zoom out a bit, and you can see over here we have this div with the opening tag here and the closing tag here. And this unit contains the content for each feature and is repeated for each feature. Now, before we start playing around with this, there are some HTML elements here which aren't that commonly used. You can see we have this DL tag, which wraps all 4 features, this DT tag, which wraps the icon SVG and the title of the feature, and then this DD tag, which is kind of like the paragraph text. So what are these tags? So let's quickly check them out on MDN docs. The DL tag is the description list element. The documentation says, the DL HTML element represents a description list. The element encloses a list of groups of terms specified by using the DT element and description provided by the DD element. So you can see in this sample markup here, we have a main DL wrapper tag, which is the definition list. You can think of this as like an unordered list tag. And instead of list items, we have repeating groups of DT and DD tags, where DT is a definition term, which in our final design might be more like a heading, and a DD tag, which is a definition description, which in a final page is more like a paragraph. So that's what those tags are. In all honesty, you could just replace your DL, DTs, and DDs with divs. But the reason Tailwind isn't doing that is they want to provide a bit more semantic meaning to this section, because you can see there already are a lot of divs being used for different layout goals. So don't let these more uncommon tags throw you off. Tailwind are just using them for a better semantic approach. So once again, we can see this DT tag contains the icon and the heading text, and this DD tag contains what is like the paragraph text. We will update the actual content of that icon, but for now, let's just go change the color. The color is actually being defined on this div here, where it has BG Indigo 600. Let's go update that to our primary color of Sky 500. I'll copy this utility there. I'll remove this and paste it there. So that will change the color, and the actual icon we're going to go update soon. For this text push to deploy, it's being controlled by the utilities in here. So I'm going to remove this and replace it with text LG. On our H2, we're using 4XL, and for this heading, I want to use a bit of a smaller text size. In the Tailwind documentation, if I search font size, text LG is 1.125 rem, or 18 pixels. Next up, I want to replace font semi-bold with font bold, and then update the text color to the heading text color of text slate 800. So I'll copy that, remove this, and paste this there. All right, let's go handle the DD tag. Because this is still a text element, it is going to inherit the base text properties we set on our body tag. So all I'm going to do here is I'm going to keep margin top 2 and just remove these 2 properties here, and the base properties will be inherited. So let's check this out in the browser. I'll refresh, and you can see how this now compares to the others, where the colors and styles are a lot more in line with what we did in the hero section. All right, let's now just go copy this for the other 3 features. I'm going to zoom out a bit, and I'm just going to copy this entire div and replace it with each of the divs over here. So I'll remove that, paste this there. For the next div, I'll remove that, paste it again. And for the 4th one, I'll remove that and paste it here. Let's jump back to the browser and make sure this worked. I'll refresh, and you can now see all our styles have been applied. So now let's just update the text content. So we have here how it works, and this text content over here. In our markup, this H2 now needs to become how it works. And this paragraph text, I'm just going to replace with what I have sitting in my clipboard. Okay, I'll refresh, and you can see this is now updated. For the feature section, I'm just going to copy what I have in my clipboard. The heading over here is high quality, and the DD, which is like the paragraph text, I'm just going to copy from my clipboard. All right, I'll refresh, and you can see this content has now changed. Now, just to avoid boring you, I am just going to go update the other 3 in the same way. Okay, so in the markup, I've gone ahead and updated all of that. On the page, I'll refresh, and you can see all our content is now updated. All right, so the final thing we need to do for this section is just go update our icons. Now, unfortunately, Tailwind doesn't provide an out-of-the-box solution for icons, so we need to go use another tool. One of my favorite tools is Ion Icons, and we're going to see how easy it is to import them into our project. If I click Usage, all we need to do is copy these 2 script tags and place them near the end of the page right before your closing body tag. So I'm going to scroll down to the bottom of our page, and just before our closing body tag, I'm going to paste these 2 script tags. So this now gives us access to Ion Icons, and let's go now add them into our project. I'm going to click Icons, and for this first icon, I have this play button. So I'm going to search play. It's this one over here. When I click it, you'll see I get this web component code. And all I need to do is copy it and paste it in our project. The current icon is an SVG, which I'm just going to comment out for now. I'm going to paste in our special Ion icon, and let's refresh to see what we get. I'll refresh, and you can see the icon is imported, but the size and color are a bit wrong. Our other icons are a bit larger and are white. So all we do is comment out a class onto this. You can see the original SVG had a size of 6, so I'm just going to copy that inside our class, and the text color was white. So I'm just going to copy that and paste it here. Okay, I'll refresh, and you can see now our icon is much more in line with the original style, and this is looking great. Back in the HTML, I'm just going to go remove this SVG. Now you also could have downloaded this icon as an SVG and done it that way, but the whole beauty of Ion Icon is it gives you this simple web component that's very concise, and it's very easy just to pop on some Tailwind utility classes. Okay, the other icons I have are a magnifying glass, this list, and this piece of paper. So if I search here, search, there's the magnifying glass, list, there's the list, and paper, there's the folded paper. And just to avoid boring you, I'm going to import them into the project and update the styles the exact same way. All right, so I've gone ahead and replaced all the SVGs with our Ion icons, like the magnifying glass for detailed, and added in the same class I applied on the first one we did. So I'll refresh, and our icons are now successfully imported. All right, so that's the How It Works section complete. So far we've done our hero section, and our How It Works section, and our page is starting to look great. All right, so next up, let's go handle the CTA card down here. Back in our HTML file, I'm first going to go set up the HTML structure for this. I'll grab a section tag. Inside the section tag, I'm going to add a single div, which will be a container for the CTA card. I'll add an H2, which has the text, "It's time to boost your career." I'll then add a paragraph, which has the text, "Your new future is one click away." And then I'll just add an anchor tag with the text, "Get started." And I'm just going to put a pound symbol here for now. So first up, let's go handle the different font styling. For the H2, I'm just going to copy the utilities in our H2 in the How It Works section. I don't need margin top. I'm going to copy all of these and just ignore these responsive utilities, and we'll add those in a bit later. So I'll come down here, add a class, and paste in those properties. For the paragraph, I'm actually not going to add any styles because these are all going to be inherited by the body tag. So let's check this out so far. I'll refresh, and you can see down here, the content is starting to appear. We have our H2 and paragraph, which has styling consistent with the rest of the page. Let's now go handle the Get Started button. You can see the background color of the button is white, and the text is blue, which is the opposite of the primary button. For now, I'm just going to copy the styles on our primary button over here. I'll paste it here, and I will come and update this soon once we apply blue background color onto the card. So I'll refresh, and you can see our blue button is down here. Let's go define this blue card. On our div, I'm going to add a class. I'm going to add our primary background color, which is BG Sky 500. I then want to add some width to this card. In the documentation, I'm going to search max width. I'm going to scroll down, and I'm going to set a maximum width of 48 rem, or 768 pixels. So I'll copy that utility class, and I'll paste it over here. I want the corners to be rounded, so I'm going to use rounded-MD, which is the same rounding on our buttons over here. I'm then going to add some padding all the way around the card. I'll use the padding, and I'm going to set a value of 12. P12 corresponds to 3 rems or 48 pixels of padding all around the card. Okay, so let's check out our work so far. I'll refresh, and you can see the card is starting to come together. Let's go fix up some of the styling now, as we want all our text to be white and the button to be white. So what I'm going to do is set text white onto the div over here, so the white color is inherited by our different text properties. I'm also going to come and remove text slate 800 here, as we no longer need that. For the button, I want the background color to now be white, and I want the text color to be sky 500. I'm just going to leave the hover background color as sky 700. All right, so let's check this out. I'll refresh. Okay, this is looking good. I've just noticed a small mistake where this text color should be blue. And that's being caused by not removing this text white property over here. So I'll remove that. So now the color will be blue. All right, this is looking great. Now before we come and center the entire card, I just want to center these text elements inside the card. So to easily do that, on our div, I'm just going to come and add the utility text center, which will center both our block elements, our H2 and paragraph, and our inline element, the anchor tag. Ordinarily, when you apply text center onto an anchor tag, it doesn't work, but when you apply text center onto a parent container, it will center both block and inline elements inside the container. So I'll refresh, and you'll see this is all nicely centered. Okay, so the final thing we need to do is now center this entire card into the middle of the page. To achieve that, I'm going to use Flexbox. I want to center this entire div. So I'm going to add a class. I'll activate Flexbox by using the utility flex. This now makes the entire section a flex container, and this single div a flex item. So by default, our main axis is running from left to right in row. And we know that to shift our flex item along the main axis, we need to use the justify content property. Let's head to the documentation. So I'll search justify content, and we want to center it. So justify content center, where justify center is the utility we want to use. So I'll copy that and paste it over here. Okay, let's jump back to the page and refresh. And you can see now our card is nicely centered. Now the last thing I want to do is just add a bit of margin between the heading and paragraph and button. On the H2, I'm just going to add a margin bottom value of 4, and I'll use the same value on our paragraph. Okay, I'll refresh, and now there's just a bit more extra space in our card. Okay, the last thing I want to do is just create quite a bit of white space between our CTA section and where our footer will be. On the section, I'm just going to add a margin bottom of 64, which is 15 rems or 240 pixels. I'll refresh, and we now have some white space between our CTA card and the bottom of the page. Okay, the final thing we need to take care of is just this very simple footer down the bottom. In our HTML, I'm going to grab the footer semantic element. I'm just going to paste in the content from my clipboard, and I'm simply going to add the class text center to center this text on the page. I'll refresh, and there we have our very simple footer. All right, so this page is now finished for desktop. We have our hero section, our how it works section, our CTA card, and simple footer. All right, so we're up to the final stage of the project, where we're going to make our page responsive. So let's go check out our page at different screen sizes to identify some issues. I'm going to open up DevTools. I'm going to click on the toggle device icon over here. And let's start with the hero section. I'm going to reduce the width of the browser. And you can see this is starting to look really bad. For smaller screen sizes like this, we want our image to pop below. You can also see the font size is just way too big. And because of this layout issue, it's causing issues on the how it works section below, where this is now appearing on top of it. Now the how it works section is actually looking really good. This is because this page section is already built as a responsive design. So there's not much we need to do here. We will take a look at the code to see how this is working. Scrolling down to the bottom of the page, the CTA section, we want to look at reducing some of the padding, as this is just getting a bit too busy. And I'll also want to reduce the margin between the CTA and the footer, because for screen sizes like this, it's just too big. So let's go check out how responsive design works in Tailwind. I'm going to head to the documentation. On this left navigation bar, under core concepts, I'm going to go to responsive design. Looking at this sentence here, every utility class in Tailwind can be applied conditionally at different breakpoints, which makes it a piece of cake to build complex responsive interfaces without ever leaving your HTML. So this is really cool. Every single utility class can become responsive. So responsive design in Tailwind takes the exact same approach as responsive design in Bootstrap. Tailwind has different breakpoints. You can see them in this table here. And just like Bootstrap, Tailwind takes a mobile-first approach. You can see this sentence, by default, Tailwind uses a mobile-first breakpoint system similar to what you might be used to in other frameworks like Bootstrap. So as a quick recap, we always want to start with the property that we want for mobile, which is just applied by default. So for example, let's say on mobile, we want our margin bottom to be 2, so MB2. We would apply MB2 by default, and then say on a large screen, that is when we hit 1024 pixels, we want our margin bottom to increase to 5. So we would write LG:MB5. And what that's saying is that when we hit 1024 pixels, increase the margin bottom to 5. And that will then just apply for everything above 1024 pixels, and everything below 1024 pixels will just be the default margin bottom we applied. So let's now go use these breakpoints in our design. Okay, the first thing I want to do is change our base text to be smaller on smaller screens. I want the default case to be text-MD, so medium text by default. And then when we hit medium screens, I want the text to go large. So once again, on smaller screens, our text is going to be medium. But then when we hit the medium breakpoint, which is 768 pixels, our text is then going to change to large. Let's check this out in the browser. I'll refresh. Now watch what happens to this paragraph text when I go past 768 pixels. So it is subtle, but it has changed font size. All right, the next thing I want to go sort out is that on our main container, the content is butting up right against the left here. For smaller screens, we're just going to go add a little bit of horizontal padding. So here's our container. Taking a mobile-first approach, I'm going to go add some padding in the X direction of 5. When I then hit medium screens, I want the padding to change to 0. So once again, this is reading as, by default, apply a padding of 5, but then when we hit the medium breakpoint, which is 768 pixels, change the padding to 0. That is, remove the padding. So let's check this out in the browser. I'll refresh, and you can see now we have some padding left and right. If I select the div, you can see in green, and go to the box model, you can see the padding of 20 pixels applied left and right. And then when I increase the browser, you can see the padding disappears. Okay, next up, let's go sort out our grid so that the image appears below the grouped text. For our hero section, the grid columns are being set by grid cols 2. I only want our page to have 2 columns at the medium breakpoint. So I'm going to put MD:grid cols 2, which means that by default, for screen sizes less than 768 pixels, because we're not defining any grid cols, it means our grid items are just going to be stacked in a single column. So let's check this out. I'll refresh, and this is looking way better. Our image is now appearing below our text. All right, so next up, let's go sort out this issue here. The reason this is happening is because we've set 100 view heights onto our hero section, and this content is just seeing the 100 view heights. So from the how it works section point of view, it thinks I need to start at 100 view heights, which is actually now overlapping the hero section content. On our hero section, we have this hscreen utility, which is setting the 100 view heights, but I only want that to come on medium screens. So I'm going to add MD hscreen. So what this means is that by default, we don't have 100 view height set, but when we hit the medium breakpoint, 100 view heights is being set. So let's check this out. I'll refresh. So on this screen size, our hero section does not have 100 view heights. So the how it works section just appears below. And then when we go above 768 pixels, the hero section now does have 100 view height units. All right, the last thing I want to do on the hero section is just reduce the font size of our H1 on smaller screen sizes. Our H1 currently has a text size of 6XL. I want this only to start at medium screens, so I'm going to add MD. And then by default, I want our H1 to be 4XL. Let's check this out. I'll refresh. You can see the heading looks a lot better now. And when I increase the width of the browser, it goes back to 6XL. Now, one thing I've just noticed that I'd also like to correct is that on our main container, I'd like to add a little bit of vertical padding as well, so that the future Fullstack logo is not butting up right against the edge here. So I'm actually just going to remove the X, so that's padding in all directions for smaller screen sizes. And then on medium and above, I'm just going to remove the X, so that we remove all the padding. I'll save, let's refresh, and now you can see we have some vertical padding as well. And that padding will disappear above the medium breakpoint. Okay, our hero section is looking good. Now, as I mentioned, the how it works section already comes fully responsive. So let's go check this out in the code. So I'm in the how it works section, and I'm not going to go line by line and show you every single responsive query, as I just don't want to bore you. But let's go identify a few to see how they're working. On this div here, we have text center being applied for large screens and above. This text center is being inherited by our H2 and paragraph. So what this means is that on smaller screen sizes, our text is going to be aligned left by default, and then on larger screens and above, it's going to be centered. Let's check this out. You can see the heading and paragraph are aligned left, and when I increase the width of the browser to a large screen size and above, the heading and paragraph become centered. You can see our H2 over here, by default, is text 4XL, and then when we hit the small breakpoint, it changes to 5XL. Over here, we also have this text balance utility being applied on larger screens and above. Now in the docs, let's check out what text balance is. You can see here, use text balance to distribute the text evenly across each line. You can see in this example here, if you didn't apply text balance, on the first line, this would likely read, Beloved Manhattan Soup Stand, and then the word closes would just be on its own line, looking a bit unbalanced. So text balance nicely distributes the text content onto two lines when the text wraps. Now in our design, this isn't really relevant because our text isn't that long. But if it was longer, I'm just going to copy and paste this a few times. Let's see how this works. I'll refresh. And you can see that how it works is being applied nicely across two lines for larger screen sizes. When I reduce the width of the browser, it just goes back to the default behavior. Okay, I'm just going to change that back. Now there are quite a few instances of responsive design being applied, like over here, down here, and in a few other places. Now from what I've taught already, you should be able to understand what each of these are doing, so feel free to go check them all out yourself. But the main thing here is that a Tailwind section comes responsive out of the box. Alright, the last thing we need to take care of now is the bottom part of our page. All I want to do here is remove some padding on smaller screen sizes and just reduce the amount of margin between our CTA and our footer. So back in our code, I'm on the CTA section. At the moment, we're applying padding 12 all the way around. Let's go apply that only on medium screen sizes and above. And by default, let's just apply padding 4. So let's check this out. I'll refresh. And you can see this just looks a bit tighter. And on medium screen sizes and above, the padding increases. Now, just to show you an example of how you could apply 3 different breakpoints, we could have padding 4 as our default case. And then for the small breakpoint, I'm going to add a padding value of 8. So the way we read this is as follows. By default, we have padding 4. When we then hit the small breakpoint, which is 640 pixels, our padding changes to 8. And then when we hit the medium breakpoint, our padding changes to 12. So in other words, from 0 to 640 pixels, our padding is 4. From 640 pixels to 768 pixels, our padding is 8. And then from 768 pixels and above, our padding is 12. So here's an example of how you can apply multiple breakpoints to your single property. So let's check this out. So on this screen size, our padding will be 12. I'm now going to go to a value between 640 pixels and 768 pixels. So over here, our padding will be 8. And then above 768 pixels, our padding changes to 12. All right, the last thing I want to do is just go sort out this margin. On our CTA section, we're currently applying a margin bottom of 64. Let's go apply a margin bottom of 8 by default. And then for medium screens, we'll change it to 64. Let's check this out. I'll refresh. And you can see on smaller screens, this is a lot tighter. And when I increase, the margin significantly increases. Okay, nice work. This is the project done. You now have an incredibly solid foundation in Tailwind CSS. Congratulations, you've made it to the end and now have a solid foundation in CSS needed to work on professional projects. The next step is to learn JavaScript, which is responsible for adding interactivity and dynamic behavior to web pages, transforming static HTML and CSS into engaging and responsive user experiences. You can join my full JavaScript course for free on YouTube, where you'll experience the same high-quality teaching. Also make sure to subscribe to the channel to stay in the loop with new releases. And if you're serious about learning full-stack web development and interested in joining my bootcamp, make sure to check out futurefullstack.com. See you in the next video.